There's no laws to it. But in my experience, the biggest determinant of what you need is going to be like the due date, right? Because remember, in everything we've talked about, this experimentation, the hyperparameters, the number of calculations we're doing, we've completely ignored the element of deadlines and time, right? There's going to be times when you have to ship a model that you wish you had more time to work on, but you have to ship it because the project manager said so. Like, that's just a real world reality, right? So keep that in mind. Yes, I mean, that's how I would answer you. See, there's many ways to go about it. Just pick one. But most of the time, it'll just be time. Salient says, better architecture comes at computational cost. That sounds suspiciously like, what is that called? An oxymoron, right? Is it better if you have a more computational cost? Like, is it better? Like I said, have we won here? I don't think we've won, right? So that's better in quotation marks. This doesn't feel any better, right? So yeah, Salen, I'd say that you're posing an oxymoron there, right? Sure doesn't feel like we're doing any better. Man, this is going to take a while. And we're basically at the same loss as before. So this is also a good time to kind of illustrate what I mentioned to you guys about early stopping, right? If we know that we can get to a model that gets us to this loss, why would you accept this loss at 6,000 epochs? Like, yes, maybe that could improve, but if that's going to take you another 3 hours to get there, I could run a lot of experiments in 3 hours, right? So this is where you might say, okay, you know what? Let's stop this. Let's move on to something else. Let's stop here. We've reached the best we can do with RNNs. Let's try CNNs. Like, that would be a valid conclusion at this point, right? We would exercise our early stopping decisions, and we keep the results, right? Because we want to document all experiments, but we move on to something else. This is a really good example of that. We're at 8,000 epochs. And granted, that is the lowest loss we've seen so far, right? We've never hit 1251. So kind of, sort of headed in a good direction, but not very fast, right? So something to think about there too, guys. All right, so we covered a lot of ground today, guys. I hope that this has been beneficial in understanding all of the different approaches that we could be possibly using, right? Because there's a lot to it, right? There's a lot of different variations, a lot of different things that can be tried, right? Yeah. So I'm going to let this run in the background, see where it ends up. But I think I want to wrap up here because we've gone for almost 3 hours. But I want you guys to think about all the different things that we've covered today, because that means that next week's lightning round review is going to be very interesting, right? Lots of things to talk about in the review. Feel free to look up the definitions for CNNs and RNNs in the nerd explanations. But the bottom line is that sequence matters. We're going to see that in NLP. You're going to see that in image processing, right? but sequence does matter. Maybe it didn't matter for us in this example because the XOR table is only, 4 inputs, right? Four rows. 4 rows, 2 different classes, right? But you can kind of get a feel for how you experiment your way to a solution, right? Let me know if you have questions in the meantime. But really happy you guys attended. Hopefully you guys get something out of this session. We're also going to be gravitating more towards using some frameworks because we haven't looked at frameworks yet, right? So next week, I promise that we're going to do at least one of these examples with a framework. It's time that we do that, right? It's time for us to leave the raw code and go to the frameworks. And who knows, maybe we'll see better performance, right? In theory, the framework should help you see better performance. So guys, thank you so much. Really appreciate all the participation. Really happy to be spending Sunday with you. In the chats, there is a link to sign up for my data science school. Guys, I'm trying to get to 1,000 signups prior to opening. At this point, it's in danger of me having to kill the project because I'm not seeing the number of signups I'd like to see to have the school be self-sustaining. But if you haven't signed up, please sign up for my data science school. I want to open it by August 1st, but I'll never get to an opening phase if I don't get enough signups, okay? So thanks for being here. Thanks for all the feedback. As always, we live in a very dynamic world. I worry about all of you, so please, take care of yourselves, take care of your families, and I'll see you guys next time. All right, let's get started with our lightning round review for our latest installment on neural networks. I have some questions up on the screen. Now, some of these might look familiar because we did have some of them last week, but there's also a lot of new people in the chat. So why don't we start with these 4 questions? What is a learning rate? Are there different types of neural networks? When would you use each one? What is a grid search? And is every grid search successful? What are some of the frameworks that are used for neural networks? And why do we never use PyTorch? All right. So, those are the 4 questions in front of the group right now. Feel free to put your answers in the chat below. But what do you think? What are the answers that we can put with some of these 4 questions? I'll give you guys a minute to think about it. You don't have to answer all of them. You don't have to answer in order. Just pick one that you feel most comfortable with and go for it. I'm going to have to figure out why the Instagram is still acting up, just like it was last weekend. But we've had a lot of growth on Instagram recently, so I'm going to do a special stream just for them after this. But until then, let's think about these 4 questions. What is a learning rate? Are there different types of neural networks? What is a grid search? And what are some of the frameworks used for neural networks? And by the way, that last one's important because today I do want to focus on using frameworks. We've been using raw code, which is great, right? I'm a fan of that. But let's get a little bit more modern today. We're going to start using some frameworks. So let's see how comfortable you guys are with these 4 questions. What do you guys think? Feel free to put them in the chat. Okay, Starry Vibe says learning rate controls how much the model's weights are updated during training. Okay, yep. That's a pretty reasonable answer. Starry Vibe says, are there different types of neural networks? Yes. Okay, Starry Vibes, give me at least one if you don't mind. Give me at least one. And if you're too shy or don't know the answer, you can just say, I agree with Starry Vibes, I disagree with Starry Vibes, whatever you guys want here. Okay, Manoj says, grid search, tuning hyperparameters by exhaustively trying combinations from a predefined set of values. Grid search is tuning hyperparameters by exhaustively. Yeah, that's a pretty good definition. What do you guys think? Yassine says yes. For number 2, he says yes. There are many types of neural networks, like RNNs, CNNs. We use each one depending on the data and the problem at hand, and more specifically, data dimensions. Okay. I like that, Yassine. I like your answer. We're gonna come back to it because I like the way you closed out the answer there. Denelson says a learning rate is how fast or slow a model learns from its epochs. It can either take big steps or small steps after each epoch to find a minimum. Okay, Denelson. So Denelson, is it more desirable to take smaller steps or bigger steps? Because you say what it can do, big steps or small steps, but that doesn't tell me which one is more desirable. What do you think? Okay, Starry Vibe says for the different types of neural networks, CNN, FNN, and GANs. FNN. Did you mean to do FFN, maybe? I don't know of an FNN, but maybe I'm just wrong. But I think you meant FFN. And then also Starry Vibes mentions GANs. So that's an interesting mention. So if anybody in the chat, what does GAN stand for? We haven't seen that one yet before, right? We haven't seen that one. So if somebody wants to give me the definition for GAN, G-A-N, go ahead and put it in the chat, okay? Michael says, happy Sunday, Dennis and Eric. Michael, so good to see you. How are you, our good friend? Michael, I believe that you are from Nigeria, so welcome back. Glad you're here, my friend. Yassine says, grid search is a method to experiment with different combinations of hyperparameter values. Yeah, I like that. Yeah. Okay, Starry Vibes is a feed forward neural net. Okay, yeah, so I guess it would be FFNN, wouldn't it? Because I said FNN. No, I said FFN. But yeah, okay, Starry Vibes. So you were, I got what you were saying. I just, the acronym FNN, I don't think I've ever come across. But thank you for that. So for the definition of GAN, Yassine is posting generative adversarial networks. Okay, cool. So I'm going to take a small diversion here, guys. Because we are not going to learn about GANs today. I have that planned for next weekend. Or next Sunday, I should say. And the reason I say that is because I'm not sure if GANs are its own neural network as much as they are a neural network architecture. And I think that distinction is important. I would argue that it is an architecture, not a type of neural network. If you guys have done a little bit of work with GANs, you might understand what I mean by that. If you don't understand what I mean by that, that's okay. We're going to cover that much more in depth next week. But for today, for those of you that do know what GANs are, I would propose to you that they are not a type of neural network, so we actually won't be focusing on it today. Okay? And hey, I'm happy to be wrong on this. If you guys, I'm open to debate. If you guys want to tell me otherwise, feel free to do so in the chat, okay? So Ayush, our new friend Ayush says neural network frameworks is TensorFlow, PyTorch, Keras, and JAX. Okay. I'm familiar with the first 3, obviously, but not JAX. So somebody wants to fill me in on JAX. Give me the elevator pitch on JAX there. I'd appreciate it. Denelson says, yes, there are different types of neural networks. There are models like CNN, RNN, LSTM, so on, can be most effective with data that are close to a time series, where CNN can work best with images. Okay, Denelson. So remember how I said that Yassine had a very interesting way of closing out his definition of these neural networks, right? So last week we talked a little bit about this, about how people say, "Oh, RNN, that's for time series." Well, no, it's for data that's in it's four-dimensional data, right? It just so happens that time series is data in a single dimension, right? Because you can say that the series matters and the ordering and the previous inputs can have an effect on future inputs, so on and so forth, right? So I'm encouraging you to think about it in terms of the dimensionality of the data rather than, oh, it's time series. Because the same thing for CNNs, right? CNNs, people always say, oh, that's what I use for my image processing. It's good for images. Well, no, it's good for dimensional data, but that's multiple dimensional data, right? Because it's not a single pixel in a picture, it's a pixel that's surrounded by other pixels, right? So, like, in layman's terms, those edges and those connections count, right? It's important that this pixel is above this pixel, but to the right of this pixel, and then also below this one, right? But that's not an image, that's multidimensional data, right? So that's where I'd like for you to think about it, Denelson. So again, look back at Yassine's answer, because we need to kind of keep that in mind, that all of the YouTube tutorials, the fake influencers, all the idiot influencers, they always say, "Oh, use this for time series." Well, but that's kind of an ignorant statement, right? It's not that it's time series; it's that it's single dimensional data or multidimensional data, right? That's really kind of what we want to know. Because remember, the neural network, the algorithm, it doesn't know it's dealing with time series. It doesn't know it's dealing with an image, right? It's all math to that, right? So keep that in mind, guys. Single dimensional data versus multidimensional. Ayush, we're going to come back to your question, okay? Manoj says generative adversarial network is the workflow or architecture. Yeah, Manoj, I would agree with that. And again, guys, if you don't understand what Manoj means by that, that's okay. That's okay. You can still stay. But next week, we're going to talk a little bit more about that. Let me read ahead here a little bit. Okay, so Starry Vibes says 3. 3, is every grid search successful? No, it can get stuck in local minima. That's right. The local minima is one of the many problems a grid search can have. But what we really should remember is that not every grid search is successful. Not every set of experiments is successful. So if we go to our terminal window, some of you guys might remember this, right? We worked on this a couple of weeks ago, right? Hold on a second. That's not refreshing. Give me just a. There we go. You guys might remember this. Who remembers this, right? Remember this terminal output? Remember how slow it was? We actually had to cut the session short because this was so long, and this didn't finish by the time we finished our session. And this is a terrible model, right? But it was a grid search. It was a lot of epochs. It was supposed to be a better architecture. I believe this is an RNN that we did, if I remember right. But wasn't successful, right? And not to get on a tangent here, but this is one of those things that I kind of have trouble with machine learning in general, or AI in the public eye and things like that, right? Everybody assumes that machine learning can solve everything, but that's not always the case. Machine learning models at the end of the day are still math formulas, right? It's all still numbers based. So that doesn't mean that every single attempt you do is going to be successful. So going back to Starry Vibe's answer, it can get stuck in a local minima, right? There can be other problems with it too. But not every grid search is successful, guys. Just because you run 1,000 experiments doesn't mean like you have to get a positive result. You have to be willing to say, we ran the experiments and we couldn't get there. Lots of companies are unwilling to do that. All right, let me go back to my deck here. All right, so Denelson says, when it comes to learning rate, there is no learning rate that will be effective. DS experiments to determine if their model needs to take big steps or small steps to find the minimum, nitty gritty. Yeah, Denelson. I like the way you put that. Thanks for that. And I think you're on the right track there. Thanks a lot for that. Yes. Yassine says, yes, I can see the argument for that. It's not manipulating the node calculations and processing method. It's just structuring the existing types of neural networks in a way to achieve a certain objective. Yeah, Yassine, I think you're talking about the multidimensionality of it all. But yeah, I mean, I like how you mentioned the node calculation, because again, guys, remember the neural networks are math representations of the brain. That doesn't mean it's thinking. It doesn't mean that like it's, you know, sentient or making decisions on its own. It's just picking the best result from what the math says, right? And we're going to see a little bit of that today. So remember, the model doesn't know what it's working on. The model just knows the numbers. That's it, right? Denelson says, grid search is a way for us to automate experiments with different configurations for hyperparameters so we can find a good enough model and then retrain the model and further tune it. Yeah, I like that, Denelson. That's a pretty good definition there. Denelson says, there are frameworks that we can use for neural networks. The two most popular are Keras and PyTorch. We use Keras and not PyTorch because we have families that love. Okay, so Ayush, our new friend Ayush, says, why do we never use PyTorch? Because of production challenges it has. Not sure about it, but curious to know more about why. So Ayush, I would like for you to encourage you to read Denelson's answer. PyTorch is only for people who didn't grow up with a father in the home. So if your father went out for cigarettes one day and never came back, Ayush, you're welcome to use PyTorch. That didn't happen to us, so we're going to choose to use Keras and other frameworks that, you know, make sense. But Ayush, the decision is ultimately up to you. But Denelson, thank you so much for showing that it's not your first rodeo. Denelson understood the assignment there. Yassine says that he was referring to GANs. Okay. Yeah. Okay, Yassine, sorry about that. Yeah, I see it now. And Yassine, you're 100% right. That the argument that I was making is that it's not a type of neural network, it's an architecture. And yeah, you're modifying the structure of it all to get to a desired result, right? And really to say a desired generated result, right? But yeah, Yassine, we're on the same page there with the GANs. Okay, cool. Are there any last answers or any last questions on this deck before we move on? Or excuse me, on this slide before we move on? Ayush says, what an analogy. Ayush, I do my best to teach you guys serious, right? But at the same time, you know, we can always have a little fun. And like I've always said, for full disclosure, I am one of the moderators on the Keras mailing list, so I am a little biased. I fully recognize my bias. But my parents aren't divorced. I didn't grow up in a broken home. What can I say? I like Keras. Yush says, I love it. Well, thank you, Yush. If you love that, then you're gonna fit right in. So just keep on coming back. All right, let's go to the next one. So we already had Starry Vibes mention feed-forward neural networks. And by the way, guys, I assume that most of you are already going to know what's on these slides. But for some reason, I just felt like I needed something where we actually state it so that we as the group can have a collective understanding of what we're talking about when we're talking about these feed forwards or these RNNs, CNNs, and all that, right? So these are the general definitions or general guidelines that I'd like for you to keep in mind. So feed forward starts from your input layers and makes a pass through your output layers, and that's it, right? It doesn't go back and try to make changes and adjust and take information that it's learned and make adjustments to previous layers and all that. It just goes in one direction, feed forward, right? Pretty easy. All right, recurrent neural networks. It maintains a memory of previous inputs so that it can create a context for itself. You'll notice that I said, and I chose my words carefully here, tends to do well with time series data. But as I prefer to say, it's also sequential data with a single dimension, right? We're basically saying that order matters. The order in which I'm giving you the inputs matter. That's basically what you're saying with an RNN. It just so happens that time series also shares that quality that the order matters. But remember, the model doesn't know you're giving it time series data, right? So we got to think about it is that RNNs do well with sequential data in a single dimension, right? So keep that in mind, okay? And if you want to actually think about this a little bit further, what else is data where the order or the sequence matters? What else? Think about that. Let me know in the chat. What else is out there where sequence matters? And also keep in mind, I chose the tends to because again, there's no rule that says you have to do this. Too many of the idiot influencers out there are, oh, it's time series. Oh, we must use an RNN. You don't have to do anything. That's part of the experimentation of life, right? Experimentation of data science. Maybe a feed-forward neural network will work just fine. Or if we go back to our previous example, right? We did do an RNN on this data and it performed horribly. What are you going to do then? Just stop because, oh, well, it's time series. We have to use RNN. No, you don't. You can do whatever you want. Right? So keep that in mind. So for my previous question of what else is sequential data with a single dimension, Yassine says NLP. That's right. Text data, right? Text data is sequential. It matters where you put the words, right? You can't just output all the words of a sentence, even though every single word is correct and fits the sentence. The order in which they're in matters, right? So yeah, Yassine's right. Text data is sequential, arguably single-dimensional data, right? So I'm using it again to reinforce that sample. Don't get stuck on RNNs for a time series. It can be for anything you want it to be. It tends to do well on time series. It's best with single-dimensional data, but you never know, right? Manoj says, agree with Yassine. Yeah, Yassine was right on that, right? And by the way, guys, if you're feeling shy or don't always know the answer, feel free to do just as Manoj did and say, hey, I agree with so and so, or I disagree with so and so. That's okay. You don't have to give a long answer everything. But again, right? It's not that it does well for time series, it's that it does well on sequential single-dimensional data. And there's a lot of other sequential single-dimension data that you can come up with out there besides time series. Okay? All right, next one. Convolutional neural networks, or CNNs. So this also tries to create context, but it just does it with more inputs. So it assumes that whatever data you're giving it is part of a grid. So it wants to take all the edges into account, right? So if single dimensional sequential data is just on one plane, CNN says, well, wait a minute, you could have multiple planes. So I want to know not just what's beside it, but what's on top of it, what's the diagonals, what's on those edges. And it just so happens that that's also convenient for pixels, right? Pixels have edges. You can't just have a jumble of pixels. It matters that this pixel is above this one, below this one, to the left of this one, diagonal of that one. It's this color, whereas the one next to it is another, right? Like, it matters. So CNN takes that into account. But again, the neural network does not know any of that, so it does well with sequential data with multiple dimensions. That's really the takeaway there. And again, I'm sure that there are other examples for sequential data with multiple dimensions that go beyond pictures, right? There could be other things out there. All right. Let's go to the next slide. I thought I'd bring this up because I thought this was kind of funny. But what is this trying to capture, guys? What makes this meme funny? Let me know what your takeaway is on this one. I'll give you guys a minute to think about it. Go ahead and tell me in the chat. Yassine says, if I can share an example we worked on to emphasize the idea that it's essentially about the dimensions. One time we used CNN to classify the problem type behind missing data in tables. Okay. Yeah, I could see that, Yassine. I could definitely see that. There could definitely be reasons why you'd want to do that, right? If you're trying to fill in or classify why you had missing data in a sequence, yeah, that would be very good, right? So thank you, Yassine. Appreciate that example. Fabrizio, welcome back. How are you, Fabrizio? Hope you're doing well. Fabrizio says, I think you need to feature engineered data before sending. If not, we cannot explore fully the patterns on the net. I think you need to feature engineered data before sending. If not, we can explore fully the patterns on the net. I'm going to assume you mean the patterns on the neural network. Fabrizio, I'm going to say that your statement doesn't hold for a lot of scenarios. Today we're going to focus on image data, and I would say that image data is one of those, right? You don't tend to have too much feature engineering on image data. You would also say the same for like audio data, right? Or signal processing. You actually kind of don't want to have a lot on those types of scenarios, right? So in some scenarios, I would agree with you, but you can still do a lot of learning and a lot of exploration without any feature engineering. I actually had this conversation with one of my clients recently. I'm giving him private NLP lessons, like private tutoring lessons. And one of the beauties about NLP is that like there's a lot of pre-processing that exists for NLP, but there's no rules that you have to use it. There's no rules whatsoever that you have to use it. You can do whatever you want with the pre-processing. I don't want to talk too much about the project, but I worked on a project where I wanted to keep emojis. Like I treated emojis as like text or as communication, right? Like you wouldn't say that for every project, but like there's no rule around that, right? So I understand the spirit of your point, Fabrizio, but that's not always the case. You can do a lot without any engineering, and in some cases, you don't want to do any data engineering, or excuse me, feature engineering, right? So keep that in mind. Keep that in mind, guys. There's no rules when it comes to that. You can make that part of your experimentation. You know, like I've done NLP projects where you can say, I got these results by using this stemming approach, but I got these other results by using a different stemming approach, right? You can do that, but you can also do none of it if you wanted to, right? So it's all part of the flexibility of data science. Okay, so coming back to the meme that's on the screen, Michael says overfitting, I believe. Osama says overfitting. Denelson says, I believe that it will just remember the data and not train properly. I was a bit confused when it was posted. Yeah, so all of you are on the right track, right? And I think it's basically making fun of a lot of the AI companies where, you know, they're claiming these ridiculous accuracy numbers and, you know, test scores and things like that, because they're just, you're basically almost not inferring anything anymore, right? It's not an inference if it was part of your training data, right? So I thought this was funny because that's kind of like the approach a lot of the AI companies are doing, right? Where, well, we don't want to guess. We'll just try to get every single document out there and put it in there. Well, I mean, that kind of sort of can work until it doesn't, right? But I thought this was funny, so I thought I'd put that out there. All right, guys. So here's what I want to cover today. This is my coming up screen because this is what I want to work on today. We are going to work on an exercise for image recognition. We're going to use a modern framework, right? Up till now, we've been asking ChatGPT to give us raw code for our neural networks, and that's been a lot of fun. That's been very effective in helping us kind of take things apart and understand how they're working. But that's not how you'll be doing it in real life, right? In real life, you'll be adopting whatever neural network framework your team is already using, right? Most teams tend to adopt a single framework. We're going to use a CNN because we are going to be working with multidimensional data, not images. We are working with multidimensional data. We're also going to conduct a grid search. We're going to run some experiments, right? Basically with our grid search. We're also going to utilize a dropout rate. We haven't talked about a dropout rate. So in the chat, for extra credit, if you guys want, let me know. What's a dropout rate? What's a dropout rate? Let me know. We haven't discussed it at all. It just hasn't come up, but that's okay. It's going to come up today. The dropout rate is a really good example of something that is made easy by the modern frameworks. And we're also going to get away from like these binary type of decisions, you know, because basically we've been like 1 or 0 has been our output, right? And we're going to see what it looks like to have multiple nodes in the output layer, because most neural networks that you'll work on, or a large number of them, aren't going to be binary yes or no, true false decisions. You're going to need multiple nodes in the output layer. And in some cases, you're going to have a lot of nodes in the output layer, right? So yeah, what do you guys think? Let me know if you know what a dropout rate is. Put that in the chat. And yeah, while you're thinking about that, let me focus on the dropout rate. So, because Starry Vibes has already given an answer. Starry Vibes says, I think it's used to reduce the complexity of the model. What do you guys think? Does anybody agree with Starry Vibes? Yassine says, what percentage of nodes to turn off in each layer? Okay, why would you want to do that? Why would you want to do that, Yassine? Denelson says, I have defined dropout rate as the proportion of nodes that my model will sleep to help with the complexity of the model. Okay. Denelson and Starry Vibes, maybe you guys can give me a definition for what you mean by complexity of the model, because that's where I'm stuck. I think you guys are generally on the right track, but you're losing me at complexity of the model. Osama says it's a regularization technique used in neural networks to prevent overfitting. Aha. Overfitting, right? I mean, that's pretty important, right? You know, just as we talked about on our previous meme, right? You don't want to get everything because then you're just overfitting, right? So how do we account for overfitting in our models? Like how are we going to prevent that ourselves? Right? Kind of an important discussion. Manoj says used to prevent overfitting. Yeah, yeah. See, so Starry Vibes and Denelson, that's kind of where you lost me because I don't view it as complexity. I view it as the overfitting. Right? So Manoj says agree with Osama. Yeah, and Manoj, I think Osama would also agree with you. Yassine says, I want to do that to make sure the model does not unnecessarily focus on the very small details. Oh, Yassine, but what is small? What is small? The neural network doesn't know that, right? The neural network doesn't care. Yassine, buddy, I love you, but I'm not on board with that answer. Starry Vibe says high complexity is more flexible but risks overfitting. I'm not sure if I associate complexity with overfitting though, Starry Vibes. Complexity is going to affect your speed, the size, like the physical size of the neural networks, but overfitting, I don't know about that, Starry Vibes. Denelson says we use dropout rates so that we can help our model nodes don't grab all the information. Not information can be best. That can help us with reducing overfitting. Okay. So Denelson, I think you're putting forth a very reasonable definition there. So here's how I like to think about it, guys. Remember how we've talked about that a neural network is a mathematical representation of the human brain, right? That's the base definition we've established. So when I think of a dropout rate, I think of those times when you're just like, oh, wait, what was that? What was that person's name? Oh, wait, where did I go on vacation that one time? You forget things, right? We talked about those synapses and all the links in your brain. Sometimes those links don't work, right? Sometimes things just kind of get lost, right? So a dropout rate simulates that in training, right? Because it's a training hyperparameter, right? You really wouldn't need it at runtime. And that's where you simulate nodes dropping out, because that kind of simulates a little bit of a memory loss, a little bit of just like times when like your brain has to think about other, oh yeah, now I remember it, right? Has to find other patterns or other connections in your brain and in those connecting synapses to be able to say, oh yeah, now I know the answer, right? That's basically what a dropout rate is. It simulates that. It says, okay, this training round, I want to shut off X number of nodes or proportion of nodes. And that way the network has to kind of retrain itself and say, oh, here's what I need to do to get to an answer, right? So that's really how I think about it. The benefit is that it prevents overfitting, right? Why? Well, because it has to find other ways to an answer, right? And you're forcing it to adjust. You're forcing it to say, okay, yeah, well, in times when you don't know this, or in times when you get a bad answer here, make sure you find an answer by going over here, here, and here, right? So that's basically how I think about a dropout rate and the benefit of it. Because you are preventing that overfitting, because now when you present data, it's kind of sorted to a different neural network every time because different nodes will be shut off, right? Same proportion of nodes, but that's kind of the point, to help you have different neural networks answering the same answer on the same data. Manoj says, I feel complexity can be addressed as high dimensionality, open to being wrong. Manoj, I want to credit you for saying open to being wrong. I think that's a very healthy attitude for a data scientist to have. So good for you, my friend. Complexity can be addressed as high dimensionality. Um, sure, sure. High dimensional models tend to be complex. Um, so I agree with that, but it's not the only source of complexity. Remember how we talked about the neural network architecture can be whatever you want it to be, right? There's different implications of your choices, right? If you need it to be a fast neural network, or it can be a little slower, or you're going to have a lot of hardware, you're going to have a little bit of hardware. There's implications to those choices, but um, complexity can also be addressed or created by the architecture that you choose, right? So I think you're on the right track overall there, Manoj. Fabrizio says the model becomes more resilient and flexible. Drop rates, the dropout rate is the fraction of neurons randomly set to 0 during each training step. Yeah, that's reasonable. Yeah, guys, and if it's very important how we express ourselves, right? So one of the things I always tell my clients or my beginners is always, it's not fractions, it's not percentage, it's proportion, right? If you want to sound like like a professional statistician or professional data scientist, we use proportion. So keep that in mind, guys. It's just one of those things that when I learned that and when I adopted it, it felt like it elevated your career, your status, right? We don't say fractions, we say proportion. Osama says turning off parts of neurons during each training iteration. Yeah, Osama. I think you're on the right track there, in line with all the other items. But again, guys, just remember, it's just another extension of simulating the human brain. The human brain is not perfect. You're going to forget things, right? But your brain doesn't say, "Oh, I forgot that. I'm never going to think about it again." Your brain finds other ways, other connections, right? Same thing. Same thing. All right, guys. So number 4, I want to talk about real briefly. We're going to have multiple nodes in the output layer. Because if you remember before, we were using our XOR, right? We were using our XOR table as our data to be able to say, hey, this is the input and this is the desired output, right? 0, 1, 1, or 0. So that's basically a binary output. And we were only getting one probability, right? This probability here that tells you whether it was 0 or 1. So here, this is telling you it's 998. That means it's closer to 0. That's closer to 1, excuse me. So the likely answer is 1. Here, it's 0.004, which is close to 0, which means that the likely answer is 0, right? But what happens when we go beyond ones and zeros? It's kind of important, right? So when would we need to do that? We are going to work on what is known. By the way, guys, I'm sorry if I'm mispronouncing this, but I've always referred to this as the MINCE data set. Maybe I'm wrong on that. If somebody wants to correct me on that, but I've always referred to it as MINCE. If you've never heard of this data set, it's basically a collection. Oh, actually, no, let me increase this. Sorry, guys. It's basically a collection of images. And those images are handwritten numbers. So what we're going to do is we're going to take, this is going to be our data, and we are going to create a neural network to determine an input picture and say, what number is this? Right? So, taking everything we know about neural networks and all that, how many nodes are going to be in our output layer? We want to keep an open mind to what our architecture is going to be and all that. But one of the first things you should establish in a neural network design is your output layer, right? Because that gives you an idea of the complexity and the time it's going to take you, all that stuff. Put it in the chat. How many nodes are in our output layer? All right. So Yassine, Starry Vibes, Denelson, Michael, everybody's coming up with 10. Okay, why? Denelson says 1 for each type of number. That's exactly right. Thank you, Denelson. That's exactly right, guys. So if that's not clear to you, we're basically saying we're going to have a neural network. And these are the possible results from that neural network. Or as Yassine says, we have 10 classes, right? Each one of these numbers represents a class, right? So we have to assign a probability to each one of these classes based on what our neural network knows. So speaking of complexity, right? You, as the data scientist, should immediately be aware that, hey, this is going to be a little bit more complex than your average model, right? Because if you're going to have 10 outputs, that means you're going to have a fairly sizable model, right? Because, 10 outputs, you're unlikely to reach a good answer with only just a couple of layers. You're probably going to need multiple hidden layers. Each one of those layers, you generally want them to be bigger than the number of outputs. Maybe just as a starting point, we'll use 30 nodes. I mean, I'm making that up because any answer is valid, right? So right away, you should be knowing, oh, wait a minute, this is going to be a serious effort, right? Some of the biggest models that I've worked on, I think, have been up to like 46 or 48 different classes, right? Which is a lot, right? You know that you're going to be investing into a serious model when you're doing that. But I'm bringing this up because these are the types of like mental calculations that you can make just by talking to stakeholders, just by sitting in general meetings, right? You don't need to code everything out. You don't need to, run experiments. This is more about like just kind of like the experience side that you develop as a data scientist to say, wait a minute, there's a big difference between me developing something that has 3 or 4 classes versus 15 classes, right? I mean, think about what this looks like for the American, or rather the English alphabet. English alphabet has 26 letters. So now you're going to have 26 classes, right? So what does that look like? Well, that's a big network, right? So I'm encouraging you to kind of think about it in those terms, because this is how you can come up with like ballpark figures to know like, okay, wait a minute, that's going to be a pretty significant effort. I need to be careful here on the questions I'm asking and make sure I have enough data, because the more classes you have, generally speaking, the more data you need, so on and so forth, right? So keeping that in mind, we're going to be working on a neural network that most likely will be image data, which most likely, or we'll start with CNN. We're going to use a modern framework instead of raw code, and we know that our output layer needs 10 nodes. Okay? Are you guys with me so far? If anybody's lost, that's okay. Let me know in the chat. But otherwise, let's go ahead and start going into ChatGPT and start building out this sucker. All right. So give me just a second, guys. Let me bring up I guess we're ready for the web. Oh, wait, we are in the web interface. Okay. I think we are going to stay with O4 Mini. O4 Mini has given us pretty reasonable results so far. And I point that out, guys, because we've been using 4.0 a lot for our coding, but 4.04 Mini is not too bad. So let's just keep going. In this scenario, we're going to assume that ChatGPT knows about the MINTS data set. It's a fairly standard data set that's used by, a lot of people, a lot of training. So we'll just kind of start building our prompt from there, okay? So Oh, you know what? Let me increase that. Sorry, guys. So we're going to specify that we want it in Python. We're going to specify that we want to use the data set and that we want to start with a fairly simple example and then we'll build it up. I believe that Mince is already built into Keras because Keras does have some sample data built in. So we're going to go ahead and ask it to use it. Use the Mince data as available in Keras. Mince data set. So yeah, let's start here. I'm tempted to prompt it a little bit more, but we can make adjustments later on. But let's see what it gives us as a first pass. I was thinking because I wanted it to kind of maybe break out the training versus the prediction cycles, but let's see what it gives us. All right, so here's a simple Keras example. Okay, yeah, so it does have it. If you notice, it's making a call to Keras dataset minced. It's giving us our training and our testing data. Yep. It's going to use accuracy as the main metric. It's going to do 10 epochs. Okay. So this looks like a reasonable example. Let me go over here. We're going to start a brand new new sheet or new code, and we're going to call this NN4. We're going to put it in here. 54 lines. Wow, 54 lines is pretty good, guys. So this is a fairly simple example. I think ChatGPT did a good job of keeping things easy for us. So we're going to go this line by line just in case anybody is lost. But basically, here we are breaking out our training and our test set, right? You always want to have something that you're training on, and then you want to have your test that you're testing against, right? Here, it's going to go ahead and take and make those images flattened out into 28 pixels by 28 pixels. And that way it gives you a vector length of 784. And then it's going to go ahead and normalize the pixel values to 0 or 1. In other words, it's going to turn it into a black and white image, right? That's essentially what you're doing when you're saying, don't give me the color, just tell me if it's black or white. Or, you know, shading light or shading dark, and then turn it white or turn it dark. And then here we are going to go ahead and we're turning it to one hot encoded vectors. At line 20 is where the magic begins, right? Because in line 20 is actually where like the work happens. This is our input layer, and then these are our 3 hidden layers. That's what it's recommending. It's recommending 3 hidden layers. One of them is going to be 256, one of them is going to be 228, and then here In the output, it's, excuse me, I meant to say two hidden layers. The last one is the output layer. And the output layer, it knows that the number of classes it needs is 10. Yep, it established that up here. I don't know why it hard coded that. That's weird. It could have found that in via other ways. And then it's gonna assign an activation function to those final nodes, right? And with softmax, if you guys remember, softmax is what? Is softmax a step function, or is it more of a gradient function, like a sigmoid function? Let me know in the chat. What do you guys remember about softmax? Is softmax a step function or a sigmoid function? Excuse me. Let me know in the chat. And then the compile is what actually puts the entire neural network together. The compile is a Keras call, if you guys haven't seen that one before. And then these are our training parameters. The fit is the Keras method that actually does the training. Here's where we're putting in our epochs. We're putting in our validation split, where we're saying withhold 10% of our records for validation. And then here is where it actually gives us the results. Right? So I think this is pretty good code ready for us to run. We don't have these though. We don't have NumPy or TensorFlow or Keras. So let me go back to ChatGPT and figure out the imports that we need. Or the pip installs, I should say. Pip install TensorFlow, that should be it. Okay, so that's pretty good. All right, let's go ahead and do that. What the heck? It couldn't find one. Okay, that was weird. Let me upgrade my pip just in case. What is going on? I think I could just probably do Keras instead. Let me just do that instead. ChatGPT might have made a mistake in telling us to install TensorFlow. Let me know what you guys think about that. That was a weird error. But let's go ahead and try to run this. So Python nn4.py. No module name TensorFlow. Okay. Okay, that's weird. Fabrizio says maybe the name is different. Yeah, I think you're right. So let me show ChatGPT the error. Oh, right. The Mac OS is might be part of it. Or not. Wow. I feel like we had this error before, chat. And I want to say it was related to the version numbers. Does anybody remember that? JR, I think you're new here. Welcome. JR says virtual environment. No, well, I mean, it is a virtual environment, but I'm using Conda. Guys, maybe some of you remember this because I know we've used Keras before. I think we had to downgrade our Python version, didn't we? Wasn't it something like that, guys? Does anybody remember that? I want to say it was related to our Python version. This is weird. Let me follow everything that ChatGPT says. Okay, setup tools wheels. Now we can try Mac OS again. Nope. Metal is also not gonna go. So let's show that to ChatGPT again. Yeah, it supports 3.11. Okay. Yeah, that was the answer last time, chat. I tend to lean towards the latest version of Python, which doesn't always agree with Keras, which is kind of weird, right? So we're gonna have to downgrade our on our environments. So I just want to be reminded of what that command is. Yeah, conda create and into, yep, okay. So let's go ahead and fix that in the terminal. So we're gonna say, we're gonna deactivate this. We're gonna create a new one with Python 3.11. We're gonna name it NN2. So that looks good. All right, cool. So now we're gonna go to conda, activate NN2, and we're gonna go to the initial recommendation, which was pip install TensorFlow. Okay, so that's gonna work. So guys, I'm not in agreement with it, but apparently, you know, the libraries don't always support the latest Python version. So if you're not aware of what just happened, I created my environment in Python 3.13, which I think is still the latest release. But that was causing problems with the latest versions of Keras and TensorFlow. So we had to downgrade our Python by creating a brand new environment, right? Separating that out from our other work, create a new version in Python 3.11. And now the TensorFlow install works just fine. So now, if we go back and we run that same Python file, the code that ChatGPT gave us, this should work here. So it looks like this is going to go. Okay, so there we go. So now we're running through our epochs. So if you guys have never seen it before, everything you're seeing right now with the epoch list and the steps and the accuracy and all that, that is all a function of Keras, right? This is kind of like the value add that you're getting from working with an environment or excuse me, a modern neural network framework, where it will give it to you and say, okay, well, here, now let me take over. You told me what architecture you wanted for your neural network. And now I'll take over and I'll do all the math, all the different changes and arrangements and all that. And it'll do it internally within the library, right? Because remember, if we go back here, we can see that our code is only like 50 lines. 50, this was an optional one, right? But it was only like 46 lines for the entire, like the base of the code, right? So pretty reasonable, right? Pretty reasonable to bring in that framework and have to deal with a little bit of setup and a little bit of overhead, but it really just kind of helps you instantly get some more information and data out of it. Casual Economist says, I'm late. Can we start all over? Welcome, Casual Economist. Yes, of course we can start all over. So, Casual Economist, today we started our stream by everybody giving a 10-minute presentation about themselves. So, yeah, if we want to start over, go ahead and start, Casual Economist. The floor is yours. Yassine says, is it supposed to be showing the training cycle? I don't know if it's just me, but I can't see it. Yassine, yes, it is supposed to be showing a training cycle. Did it not do that? I think it did, right? Or wait a minute, did I? Gosh, oh man. You know, guys, I'm sorry. I don't know why it's doing that. My OBS keeps dropping my screen capture, right? Because I have like a second monitor that I use for all of my work. Yassine says now it does. Yeah. Sorry, guys. I don't know why that refresh rate is failing, but it doesn't seem to restart the capture. So I have to do it manually, which is really annoying. But yeah, thank you for that, guys. But yeah, this is what it looks like, guys. So everything you're seeing on your screen right now is a convenience of working with Keras, right? Because this is all Keras output. We didn't program any of that. This is what's baked into the library, right? So the library is telling us, hey, I ran this epoch. I used 422 batches. Here's the accuracy. Here's how I improve, so on and so forth, right? So let me know if anything on this screen is catching your eye. I haven't looked at it yet. I'll take a quick look here. Osama says, if one framework is compatible with Python 3.11 and another requires 3.13, what approach should we take to manage both? It depends. It depends, Osama. Are you talking within the same project or within the same server or whatnot? Because virtual environments should be able to handle what you're talking about, assuming separate projects. Yeah. Otherwise, you'd have to get more into project-specific needs and figure out, what needs to actually talk to what, and go from there. But virtual environments, Conda, all of that should help you with that problem, Osama. Common problem, by the way. Casual Economist says, I was born on a farm. It was cold and rainy night from what I remember. Okay, keep going. You've taken up about 20 seconds. So you got a long way to get to 10 minutes there, my friend. All right. So let me take a quick look. Does anybody want to point out anything that they're seeing on here? What do you guys think? Is this a good model, bad model? Do we need to try again? What do you guys think? What is your general impression? If you're lost, that's okay too, right? Let me know. But what do you guys think? Give me your impressions. What's your interpretation, right? Results interpretation, super important part of being a data scientist, right? So I've already made my interpretation, but you guys tell me, what do you guys think? Yassine says loss is good, accuracy is good, both for training and validation test sets. Starry Vibe says, I think it's a good model. Starry Vibes, why do you say that? Yassine says, we didn't need that many epochs, that's for sure. Yep, 10 epochs, pretty fast, pretty fast. What else do you guys think? Anybody else? What do you guys think? Is good model, bad model? Are we on the right track, the wrong track? Do we need to redo everything? What do you guys think? Fabrizio says, how is accuracy and loss being calculated? How is validation, accuracy, and value loss being calculated? Is it using MSE or cross entropy? Is accuracy calculated as an F1 score? It is using cross entropy, right? We can see that in the code. And accuracy is not being calculated as an F1 score. I believe the default for Keras is just to do it straight up accuracy. Manoj agrees with Yassine. Osama says, I believe it's a good model. Michael says, please explain. Michael, which portion do you want to explain? I mean, if it's the whole output, that's okay, right? But let me know which portion you're referring to for the explanation, okay? Because there is to Michael's credit, there is a lot happening on this screen, right? So that's why I'm kind of challenging you, all of you guys who say it's a good model. Tell me why. What on this screen is kind of, making you conclude that, right? And like I said, guys, results interpretation, model interpretation is extremely important in your career, right? So I'm gonna kind of push you guys a little bit. Why are you guys saying that? Why is it a good model? Or if you're maybe just a little bit confused or whatnot, like Michael, feel free to say that too and say, hey, I need a little bit more in-depth explanation. What do you guys think? Starry Vibe says, I think Epoch 9 does better than 10. Look at the validation loss in line 9 and 10. Okay. I love that observation. Denelson says, it does look good. Could we get back to the recomposition scores and a confusion matrix? Okay. Michael says he wants to explain the whole output. Thanks. Okay. All right. Yeah. So all very reasonable comments here, guys. So let's try to address Michael. And in that process, I'm going to also try to address some of the other comments that people are making, okay? Give me, you know what, guys, just to make things a little bit easy. I'm going to rerun everything we just did. I want to clear out the screen just so that we're clear that everything on this screen right now was generated by Keras. And we're getting similar results, so I think we're going to be okay here. Although I might have just tanked Starry Vibe's previous observation, but it was still valid, so I'm still going to focus on it. Yeah, okay. Okay, so first of all, the first understanding we should all have is that everything here was generated by Keras. We did not write any of the code to to explicitly generate this output. That is a function of the library. That is why you want to use a modern framework, because all of that is baked into the library itself, right? All we did was say, hey, we think this is an architecture of a neural network that we think will work. Why don't you go ahead and try that, right? That's all we did, right? Because our biggest contribution is this section right here, the build the model section, right? This is basically like like the only part that's really not done for us, right? Everything else is kind of sort of like predefined, right? Because we know we can't change our data. We wanted to use the min set. We flattened out the data, fairly standard pre-processing. There's going to be 10 classes because there's 10 numbers. Like, we're not making any decisions here, right? Here we're making decisions. Here is where we're saying, okay, well, here we want this layer, we want this activation function, so on and so forth, right? And that's basically all we've defined, but and the number of epochs, right? We defined that, right? But that's it. Everything else here was created by Keras. Okay, so that's the first thing we want to understand. 10 epochs, we define that, right? And we've seen epochs in our other parts. And basically, as we've defined it, it's basically giving the algorithm a new chance to start all over again, right? An epoch is day one in school all over again. So we've given it 10 opportunities to train itself, essentially. Within each one of those epochs, it will go through the data set and try to come up with the best model, and then take that model forward into the next epoch and learn a little bit more, so on and so forth. So in theory, more epochs, more better, gives it more of an opportunity to learn from its past mistakes, right? All right, so that explains why we have these epochs, okay? This is telling us a little bit about the performance, right? How long each epoch took, which for these models is not critical because they train pretty quickly, but as you get into larger, more complex models, that's gonna matter, right? All right, so now we have 4 columns that look very similar, right? So Michael, I want you to think about these as this accuracy and loss is one conjoined column, and this accuracy and loss is another conjoined column. And what we're basically saying is that this accuracy and this loss applies to our test data. Okay? And then we're saying that this accuracy and this loss applies to our validation data. Because if you remember, we chose a certain proportion of our records should be held out for validation testing, right? We designated that. We designated that as 10%. So this is what happens when we use our test data, and this is what happens when we use our validation data. And validation data, your validation numbers, are technically more important. I hesitate to say, but they should have more of an emphasis because this is data that your training cycles never saw. They were intentionally held out so that this is brand new data to your model. So in theory, your validation data is kind of like your best reflection of your metrics, because it kind of simulates what you're going to do in the real world, right? When you actually go to use this. So that's basically what we're doing here, right? So think of these as 2 columns of 2, right? This accuracy and loss is important, and then this accuracy and loss is important. So your eye should be drawn to this one, because this is your last epoch, and these are the validation numbers for accuracy and loss. And as we've discussed before, accuracy, more higher, more better. Validation loss, more lower, more better. Anytime you start crossing into the 0.0, you're on the right track. And if you remember, in some of our previous classes, we've gotten down to 4 zeros, right? Where it's like 0.0000 something, right? The lower you can get to the loss, the better, generally speaking. So Michael, I hope that helps break it out for you, but that's essentially what's happening here. This tells us how the model is doing. Now, if we look at this line here, this line is very similar to the comment that Starry Vibes made about the earlier model, where it is possible where you will have epochs that are actually better along the way. Because remember, guys, just because you give it more epochs, you're not guaranteed a better result. You know, that's a fundamental mistake that a lot of people make. Just because you try more in machine learning doesn't mean it's going to be better, right? So there are going to be models along the way, as Starry Vise made the observation previously, where these numbers are actually not too bad. They're actually pretty good. I mean, that's a pretty high accuracy, right? 9788 is bigger than all but one of these, right? And the validation loss matches what our 10th epoch was, right? So those are the types of things that your eye should kind of be drawn to. Okay? But overall, people are saying that this is a good model, and yeah, there's reasons to believe that this model can fit our needs, right? There's reasons to believe that this model is on the right track and will get us to an answer, right? Denelson wanted to see this more of in a traditional confusion matrix, which is what we've done in the past. So I agree with that. We're going to do that. But let me look at some of these comments. So Yassine says, I think it's a good model, good results, loss is small, validation loss as well. They are not so close, but not too far to worry, I guess. Yeah, I agree with that, Yassine. I mean, they are not equal, sure. Fabrizio says, the accuracy is being calculated, accuracy, number of correct predictions, predictions, that's not, softmax front. Yeah, sure, Fabrizio, I'm on board with that. Michael says, okay, thanks, it's clear now. Okay, good, Michael, thanks for that. Good question, Michael. All right, so let's go back to our ChatGPT and let's get a confusion matrix. I think that's a good idea. And you know what? We'll ask for it as a plot, right? We'll ask it to kind of show it to us in a graphical manner. Graphical manner? Yeah, you can say it. So I expect that the general code it's going to show us is going to be basically the same. It's just going to have like additional outputs, right? Okay, so we're going to copy that. Let's bring it over. We're going to call this NN5 just in case it made too many weird changes, right? 52 lines. Okay, it gave the confusion matrix. Oh, shoot, I copied it too early. It was still going. Okay. Predicted label, true label. It's going to show us the plot. Okay. It looks to be the same code. But it looks like we're going to need another pip install. Let me get those real quick. scikit-learn, matplotlib. Let me just get this. We're going to install these real quick, guys. All right, that should be good. And now we are ready to run NN5. All right, so we're going to see the same output basically, slightly different numbers. And then we're going to see the plot appear on our screen. Okay. And here's the plot it gave us. What do you guys think? What's your interpretation now? Let me know what you guys think. Anybody have any thoughts on this one? Denelson says, I think it looks great. So yeah, I'm gonna kind of keep that, and I'm still gonna kind of, let me go this way, so we can see the accuracy and the loss numbers. Give me just a second. Let me bring it down like this. So here's our accuracy and our loss numbers. So Michael, if you want to kind of narrow down your focus, this is a good way to think about just the last two columns, right? So yeah, I think Denelson's right. It looks pretty good, right? The chart looks pretty good. It's telling us it's making very, very few errors, and the numbers say that, right? A 0.9815 accuracy is pretty high, right? That's like maybe on this size of a data set, that's like one error, two errors, right? The loss is also pretty good. We had a loss. This one caught my eye. We had a loss of 699, which we didn't have any sixes in our previous run, right? So this run is actually pretty good, right? To have that loss is pretty good. Yassine says, not one false prediction, I guess. First thought is bad confusion matrix because, well, it's confusing. Not showing numerical result. That's funny. That's funny. And you're right, Yassine. I think that ChatGPT could have picked a better way to do that, right? Like the color gradient, I'm not really on board with. It's kind of funny, right? But I totally agree. Class for digit 1 is being classified the best. Oh, yeah, that's a good observation, Denelson. I'm on board with that. Fabrizio says, what does the colors mean on the confusion matrix? The diagonal is a perfect match. So the purple means that there were no mismatches there, Fabrizio, is what it means. That's the way you should be interpreting that, right? And Denelson is making the observation about 1 because it's the brightest number, or brightest on that gradient scale, right? But yeah, I mean, to Yassine's point, it's not really it's not I don't want to call it a poor visualization, but ChatGPT could have done better on it. Yassine says, I don't think the class or digit 1 is being classified the best. Okay, why do you say that, Yassine? Because I can see how Denelson drew that conclusion. It's just because it's the most existing case. Um, maybe, maybe. Um, you know what? Let's ask ChatGPT to modify that because I think we can all agree that that this isn't the best visualization. It's an okay visualization, but not really ideal. Fabrizio says, so we don't have any colors like green, for example, on the purple side. It means it's not mislabeling. And the number 5 is the less accurate, let's say. Number 5, let's say. Yes, Fabrizio. Yeah, you're correct on both of those counts. I think you're drawing two valid conclusions there. That's right. But but look, maybe most of us here are, we're not visual learners, right? Like the slow blinkers out there. Maybe we need something a little bit more quantitative. So let's ask ChatGPT to do that. But you know what, guys? I'm glad it kind of did that because this is part of prompting, right? AI is not perfect. AI is only as good as you prompt it. Maybe we should have been more clear on the initial request, right? Maybe that's our fault, right? So we're gonna, you iterate just like anything else. You say, oh, that looks good, but let's do this. This is what I really meant when I said this, right? This is totally natural for us to go through this. All right. So we're going to copy that, and it says that each cell shows its raw count, which is maybe what we should have specified to begin with, right? So let me do that, and we're going to go ahead and replace this. I think we can replace this just fine. And let's go ahead and run it. Okay, so while we're waiting, Yassine says, if the color is based on the number of correct predictions, you can get a big number just by having it exist more in the validation data set, meaning it's unbalanced. Maybe, Yassine. I don't think that the validation set is that big to make that kind of difference. All right, guys. Okay, so technically speaking, ChatGPT did do what we wanted to, but the colors are awful. Oh my gosh. Okay, guys, that is terrible. We're not even going to try this. We're not even going to try this. Um, what is the prompt we can fix here? We can say, okay, let's see if we can get rid of those purples. Purple on black is a terrible combination. But hey, you know what, guys? Another great example when people say, oh, AI thinks on its own and we're going to reach generalized intelligence. No, we're not. It just showed us a plot with black on purple. That is not intelligence, right? Uh, oh, why are you? No, don't just import the plot. Do the whole thing. Oh, don't do that. All right, so it's going to show us the whole thing now. We asked it to remove the gradient. Uh, let's do this. Let's do this. And then we're going to rerun it and we're going to see where we end up. All right, so we're going to rerun this. 0.0660. That is the lowest validation loss that we've seen. All right. All right, guys. Oh gosh, now it changed the axis. Oh gosh. All right, guys. So here's our confusion matrix. No color gradients, counts only. Does anybody want to make any observations on this? That's about as big as I can make it, guys. Give me some observations that what's catching your eye here, guys? So Yassine, I see your latest message. So Yassine, here's an opportunity for you to kind of correct that, right? What do you think? All right, anybody want to volunteer their suggestions for this? What do you guys think? Anything jumping out at anybody? I'm trying to draw my own conclusions. And if you don't know how to interpret this, that's okay. You know, we'll get to that. But I'm just curious to see if anybody wants to jump in. Yassine says, I think the model does confuse certain numbers with each other. Okay, well, give me an example, Yassine. What makes you say that? Especially with numbers like 2 and 5. 2 and 5. Yeah, maybe a scene, but I'm seeing more in 3 and 4, right? 8 and 3. Yeah, I definitely agree with 3. 8, I don't think so. I think 8 looks fairly reasonable. The other one that's catching my eye is 1. How are there 3 instances where a 6 looks like a 1? That's kind of weird, right? Because I agree with you, right? The whole point of this confusion matrix is to find the ones that are being confused. But why would a 1 be confused for a 6? Right? I definitely agree with 3, Yassine. So guys, this is jumping out at me, right? Here, this value of 10. If you guys are confused on what's going on, what this is saying is that there were 10 instances where a 5, a value of 5, was confused for a 3. Right? That's what, because the y-axis is our true label, or what the number actually was. And the bottom axis, the x-axis, is what the model thought it was. So this line here, this value of 10 right here, says that there were 10 instances of somebody writing a 5, and the algorithm said, oh no, that's a 3. So that's a mistake, right? But then that's why this value is so high over here, because there were 867 instances where a 5 was written, and the algorithm predicted a 5. Right? That's how you should be interpreting this confusion matrix. So Manoj is saying 3 and 8. Yeah, Manoj, I think you're on the right track with 8. So guys, if we look over here at this number of 14, that means that there were 14 instances where somebody actually wrote an 8, but the algorithm said, oh, that's a 3. Right? That's how we should be interpreting that. Um, 4 looks fairly reasonable, yeah, Manoj. 4 and 9 is only 8 instances, right? So coming back to Yassine's previous statement, there were 1,121 instances where somebody wrote a 1 and it actually was a 1. So, Yassine, if that was part of your argument that it's just because it's a lot of numbers, I guess I can kind of see that, right? Because on the color gradient, it was by count. So, yes, I think if that was your point, then I think I would agree with that. I don't know if that was your intended point or not. But yes, this does kind of bring up a case a little bit of unbalanced data. It's not the worst unbalanced data set I've seen because they're all reasonably close to each other. But yeah, that is something you should take into account, right? The more classes you have, the more data you need overall, because the more examples of each classification you're going to need, right? These are all hovering in the 900 to 1,000 range to the 1,100 range, right? They're all within 200 of each other. Guess what, guys? It's not always going to be like that. This I would call, compared to some of the stuff I've worked on, this is a very balanced data set, right? So I think that was part of Yassine's point, and that does come into play when you do have wildly unbalanced data sets. So this is a small example of that. So Yassine, let me know in the chat. But if that was your point, I see where you're going with it. Yassine says, yes, that's what I meant. Yeah. Yeah, so I agree with Yassine with the caveat that this is not a horribly unbalanced data set. I mean, you'll work on some data sets that are just like nightmares to work with because of there'll be so many classes and you'll always have that subset of classes that you have trouble coming up with examples on, right? But that's just the way it goes sometimes. Okay, anybody else before we get rid of this and move on? But what do you guys think? I mean, overall, it's not a terrible model, right? It's really not that bad. But here's the thing, guys, right? This might also be an example of a model where even though you're at 98% accuracy, it may not be enough, right? You may need to be much more accurate on that. Think about that. What if this algorithm was powering something where you were reading like dollar values or monetary values? Kind of makes a difference whether the algorithm thinks something is a 3 or an 8, right? Like that has serious implications, right? So in the chat, tell me, and I'm going to go over here. What can we do to improve our model? Here's our model, right? This is kind of like the core of the model right here. But then again, we also have other things, right? We have epochs and things like that. What do you guys want to try to help us? Anybody want to give suggestions? Denelson says, it is more clear now with the numbers to see where our model might need further tuning. Yeah, Denelson, it does help to know that, but we also can't always like fine tune, right? Like there's nothing for us to go into and say, oh yes, I just need to adjust this and my problems with the 8 and the 3 are going to go away, right? You can seek out more data. Maybe you can use it to guide you like what classification you need more examples of, but more data isn't always possible, right? So yes, it helps, Danielson, but it doesn't necessarily like give you the answer either. It tells you what to go fix, not necessarily how to fix it or a viable fix. But let's focus on what we can do, right? Because there's always other things that we can be doing, right? So in the chat, what else can we be doing? I mean, we wrote this code, right? We should be able to adjust it. Denelson says we can try balancing our data set and apply a dropout rate. Justine says we can add another layer. I think dropout rate's already accounted for, isn't it? Maybe not. It is not. I think that is part of our compilation or the fit. I can't remember where we apply a dropout rate. I think it might actually be in the fit. Yassine says, or increase nodes and number of layers. Yeah. So guys, this should be a fairly straightforward question for all of you that have been attending. I definitely like Yassine's suggestion of we can either add more layers or we can increase the nodes of those layers. What is the trade-off that we are making in that decision? Are there any trade-offs that we need to be aware of in making that decision? What do you guys think? Let me know in the chat. What do you guys think? Denelson says more calculations with both additions and more time needed for the calculations, and increase in memory storage needed for all the calculations. Yeah, basically more models, or excuse me, more calculations, more processing, right? Or earlier, Starry Vibes and a couple of the people mentioned complexity. Adding more layers and adding more nodes increases the complexity, right? So that complexity comes at a cost of more processing power. That may be okay depending on your use case, or it may not. Are you running this on NVIDIA GPUs, or are you running it on a small Raspberry Pi? Two completely different considerations, right? Are you running it on a mobile app, or are you running it on a software as a service app, right? Where it'll be hosted like on a server, right? So Yassine says, yes, we are risking increasing the model size and computational requirement. Yeah, exactly. But it's still a good idea, right? So let's try it. Let's try. What if we kept here? So, this is just me and my eye, right? Feel free to draw this out. But my eye, I can see that we have a 256 layer, a 128 layer. So it's kind of like a downward cone. So why don't we keep that going and go into a 64 node layer, right? So now our neural network is all these inputs. What is it? 784 down to 256 to 128 to 64. There's no rhyme or reason to that. I'm just kind of keeping with the pattern. It can be whatever we want, but that's the experimentation side, right? If I can't give you a rationale for 64, that means I can't give you a rationale for not using it, right? So that means you can use it because it's an experiment, right? So I'm going to try it. So we're basically added a new layer of 64 nodes, all right? And guys, here's where we're being data scientists, because what do we just do? We created a change and we just rerun, right? We just keep going. Okay, so it finished there. Here's our accuracy. Here's a validation accuracy, our loss, and here's our chart. What do you guys think? And just so we're clear on this, just to kind of state the obvious, but in case there's people out there who don't want to speak up, our entire goal is to lower these numbers across the board, right? Ideally, every number outside of this diagonal would be a 0, because that means there's no mistakes being made, right? So if we pretend that this is a financial application where it's very important to recognize numbers accurately, you really wouldn't want too many numbers outside of this, right? So what do you guys think? Anybody want to tell me about these results or anything else? Osama says, I think no model improvement. Yeah, that's possible, right? That's possible. Anybody else? Or you can just agree with Osama or something. Yassine says, I think it's better now. It only confuses the number 9 with 4. Yep, I saw that, Yassine. And Yassine's making a really good observation there. This number jumped out at me because it's the only double-digit number, right? So I want to focus on that because here's the thing, guys. Osama is not incorrect that it's not a better model because the accuracy is about the same. It's actually a little bit lower, right? This accuracy is 9808. Our previous model was 9815. Right? So technically speaking, Osama is correct. There's no improvement there. But here, Manoj is saying there is an improvement slightly. And I would tell you guys that neither one of these guys is incorrect. Because what I'm seeing is less double-digit numbers. Because if you remember, we had like a 10 here, an 11 over here, a 14 over here. So what we've really done is it's generally the same model, like accuracy-wise, right? Like numbers-wise, metrics-wise. But it's behaving completely differently because what it's done is it's spread out the errors. Because where there might have been a 14 here, maybe there were more zeros over here, but now those zeros became 1s or 3s, right? And that's why the overall accuracies are kind of close to each other. And to the eye, it can be like, oh, well, look, it's good to have 0 here, 0 here, 0, a 2 here, a 2 here, a 3 here, right? But all you've really done is kind of like reshifted the errors across the planes, right? Or across the different types of errors you can make, right? Because, another way to look at this confusion matrix is there's really just one way to go right. And it's this diagonal, right? This diagonal is like the way, right? And everything else is wrong. So there's a lot of different ways for you to spread that out, right? There's a lot more wrong capabilities than there are right capabilities, right? So I would say that both Manoj and Osama are correct. The model is very little to no improvement, but it does look like it improved. But really all you've done is kind of spread out the errors. And Yassine is correct. This one should jump out at us because it's also the only double-digit number. There's nobody else who's making double-digit, or no other category that's making double-digit mistakes, right? So this is a pretty good example of something where it's kind of sort of a wash in terms of your experiment. Different behavior, but you haven't really moved forward. Right? All right, so how about this, guys? Where do I go here? Tell me about the architecture and tell me about the processing time with the change I just made. What do you guys think? Tell me about the architecture, and how do you expect that this neural network's going to behave when we run it? What do you guys think? Yassine says 3 equally sized layers increase complexity and processing needed. Yeah, we no longer have a cone, right? This is no longer a cone. This is all this is all 3 layers being flat across instead of being like cone shaped like a cone, right? How do I do a cone with my hands like a cone, right? So this is a lot more nodes, right? So yeah, slow processing, right? This is not going to be a fast runner. Should we expect better accuracy? Yeah. We're doing a lot more calculations, aren't we? Right? Okay, that ran. So one of the things I want to also mention to you guys, right? This is also, now that we're doing more and more experiments, this is also where we can talk about baseline models. So right now, we are at a baseline of a validation accuracy of 9815, right? So when we're talking about baselines, this is where we're talking about like the baselines, the champion models, so on and so forth. We can basically say, look, we know how to get to 9815. So if you show us something less than that, we're not interested. That's essentially kind of like what you're doing, right? You should say, this is our current baseline, our gold standard, and we're looking to beat that. So here, when we come up with 9787, we're already just a little bit suspicious, right? Because now we can say, okay, that's great, but we know how to beat that, right? We know how to be better than that. All right, so we're at 9787, and here's the confusion matrix. What do you guys think? Give me your observations here. I know most of us are going to be looking at this one now, 9 and 4. What happened to 9 and 4? What else does anybody want to observe? Numbers wise, you're really not that far, right? 9787 is not that much different from 9815, right? That's what? That's less than 0.005 of difference, right? Okay, yeah. Manoj says many double digits this time. Yeah, that's exactly right, Manoj. Remember how I said that? How we had previously kind of spread out the errors? In this model, we've kind of reconcentrated them, right? Because we have a 10, we have an 11, we have a 13. These all used to be just single digits, right? We have another 10 up here. Where else did I see one? I think it was this 11 that I saw that I'm mentioning twice. But we went from a spread out errors to more concentrated errors, but generally the same model, right? Right? Yassine says it's worse, more cases of confusion. Not necessarily more, Yassine. It's a different spread. Because remember, accuracy wise, we're within 0.005 of our baseline. So it's more about the concentration of them. Osama says 3 and 5. So 3 and 5 is now 10. That was not 10 in our previous model, guys. Right? So yeah, that's a concern, right? That we've kind of shifted those errors around, right? But it's essentially like on the macro metrics, it's kind of like the same ish, right? So more nodes, not always more better, right? So let's do this. Let's do. Oh, what do you guys think about this? What am I doing? What does this look like? What are you expecting? Let me know in the chat. What do you guys think? What's going to happen here, guys? Osama says increasing model size. Yep, absolutely. We're back to the cone, aren't we? Right? But this is me saying, hey, look, maybe ChatGPT was on the right track with a cone. We just need a bigger cone because our first layer, or our first hidden layer, was 256. Maybe that was too much of a drop from 784 to 256. Maybe we need to go to 512, right? And then maybe we need to have a smaller on the downs on the far end, right? Let's go to 32. Let's see what that does. Yassine says bigger model and narrow architecture. Yeah, it's a narrow cone for sure, right? For sure, right? Let's see what this does. Not going to be a fast one, right? Not going to be a fast model here. Oh, wow. These numbers are terrible to start off. These are terrible. Okay. Okay. What do you guys think? 9817. Here's our results. What do you guys think? Let me know what's catching your eye. I already have a couple of conclusions. What do you guys think? Give me your conclusions on what you're seeing and what do you think we should do about it? Osama says no improvement detected. Are you sure about that, my friend? I don't know, Osama. Technically, you can't say that because we did beat our baseline. Not by much, but we did beat the baseline, Osama. So technically, you can't say that. And I think there's a couple things on this chart that should be catching your eye, too. What do you guys think? Anybody else want to give their view there? And then what else could we try? Because remember, guys, you can't always just increase the nodes and increase the network, right? Few double digits improved in spread of error. Yeah. Yeah, Manoj. So what's catching my eye is over here 16, 13, 16, and 12. All of the errors are basically concentrated in these four numbers, right? Like, look at that. Like, nobody else is even over like a 5. If you were to remove 7, 8, and 9, you'd have a near perfect model, right? Yeah, yeah. Yassine, that's funny, Yassine. Your message popped up just as I said it. Yeah, right? 7, 8, 9 is basically where all the errors are. Even 9. 9 has what, 28 different errors. 9 alone would remove 28 different errors, right? So this is actually well, we can say it's an improved model, right? We did beat our baseline. Is it a good model? No, because you're still failing on particular classes, right? But but again, guys, the takeaway here is how different the results can be. The spread of those errors can be completely different based on just small changes, right? Because now we have a highly concentrated set of errors. I want you to look at what Karas gave us. What is the next item? Excuse me. What is the next experiment that we should run? Remember, these have all been experiments, right? You and I have been living data science right now because we've been experimenting and walking through these different changes. What's the next experiment, guys? Give it to me. What's the next experiment? Give me the next experiment and give me your rationale for it. JR says 256, 256, 128, 64. Okay. Anybody else? Denelson says, what if we reverse the code? Okay. Okay, so Yassine has exactly the answer that I thought about. Increase epochs for the model. See if its full potential seems to improve over epochs. Yeah. Look at the way the model was progressing, guys. This is another way for you to interpret results. Are you on an upswing or downswing, basically, right? Did you give your model enough time to learn from its mistakes? To me, to my eye, this says, hey, another 20, 30 epochs could really benefit this model. We were on an upswing, right? The model was still kind of finding its way. Maybe it just didn't spend enough time learning 7, 8, 9, but given another 20 epochs, it'll get to 7, 8, 9, right? Not guaranteed, but it's like a reasonable assumption, right? What did we just do? We just created a hypothesis, right? Based on the data, the model was kind of on an upswing. We know it's not good. We know it needs more attention on 7, 8, 9, but let's see what additional time will do for that, right? So yeah, I think Yassine is correct on this. This is a really good instance of, hey, this just needs more epochs. Denelson says learning rate can also be tested. Yes, Denelson, you're absolutely right. We haven't done enough on the learning rate. So right now, we don't want to change too many things, right? Interaction factors, interactivity factors, and all that. We have to keep that in mind. But let's just add more epochs, guys. I think more epochs, obviously nothing is guaranteed, as we've already talked about, but there is reason to believe that more epochs is going to help us here. So epochs is here. Let's give it another 20 epochs. Let's go to 30. Let's go to 30 epochs. I mean, I think it's a reasonable expectation to say that we are now at 9817, and this next run should give us a higher baseline than that. That's a totally reasonable hypothesis for us to have. All right, so we know we're going to run 30. And we know we're looking to beat 9817, right? Because we know how to get to 9817. Okay, so there's a 9822, right? That's an improvement. There's a 9837. Nine eight two seven, 9835. That's a new high, right? 9835 on epoch 20. Okay. A second 9835. 9837. Okay. All right, so here we are. Okay. Look at column 7, guys. Column 7 improved. Column 9 absolutely improved, right? We're making virtually, well, not virtually zero. We're making a lot fewer errors in 9. And 8 seems kind of sort of unchanged, you know? It's still making quite a few errors between 8 and 5. But now we have more errors over here. We have two 11s over here, right? Better model. We beat our baseline, right? We got up into the 983s. So our hypothesis essentially was correct, right? That we could kind of just give it more time, right? You could argue that it still could use another 50 epochs, right? Because it was still kind of sort of in that upward direction. It hadn't stalled out yet, right? What do you guys think? Are there any observations I'm missing here? What do you guys think? Anybody else want to give their observations? While you guys are thinking about that, I'm going to go to ChatGPT and figure out what we need to do to adjust our learning rate. Okay, there we go. It's in the optimizers atom. And it is suggesting a learning rate of 0.001. Does anybody want to opine on that? I need the whole line. What do people think about 001? What do you guys think? Let me know in the chat how you feel about the learning rate of 001. Osama says it requires more time. Yeah. Yeah, right? 001, pretty low value. So it's not gonna be fast, right? Yassine says I think it should be better. Yeah, Yassine. I mean, I think there's reasons to believe why it would be better, right? Again, nothing is guaranteed, but we can have a reasonable expectation that things are gonna go well for it, right? So let's try this. Because I think Dendelson is making a good suggestion there, right? We haven't played it all with we haven't played it all with the learning rate. So this is not going to be fast, guys. Not going to be fast. And what is the baseline? I think 9837, I believe, is our new baseline, right? We can basically say we know how to get to 9837. So any new effort would have to kind of best that, right? All right, there's a 9832. Okay. Oh wow, that is interesting. Anything jumping out at you guys on this? Wow. Oh wow. What is jumping out at you guys on this? Oh wow, there's so many things happening on this chart. What do you guys think? Yeah, wow. This is crazy. But remember, technically we did get we got a result slightly lower than our baseline. Yeah, Yassine, what's going on? Yassine's right. What's going on with number 3? Jeez. Look at that. 3 is terrible now. On the other hand, look at 8. 8 is near perfect now, right? 7 is not terrible. There's 7 and 2 still have problems, right? Manoj says 3 is terrific. No, Manoj. I mean, I don't think you're being sarcastic there. But no, Manoj. 3 is actually doing terrible in this run. But yeah, guys, I mean, this is not great, right? We basically have just exchanged one set of problems for another set of problems, right? So that's one of those things where we need to kind of realize that improvement isn't in the macro values, it's also in the details, right? So, what else? What else do you guys want to try? Let's go through one more iteration. What is another iteration that we could try here, guys? One parameter, Yassine says, one parameter I think we can adjust as well as a filter size in the convolutional layers. Help me understand what you mean by filter size there in that scenario, Yassine. I'm not 100% sure what you mean by that. Help me understand that. And for those of you that just want a quick reminder, right now we're still kind of using like that cone or that funnel shaped architecture that ChatGPT had initially requested, right? I think another thing we should try is, did you guys notice how it's a little bit unconventional that we're going from these 784 inputs immediately down to 512? Or even what? Initially we were going down to 128, I believe, in the very first model. What if we went up instead? What if we went to like 1,000 instead? Right? Something where our hidden layer has more nodes. And again, I'm just kind of making conversation here because any approach is valid. You don't really know what the answer is going to be, right? Only thing we know is that we have 784 inputs in our initial shape, and that we're going to have 10 nodes in our output layer. But that's it. Otherwise, everything else is up to us, right? In the convolutional layer, each pixel considers a number of pixels around it. Filter size controls how many surrounding pixels. 3x3 filter considers 3 on each side. We can do 5x5 or something else. Okay. I could see that. I'm tempted to just try something around the size of this first layer. Because think about that, guys. We're going from 784 down to 512. What if we did this? We haven't tried this. We've tried an even neural network, but even then, the first layer was going from a lot of inputs to a smaller number of inputs, right? I think we did it at the 256 level. What if we try this? Rid of this. Let's try. Yassine says we can also add some max pooling layers. Yeah, sure. But look, guys, it's my intent that this is going to be the last iteration we're going to try here. Because really, I mean, we're not trying to solve the mince data set, right? What I'm really trying to impress upon you guys is that this is the work of a data scientist. Everything we've done for like the last hour is data science. Because our code has generally stayed the same for the last hour and a half, right? But it's about trying the different approaches, the different settings, the different interpretations of the results and saying, well, wait a minute, well, that one could benefit from more time. Oh no, that one was going terrible from the beginning. That's really kind of like the lesson here, right? The lesson isn't how do we solve mints. The lesson is saying, hey, look, I mean, what we're doing now, like this is the job, guys. Like this is what you do as a data scientist, right? More specifically as a data scientist working with neural networks. So whenever I hear people like, sometimes, they kind of poo-poo this portion, or they don't understand the difference, they don't understand what data scientists do on a daily basis, so they don't understand, well, what do you mean you need to know code? or whatnot. Well, this is it, right? This is like what you do as a data scientist. This is the experimentation side of the job, right? We're going to do a little bit more of that next week when we talk more about the grid searches. And then also we got to keep tracking this. We got to start tracking this, right? Right now we're kind of sort of feeling our way along and we're doing a good job of that. And maybe it helps that we're in a group, but when you're alone and you want to kind of like document your work and tell people, hey, I took your data, I ran 27 experiments, here's the result. Like, we need to be a little bit more organized, right? So we're going to do that, right? We're going to do that in some of our next efforts, okay? But let's see where we land here. We're at 98.32, which is not terrible. But again, guys, this is the job, right? If you're not enjoying what we're doing now, then like I don't know what to tell you, because like this is what you do as a data scientist. So this is showing kind of sort of signs of promise. So this is our slowest training network. And it's also our biggest network because you're going to have a lot more weights, right? You're going to have weights for every node of every layer. And this is our biggest network so far, right? Another part you should be you should be kind of taken away from this is that, guess what? More layers, more nodes is not always more better, right? And we kind of saw that before in our previous efforts, but it should definitely be cemented today. Think of all the different efforts that we've done just now and the different architectures, and the accuracy rate has moved 0.003, right? We've been in a range of 0.003, like 98 something. We've been in that range for like the last 45 minutes, right? So it's not always more is better. Data, can kind of be nuanced in that way. There we go. There's a 9857. We got a 9857 in our 24 of 30 epochs. (9845). That's good. So we're making incremental progress. Doesn't mean that every class is going to look great, but this is a little bit more encouraging, right? (9852). 9852 is a pretty good result, guys. That's one of the highest ones we've seen. All right, so this is the last confusion matrix we're going to look at. What do you guys think? Okay. Okay. Let me know what you guys think. A couple of things are catching my eye. Yeah. I'm gonna go ahead and say that this is one of the better confusion matrices we've seen. I'm gonna also go ahead and say that I can tell a difference in the accuracy, right? Because remember, the accuracy that we're looking at during that training cycle is kind of like a macro number, right? Better. Osama says better than a previous model. Osama, I agree, right? Like you can feel a difference in the accuracy here, right? Yassine says everything has improved except only number 4. Yeah, right. I mean, this number obviously jumps out at people, right? But guess what? It's our only double-digit number. and it's a fairly low double digit number, right? We've had charts with just one double digit number, but it was a 15, right? Here it's an 11, so that's not horrible. Look how improved 9, 8, and 7 are. I mean, 9 is pretty good. 7 is nearly, 8 is nearly perfect now. 7 is also nearly perfect, right? Remember, guys, we just a couple of versions ago, we had a model where 7, 8, 9 were horrible, right? So that's an improvement. Manoj says better than the previous baseline model. Yeah. And you know what, Manoj? I like the way you put that because, like, you know what? That would be a good T-shirt for data scientists, right? Better than the previous baseline. Like that's your whole goal. Like that. When people ask, like, what do data scientists do? That's what it is. Like, what is my baseline, and what am I going to try to beat that baseline? Right? That's the life of a data scientist, right? But yeah, Manoj. So more importantly, Manoj, it's not just numerical. I think that just to the eye and the different numbers, sections, or combinations that each of us has been keying in on are pretty good. Osama says 5 is also good. Yeah. I mean, 5 is near perfect. Well, 5 and 3 are still a little problematic, but 5 is very good. You're right about that. But yeah, guys, I mean, like, it feels like this is like just a better model, right? Yeah. I mean, look at 8. 8 is like basically perfect, right? Same for 7. I mean, 7 is nearly as good as you're going to get, right? So here's another thing, right? This is another scenario where, hey, look, maybe 30 epochs is not enough. What do you think would happen if we went to like 100 epochs, right? Like, maybe let's go ahead and run that while we're talking. Can I do that? I think I have to get rid of this. But what happens if we just go to 100 epochs while we're still talking? Just So this is one of those scenarios where you might run experiments and then you're writing things down for what you want to do over the weekend, right? And then on Friday, you would write up all your experiment or tee up all of your experiments, kick them off, and then give it 2 days, 3 days, whatever, a long weekend or whatever you want it to be. And you come back and you say, okay, well, let me see what more time did to the model, because sometimes we might kind of shortcut ourselves if we say, oh, we have to sit here and we have to watch the machine and whatnot. Sometimes just kick off the experiment and let it fly. See if it can get you somewhere, to get you to a place better than where you thought you could be, right? So I think that we're really kind of like on the right track here. Again, not to solve mints, but to appreciate the work that goes into, being a data scientist, right? I mean, everything that we've done here is what you would do on a day-to-day basis. And keep in mind that when I say that, I mean that I mean that also beyond neural networks. We happen to be using neural networks today, but you could be repeating this with any technology or library or approach or whatever else you want, right? It's just the experimentation would just be with different data and different models, slightly different settings, but it's all still, the spirit of experimentation of data science. Right? All right, so we're going to go ahead and let this fly, let this run a little bit. Give me, if you guys want, we'll do a couple of, if you guys have any other questions, let me know. But otherwise, what I'm going to do is I'm going to do the same thing I did last time, where I'm going to post these results on my Instagram and on YouTube in the community section of YouTube or whatever it's called. But I think that, this is on the right track here. Denelson says, sorry to get off topic, sir, but I just checked my LinkedIn, but I was unable to find your message. Okay, Denelson, I'll send you something else. I think I had sent it as part of one of your posts or updates or something, but let me resend it. But yeah, but if anybody else has other questions or if something didn't make sense, now's a good time to ask. Otherwise, I'm going to keep an eye on these epochs. Who knows? Maybe we can get into the 9/9s, right? Because that could be another way to approach this, where your whole goal is to get to a 9/9, and you could say, I'm going to run a bunch of different experiments. I'm going to run a bunch of grid search settings, but stop if you're not on your way to 9/9 after 50 epochs. That's a valid approach, right? You could be saying that's the concept known as early stopping in training, right? Where you can say, well, look, this is not headed in a positive direction, and I already know my baseline is up here, so let me save my processing power down here and start a new experiment. Totally valid way to go about that, right? Oh, guys, we went for almost 3 hours today. You guys are insane. You guys are mean for making an old man like me go for almost 3 hours. You guys are crazy. All right, guys. So let's see where this last model ends up. But I want to thank you all so much for being a part of today's class. Really good stuff, guys. And we're going to build on this next week. We're going to build on this with more formalized grid search, with more formalized documentation, right? Because right now we're just kind of, going off the cuff, just trying different things. But, you got to be able to kind of document all of your experiments. This also helps you a little bit with your stakeholders. It helps you get a little bit of credibility to be able to say, hey, look, my team took a look at this. We spent 2 weeks at this. We ran 700 experiments over 2 weeks, and this is where we're at, right? That's a very powerful, not just a story, but it's a powerful way to show your professionalism and say, hey, look, we are scientists working in a lab. The lab just happens to be, made up of code, but we ran this many experiments, and here's where we're at. That's super powerful for a almost like a legitimacy in front of your stakeholders. Okay. All right, everybody. So thank you so much. I can't believe we almost went 3 hours. You guys are crazy. Thank you for sticking in there with me. Really appreciate it. As always, we live in such a dynamic world, and I worry about every single one of you because I know we have people from all over the world here. So thank you so much. Please, watch out for yourselves. Take care of yourselves, take care of your families, and I'll see you guys next time. All right, guys, so let's get started with part 7 of neural networks. Congratulations to all of you that have stuck through this series. I know a lot of you have been here from the beginning. I know a lot of you have been here for some of the other series too. So thanks for hanging in there with me. You guys are awesome. But we are going to go start part 7. And I want to start by a little, kind of picking up where we left off. So if you joined us last week for part 6, which I think most people in the chat were here for part 6, you should recognize this, right? This is the last big neural network run that we did. I think we actually left this running at the close of the previous session. But you'll see here that we were doing a fairly large neural network, right? This was taking a long time. We were trying to increase our validation accuracy and loss. I think we did do that because our previous baseline was like 9835 or something like that. And we have managed to get a few values, 9857, 9858, 9875, that are clearly higher. So we're making good progress, right? And if you remember, our code looked a little bit like this, right? We were using TensorFlow and Keras. We were using the MINCE data set, right? Which, if you remember, is the handwritten numbers. And then here Well, we also know we have 10 categories, 10 classes that we're trying to classify into because it's the 10 numbers 0 through 9. And then here is our actual network, right? We ended up with what? 5 hidden layers, all of them the same size, 784 nodes in each, which is a lot of calculations, right? So this is, it's not a small neural network, right? There's a lot of calculations, a lot happening. These epochs were not going very fast. We had set a very low learning rate, right? Which, as we've established, is kind of like the size of the steps that your model takes. So in theory, the smaller the step, the more likely or the more fine-tuned it will be to try to find or try to converge on an answer. Here we have our fit function, which is like this is like kind of like where all the work happens, right? And fit being a method call to the Keras library to our neural network framework, right? And I say that because most neural networks have a fit. Most neural network frameworks have a fit function, I should say. We were doing 100 epochs, right? Which we know is going to take time, but it gives the model time to converge, right? To kind of find its way. And basically down here, we were just letting it go ahead and do outputting the test accuracy, right? We were using accuracy as a metric. And then from there, we were doing a confusion matrix, and then everything here is basically just kind of plotting a result for us to see, right? So this was a pretty good approach, right? We were getting some pretty good accuracy numbers, right? 9873, 9875. So not a perfect model. Still some work to do, but pretty good. We also saw how there was a variety of results that can happen even though the numbers are pretty close to each other, right? Like the distribution of where the errors were happening and across what numbers, where an 8 looked like a 3, or a 5 looked like an 8, or a 5 looked like a 3, so on and so forth, or a 1 looked like a 7. There was a shift in distribution of those errors. So not all of these models are the same. Just because this model is 9893 doesn't mean that it's really, really close to the one that's 9873, right? Like they're not related in that way. They can be close in value and accuracy in the metric that we're tracking, but still be wildly different neural networks, right? Making completely different mistakes, essentially, right? Or you could say, they could have completely different skills within each one, right? So what we want to do is we want to go ahead and give me just a second. Yeah. So what we want to do is we want to go ahead and we want to take it a step further. Let me bring up my slides. So this is what I really want to accomplish. Or these are the next 2 big items that I want to accomplish. I'm not sure if we're going to get to item number 2 today. And I'm not even sure if I want to try because it would be 2 big topics in one session. And maybe we just need one topic. So what we need to do is we need to take our current neural network one step up. Right now, we have done what I would consider, like, as far as like in the professional world, we've done a really nice exploration. What we've done so far is what I would be doing when a brand new stakeholder approaches you with a brand new project and says, hey, we have this idea, we think there's something here, can you help us? And that's what we've done, right? We've done enough research, enough work to say, yeah, we could probably get to an answer here, right? There seems to be enough data. We understand how to work with the data. we have some idea of what the neural network architecture can look like. So this is kind of like where I would be saying like, yeah, let's commit to this project, right? Like there's reasons for us to be optimistic that we can have a good delivery here, right? So we've done a lot of good work, absolutely, but don't be fooled, right? Everything we've done was really just kind of like exploratory, right? Like this is nowhere near a finished product. So what do we need to do to kind of take that next step up to make this into like a professional effort, right? Because we're not students of data science, we're professionals of data science, right? So um, what I'm hoping that we can walk through today is kind of like taking that next step up and really kind of your practice and your career, right? Where you can say, okay, now I'm doing like the level of work that pays the bills, right? Not just I'm really good at studying neural networks or I'm really good at doing YouTube tutorials, right? So what I think that entails is four things. One, we have to do a more proper grid search for our items. Two, we have to start documenting our results. Three, we have to start saving the models. And four, we have to start actually separating our, well, what we want to do is we want to start having code that actually makes the predictions for new data, right? And what you're really talking about there is you're talking about writing separate code that actually uses your model, because we don't have that yet, right? We don't have something that that's a deliverable yet, because you're not going to hand over training code, right? That's not what the stakeholder wants. The stakeholder ultimately wants code that is like plug and play, right? Like tell me where to show the new image and you tell me what number it is. Like that's ultimately what the stakeholder wants, right? So those are the four things that I want to accomplish today that I think kind of give us like that next step, like that pro level feel, and really kind of more of a deliverable feel to what we're doing. Okay? So you guys with me on that? What do you guys think? Does that make sense? But those are the four things I want to accomplish. So the first three we're going to accomplish in the current code file we have. We're going to basically make it more robust. But the fourth one, the prediction cycle, that's going to be a brand new piece of code, and we're going to see how we do that. And by the way, you can't do number four. You can't get to the prediction side without first having a scheme or an approach to saving the models, right? There's nothing for you to use at runtime. There's nothing for you to deliver to the client if you haven't actually done the saving, right? You got to have a model to point to, right? Fortunately, the most of the modern frameworks have a way for you to both save and load models. So we're gonna basically trying to focus on that. Okay. All right. So in the chat, Fabrizio says, is there a way to pull the error or bias from weight biases and do some sort of feature importance classification based on an external database to add new variables to improve prediction? Not always, Fabrizio. It depends on your data, and the challenge here is that it's what your statement is based on the assumption that there's always more data available, and that's not always the case. And then on top of that, I've never been an advocate of chasing errors, right? Because as you guys saw last week, even from one run to the next for very, very similar models, the type of errors you're making are very different, right? So after a while, it'd be kind of like whack-a-mole, right? You'd fix an error over here, but you'd probably cause an error over there, right? And then on top of all of that, you're also risking creating an unbalanced data set, right? The only time I would advocate that is if you're getting errors and you know you have an unbalanced data set and you know that the error is being caused by a lack of data. So let's say we saw an error between the 8s and the 3s, a distinction of the number 8 and distinction of number 3. But we know that we are low on number 3 for whatever reason. In that scenario, yes, you might want to go out and seek more data to kind of bring up your numbers to parity, right? But anything other than that, I'm not sure if chasing down errors is the best way to go about it, Fabrizio. So I hope that makes sense. All right, guys. So let's focus on these. I put these generally in order of how we can approach them. So we're going to add a grid search, we're going to document our results, and we're going to save our models, and then we're going to use prediction cycles. These should kind of go in line with each other, okay? So what I want to do is I want to go to our current code, and we're going to make a copy of this. And we're going to work on NN6. Oh, why did that name that? Hmm. Why did that name automatically? Weird. Hmm. Never seen that. Okay, so there's NN6. The reason I made a copy is because I kind of want to slim down the neural network because we know that this neural network is pretty good, but it also takes a long time to run. And we're going to need something that's a little bit faster. So we're going to go 2 hidden layers. We're going to cut our epochs in half. And then let's see what kind of results we get with this. So, oh, and oh, where did I save that? Did I not? Oh, oh, that's weird. Okay, I may need to have to restart my terminal window because this is my terminal window from last week. So give me just a second here, guys. So I just needed to restart my terminal window. Okay, there it is. We're going to activate our Conda environment. And then we are going to NN6. All right, so let's see what kind of results this gives us. If you remember, we're plotting at the very end, right? We're showing a plot to ourselves. Okay, wow, that's still pretty slow. That is still pretty slow. Well, that may not be so bad for today's needs. Um, All right, we're going to proceed with this neural network. I'm a little cautious about how slow it is, but that might actually be okay because it'll give us time to evaluate the results as they happen. So let me go over here. So grid search, right? We're going to go ahead and take our current architecture, NN6, which is we're going to close out all our other windows and just focus on bringing this version up to like a pro status, right? So we're going to take this and we're going to go back to our ChatGPT. This is the window that we were using last week, right? This is how we got the code for this particular neural network. So we're going to bring ChatGPT up to speed and say that we want to make other adjustments, right? So the first thing we want to add is we want to add a grid search. Okay, so this is giving us suggestions ahead of time instead of asking what we want, which is okay, but all right. So I'm trying to be a little bit explicit with this because we know that in the past ChatGPT will just give us snippets of code, but I want to make sure that we're always seeing the entire code. That way, we can kind of make sure that um, we're getting like the full picture of how these things are implemented, right? So you can see here already, there's a couple of new things added, right? It's added an additional optimizer. It's added a grid search dedicated library. And I think that's it. That's all it's added. At least at the top there. And then down here, you should see that interesting. So it's going to make a couple of changes based on the dropout rate and the activation function. It's also going to make some changes based on the um, uh, optimizing the learning rate, right? Based on the two different methods that you see there. And then that's it for now. There's a parameter grid, which is kind of like the heart of a grid search, because this represents all the different values that we're going to be trying. So each one of these, or each permutation of these, basically represents an experiment that you're doing, right? Because again, we don't know what the answer is. So each one of these is an attempt, an experiment. And they're each going to have their own different values, right? Here's where the grid search is set up. And then here is the actual fit function, right? So the fit becomes the call to the fit function becomes a little bit different. And then I assume that that's going to run for quite a bit of time. And then it's going to give us the actual result as an output in text, confusion matrix, and the same plot out. So let's copy that over. We're going to paste it in here. And you can see now our code has jumped up quite a bit, right? We were like at under 60 lines of code. Now we're at over 110. But that's okay, right? Because that's what it takes to be able to run all those types of experiments. So let me stop here on the parameter grid. What do you guys think of some of the parameters that are on here? What do you guys think? Oh, and also, by the way, oh man, what did I just do? This is our latest confusion matrix from that run we did on the slimmed down model. So not terrible results, but there's still a couple of numbers here, right? 9s and 4s, 9s and 3s are still having problems with each other. That's really the biggest one, I think. 7s and 2s seem to be having a problem with each other. But generally speaking, a reasonable model, right? I mean, like there is a double-digit error. 6s and 5s apparently are still having trouble, but that's our only double-digit error, right? So, not the worst model we've seen. Good to know that we're getting that from only 2 layers, right? All right, so what do you guys think about the different parameters that we're adding? What do you guys think? Give me some feedback on that. Yassine says maybe we can reduce the number of nodes in each layer. Sure. That is definitely possible. Gulam over on X. Good to see you, my friend. It's nice to see some participation on X. So Gulam, I think it's your first time here, so welcome. We were in the middle of talking about neural networks, specifically around grid searches. So thanks for being here, Gulam. Fabrizio says the fit train, the different data set, I see it's using hot encoding for the Y training category. Yeah, that's right, Fabrizio. I think all of those are correct. But let's focus on the parameter grid, because that's really kind of like the net win here, right? Let me close this out. That's the net win. The net win is that we have this parameter grid, right? Because again, each one of these permutations, it is an experiment, right? What I'm not liking too much is down here. I have a feeling that this is going to sit there for a long time on the grid result and not output as it goes, because I didn't see any other sort of outputs. But we'll see. Fabrizio says, use another optimizer can reduce even more the learning rate. Sure, we could definitely use an even lower learning rate, sure. So if we do that, let's go ahead and add this. Who can tell me what is the net effect of adding that parameter? What are some of the things that we can expect to happen because we added an additional parameter? Because yeah, I mean it's rarely a bad thing to add to the learning rate, right? So yeah, I'm on board with this, but there's a trade-off, right? What do you guys think? What's the net effect of us adding that there? Yassine says number of neurons will be similar for both layers. Sure. So Yassine, are you saying that these numbers aren't diverse enough? There's something to be said for that, right? I mean, Yassine, I don't want to put words in your mouth, but you kind of want the experiments to be diverse, right? Especially early on, because again, you don't know where the answer is. So you kind of want a broad range because you kind of want to be able to narrow it down and be able to say, okay, I tried this broad range. This range seemed a little better, so let me try more values in that range. Okay, I'm more refined, right? So Yassine, this is in response to my question of the net effect of adding this new parameter, right? Because we added this, right? ChatGPT did not have that. Yassine says exponentially more runs. Osama says takes more time. Yeah, that's exactly right. Both of you guys are right. So keep in mind that grid searches are fun, But these are all permutations. So yeah, Yassine is right. It's not just a little more time, it's exponentially more time, right? You've added to your factorial calculations, right? So you definitely have to keep that in mind when you're adding your grid searches. And that's why I'm saying that I think the line here where we're actually doing the fit is going to take a long time. I have a feeling it's just going to like sit there, right? But we'll see. We'll find out soon enough. Question, Dennis, from top to down is number of neurons, then batch size. How many sets of those numbers of neurons are grouped? And epochs is the best feed and back propagation process, right? Not necessarily, Fabrizio. So we've talked about this where epochs is not going to change your model size, but it will change your training time, right? And there may be situations where you are limited in how big those files can be, right? So it depends. It's all a trade-off. I think that you could, if you had asked me the impact or the likely impact, that is the right list, but the likely impact does not is not always what you're chasing. You could be chasing speed. You could be chasing file size, right? And we're going to see that a little bit when we're talking about actually implementing the models and actually saving the models, right? Because we haven't really talked about that. Osama says, sir, what about cross-validation? Well, it's handling it for us already, Osama, right? Like the frameworks handle that for us. Remember how there's a accuracy and there's a validation accuracy. So it's already handling that for us. Only thing we have to do is just kind of declare the usage of it and the parameters we want. But that's one of the advantages of using one of the modern frameworks, that it handles all of that for you. It writes all of that code for you. Okay? All right, so I'm curious. Let's see what this code starts to look like. Like I said, my gut feeling is that this is going to sit here for a while. And I don't know how good I feel about it. Doesn't necessarily make for a good class. Okay, no wrapper, no module name, TensorFlow Keras wrapper scikit-learn. Let me see. Let me see what ChatGPT says about the import that we need. I mean, obviously it's going to be some sort of pip install. Oh, that's weird. Why did it do that? Okay, that's weird. Why did it change that? It changed the entire code? It changed it to a new call? Of Keras? Is that new code or not? Give me a second here, guys. Let me compare this. NumPy, TensorFlow Keras, optimizers, wrappers, scikit-learn. Oh, okay, so it eliminated that. So it removed that. And that's it. And then we need a new install. That's weird. Is that a hallucination? Hey guys, maybe one of you can help me on this. Can somebody look up if this is a valid call? Because it is a little weird that it's calling to a fourth library or a fourth class, I guess you would say. Can anybody confirm that? Is that valid? TensorFlow.keras.wrappers.scikit-learn? That might be a hallucination, guys. What do you guys think? I know some of you, kind of know the TensorFlow library. It is a little weird that it's 4 levels like that. We might have a hallucination here because the next version of the code kind of corrects that, right? This is now using scikeras.wrappers. That is interesting. Can somebody look that up? I think that might have been a hallucination. All right, so we're going to reuse this code that it gave us. We're going to make the change that we previously had made based on Fabrizio's recommendation. Okay, so Yassine says it was supported to integrate Keras with scikit-learn, but now is no longer supported. That's what I found. Okay, thank you, Yassine. It just had a weird format. It's not every day that you see it go to 4 levels like that in the library calls. Excuse me. Okay, so we still need that pip install, right? We need pip. Okay, so it has that. So now we're ready to run again. Okay, so while that's running, Fabrizio says, I see, but what really increased the probability of improving accuracy is probably increasing neurons, so then it learns more patterns. I am not sure about the epochs and batch size. Yeah, sure, Fabrizio. You're right there. But remember, guys, there's always going to be other limitations in the real world. Just because you can do it on your desktop or in your testing environment doesn't mean that's going to fit the need, right? You're not always going to be able to deliver the optimal solution. You deliver the solution that fits the need, right? So yes, the list you had given previously and increasing nodes is the highest probability of a change, but that change may not always be desirable. What if you're told that you're going to be your network, your algorithm is going to be deployed on some like embedded piece of hardware, like on a small Raspberry Pi or something? Well, you can't just build this massive network. You're going to have size limitations, right? You're going to have speed limitations, or processing limitations, right? So yeah, it increases your probability, but if that makes your network completely unusable, then kind of who cares, right? So keep that in mind. Okay, so yeah, just as I thought, it looks like this is going to sit, right? It's going to sit there with basically very little feedback. I didn't see any verbose settings that we could set. Let me check one more time. Actually, I think in the fit function we could do something, right? This might have a verbose option. I don't know if that's going to work or not. And we're going to set this verbose down here to 1. Let's stop this for now, guys. I want to see if we can't get some more feedback. Okay, there we go. There's a verbose. Okay, cool. So, does anybody want to interpret what we're seeing on the screen? Yeah, cool. What do you guys think? What are we seeing, guys? What's happening right now? Anybody? What's going on our screen? Fabrizio says it's slowly improving due to a small learning rate. Yassine says it's showing an experiment with epochs value 20 for different hyperparameter values. Yeah. Yeah, Yassine, you're on the right track there, right? If you guys watch the epochs, it goes up to 20 and then resets, right? Why is it resetting? Because every time that it's running that set of epochs, it's trying one of these combinations of the grid search, right? So looking at our grid search, is that experiment there? Is that going to sit there for a short time or a long time? I just told you that each time those epochs run, it's a representation of an experiment. Well, each group of 20, I should say, right, is an experiment, right? So is that going to take a short time or a long time? Yeah, Yassine says a long time. Yeah, because we're choosing to run a lot of experiments, right? As you may have noticed, I've always used the reference of permutations because it's like the number of experiments is 3 times 2 times 2 times 4 times 2 times 2 times 2, right? Manoj says accuracy is oscillating as epochs is running to 20. Um, yes, Yassine, but it's not oscillating because of the epochs. It's oscillating because of the settings, right? Each one of these is its own experiment, right? Each group of 20 that you're seeing on the screen is its own experiment. So that's really what's causing the oscillating. Yassine says 192 for each epoch's value. Is that what the number comes out to? It feels like it should be bigger than that, right? 3 times 2 times 2 times 5. Well, maybe it's about 192. Fabrizio says you multiply epochs or number of variables on other hyperparameters, it will run a combination 20 times, then keep going. Yeah, I think I'm on board with that, Fabrizio, right? Yeah, so whatever this number of permutations is, it's going to do that 20 times. It's going to run 20 epochs for each permutation, right? Because on epoch 1, you're using the new combination of settings, and then you're running it through the epochs to help it find convergence, right? Just like we did in other experiments, right? So this is going to sit here and operate for actually quite a long time, right? I mean, one of you guys can do the math. I think Yassine is saying it's 192, which I guess makes sense, right? I guess it could be 192. But this kind of should start to give you an idea also of the time investment it takes for proper data science to do, right? Because you can't make any conclusions until you've tried all these permutations. And even then, you might just have a better idea of what to do the next time you run these. Running these experiments is rarely a one-time thing. Like, oh, we ran one grid search and we're done. Well, no, you got more information and now you're going to change based on that information, right? So, um, so let's talk about that, right? So if we just agreed that we're going to change with each information, well, we can't do that unless we're tracking all of this, right? We got to be able to track all of these. Um, Fabrizio says it takes like 1 second per epoch. It's like 20 seconds. Yeah, sure. It does seem to be taking about 1 second for the epoch. But remember, you got to have the permutations into account, right? So here's the next part that I want to implement, right? Because let's look at our list. Let's look at our goal list, right? We said our first goal is a grid search, and we're doing that, right? Because each time that 20 epochs resets, that's moving on to the next item in the grid, right? The next permutation in the grid. And it can do that for as many permutations as we give it, right? We're kind of in control of that, right? The next thing we want to do is we want to document the results. Where are we headed with this, right? Where are we going to go with all of this? That we're going to get by creating some sort of logging, right? And on top of that, a professional always documents their work, right? So let's work on that second part. Okay, so Fabrizio's coming up with 3,840 seconds. Okay, so what is that? That's like 50 minutes, right? Or that's over an hour, right? 3,600 seconds is an hour. So that's going to take over an hour. Okay, cool. Thanks for that, Fabrizio. So here's how we can help ourselves. One, we're going to stop this, right? So we're going to pause this. We're going to take our code back to ChatGPT. And we're going to add for a modification. We're going to ask for a modification, right? Let me be a little bit more explicit. Oh, okay. So now I'm going to prompt it and I'm going to ask it to give me a result outputted to a CSV every time we finish each of those sets of 20, right? Every time you finish those 20 epochs, go ahead and send it to a CSV file. And that way we can keep a running log of all the items that we've tried. Make sense? Let me add this, and then let's let ChatGPT go to work there. And then I might have to make an adjustment to my camera here, guys. Give me just a second. I need to adjust my camera a little bit. Okay, that's going to be a little better for typing. Fabrizio says, can you show us the parameter? Sure. Well, you know what, Fabrizio, let me show you the parameters in the new code, right? So it looks like the new code is done. Yes. So we're going to copy that. We're going to go ahead and replace this. So very quickly, so we can see here, it's going to go ahead and output to gridsearchlog.csv. And it's making those calls where? Here in the log df. And it's going to write it to the CSV and tell us, you know, it's going to tell us that it logged it, right? And is it doing it at the end? No, it's doing it for... Oh man, it's only doing it at the end. It's only doing it at the end. And it's putting it in this grid results, CV results. I was hoping that it would do it as it goes. But maybe it's not possible using the grid fit. All right, let me think on that for a little bit. There's multiple ways we can go about this, but you know, so yeah, Fabrizio, here's what we're trying. If you guys want to try other values, we can definitely do that, right? But Fabrizio, that's what the values look like as they stand now. Starry Vibes, our good friend Starry Vibes, is showing up late as usual. How you doing, Starry Vibes? Good to see you. Okay, Fabrizio, so there's the parameters. I don't know if you wanted to change something, but here, guys, let me show you a little bit of a trick that I use sometimes. Because sometimes, you know, you just need something quick, right? So another trick that I use is we've talked about the permutations, right? So if you need something quick, guess what? You just cut down the permutations. So this is something that I've used before. I probably don't want to use 0. I want to use 0.3. Right? There's nothing wrong with doing this, right? You can just say, hey, you know what? I just need something quick and dirty. And we need this to try out our logging, right? Because unfortunately, I was hoping that it would write it as it goes, but it probably can't, because I'm guessing that's a limitation of the fit function. So let's just go ahead and try this, right? Just something quick. So I expect that this is going to go very quickly. Oh, I didn't do pandas. Okay, so that's fine. So we're going to do that install fairly quickly. All right. So this should go fast, and it should only go once, I think. There should only be one set of 20 epochs run. Which means that we should only have one result in our new logging file, right? Our new CSV file. And there it is, right? It's telling us what it tried, and what it output. So does that mean our log file exists? I think it does. Let's go back to our VS Code. It's not there yet. Let's give it another bit. Oh, it's running multiple times. Why is that? Oh, because of the cross-validation, I think? Yeah. There we go. So that's basically what it looks like when it finishes, right? It ran 3 times due to the cross-validation. It ran a final usage of it to give us our confusion matrix, right? Because now we have a brand new confusion matrix. And then on top of that, if we go to VS Code, okay, it's not, there it is. Yeah, grid search log.csv. So now this is what our grid search log looks like. We know that our batch size was 64. We ran it for 20 epochs. We used our ReLU activation function. This was the dropout rate, 0.3. This was the learning rate. This was the number of nodes. This was the optimizer. And then this was our final accuracy, right? So this is important because this is a record of you running an experiment. Remember how we've always talked about that data scientists are still relying on the scientific method. We're supposed to experiment with data, because that supports or disproves our hypothesis, so on and so forth, right? So that's what this line you should take to represent. This is us running an experiment. We just ran this experiment successfully, and this was the result, right? A 94233 accuracy rate. You guys with me on that? So here's what I want to do. Well, yeah. Oh, right. So let's take a look at the grid. So the grid looks not great, right? A lot of mistakes, right? There's a 16 up here, a 25, a 17, a 23, a 20. So not a great model. But that's okay because we know we only tried one permutation and we essentially created it in a random way, right? But we know that if we were to run something a little bit more robust, like the one up here, that's going to be a little bit more, much more likely to find a better model, right? So here, let me show you another item that we could consider. Let's let this run. We're going to let this run for a bit. It's going to take a little while. I did save it. This one's going to take a little bit longer, right? Because we added some more items. We added more to our grid search, right? We expanded our grid search, right? Asilbek, I think it's your first time here. Thanks for being here. We're discussing neural networks. Asilbek says, please save video. Yeah, the video are always saved on my YouTube, okay? And I also have a playlist just for this neural network series and all the series that I do. Okay, so Fabrizio is coming up with an estimate of 2 hours for it to run. Yeah, and that's fine, Fabrizio. It's good to understand exactly how long some of these will take. Unfortunately, I'm going to have to kind of play around with this a little bit because there's still some things I want to teach and get across that I can only do if I kind of cut down our grid search, right? Because, my point to you is not to do a grid. My point here is not to do a grid search in front of you. My point is to help you understand some of the best practices around grid searches and what we could be doing with them, right? So I want to kind of make a point here. So as you can see here, this is going to run a little bit more. How many different permutations did I add? 2 times 2 is 4. So 4 different Is that right? Yeah, 4 different permutations to run in this combination, right? So times the 3 is 12 times the 3 for cross validation is going to be a series of 12 runs here. So we're already 1, 2, 3, 4, 5, 6, 7, 8. We're already on run number 8. So this is going to end fairly quickly. You can see here, actually, if you look at the activation, the model activation line, you can see that has already changed, right? We already completed all permutations of ReLU, and now we're going to go to the next permutation. You can see that in the line here, right? And then I think that's all I changed, right? Okay, no, the 64s, right? You can see here, we're still at the batch size of 64, and I'm pretty sure I did a second permutation on that, didn't I? No, the neurons I did. I changed the neurons to 128. So are we seeing that change? Yeah, here we go. You see that? It went from 64 neurons here to 128 neurons here. Or same thing here. It went from 64 neurons to 128 neurons in the very next line. So those are the different experiments and different items that it's trying, right? So let's finish this out, and then I kind of want, I'm looking to make a point here. This is just going to take another second or two. There we go. Okay. So it finished out. This is, now we are up to an accuracy of 9569 that you can see here. Excuse me, 9609 is the best model, 9609. And here, you can see that it's a little better, right? The previous confusion matrix had a lot of values in the 20s. Now we really only have one value in the 20s, right? There's a 23 down here. Some of these numbers here are significantly lower than they were. This one is still high, the 2s and 7s. This one is still high, the 9s and 4s. 9s and 8s still seem a little high. But you can see how the texture of the results, of the errors rather, has changed, right? Has arguably improved, right? So here's where I'm going with this. If we go back and we look at our grid search log, our grid search log now has a few more entries, right? And is that right? Yeah, that's right. So there's 5 entries because it's still maintaining the previous one we did, right? The 9423. But now it's added the 4 additional permutations that we tried, right? Because if we were to look at these settings, that represents the 4 different permutations here in this latest parameter grid, right? So one of the things that I've done sometimes, and that you can do, and you'll need to do this because you're short on time, you're short on resources, whatever the case may be, you can go in here and you can start to kind of guide your work, right? Can anybody tell me an observation that they want to make based on this? Anything jumping out at anybody? Because remember, these are experiments, right? These are our results. Result interpretation, huge part of data science. And it's not just, hey, let me take these numbers and put them in a nice visualization and talk about them to my stakeholder. That's what people think is result interpretation means. But this here is a practice of result interpretation, right? And it's one of the many reasons why we want to do the logging. There's nothing to interpret if you don't log, right? But is there something here that somebody wants to point out? What do you guys think? Anything jumping out? Anything that could help us here? What do you guys think? Yeah, Yassine. Yassine got it right away. ReLU generally performs better. Yeah, right? There's data for you to say, hey, maybe we should only focus on the ReLU function, right? In both instances of these two tests, we did better than the other functions. Now, you'll notice that between 64 and 128, there's no difference yet, right? But there is in the function. So we can't draw conclusions or infer anything from the number of nodes. But we can look at, hey, maybe we need to focus on this activation function and less on this one. And if you can drop that one permutation from your grid search, haven't you exponentially helped or reduced the time that your grid search is going to take? Like, yeah, you have, right? You've done great there, right? Manoj says, agree with Yassine. Yeah, I think there's a lot of reasons to agree with Yassine there. Fabrizio says the fourth row is better. Yeah, sure, Fabrizio, but it's more about the experiments as a whole, right? We're not looking to pick a winner just yet. We've only run 4 experiments. We want to run thousands of these experiments over the life cycle of the development, right? Not just in a single shot, but so we're not ready to say this is better, but we are ready to make inferences, right? Okay, so Osama says the number of epochs doesn't have a real impact. Yeah, that's another fair inference, right? Now, I think there's a lot of ways to interpret that, because you could also be saying 20 epochs is not enough, right? Right? Not having an impact could be the same as you haven't done it long enough, right? But Osama's right. Like there's things we can infer from the epochs. 20 doesn't seem to be a sufficient number. But we have data to back up and say, okay, the next time when we expand our grid search, guess what? I'm just going to focus on this activation function. Right? Like we have the data, we have the experiments to back up that statement. Another thing, and actually, kind of coming back to Fabrizio's point, another thing we could also say, coming back to that fourth line that Fabrizio pointed out, is we could say that we have a baseline. We know that we shouldn't be experimenting with other settings, other models, right? Because we should be trying other things besides neural networks. We shouldn't be excited or investing time in other models that can't get us to our baseline. So it's early in the process and all that. But you could say, hey, we have a baseline of 9534. We know how to get to 9534. We have the settings saved for that. So why would you want to invest in something that's getting like 90, 91, 993? You have your baseline's up here. Don't bother with the stuff that's down here. Always look to beat that baseline, right? So that is something that we could draw from line 4 there. Okay, so let's go back. So I like the observation about the epochs. So we're going to go ahead and add another set of epochs there, Osama. We've seen data to say, hey, let's just focus on this. And we don't have anything to help us with dropout rate. So there is nothing, or rather there's reason to believe that we can experiment further with dropout rate, right? So let's go ahead and add this. So what have we done to our runtime of this experiment? Have we increased it or decreased it, guys? What have we done? Ugh, I'm out of coffee. What have we done, guys? What's the net impact here of these changes that we've done? What do you guys think? Let me know in the chat. Yassine says increase. Yeah, we have, right? By my count, we have increased by an exponential of a net 1, right? Because we removed the activation function, which is a -1. We added a dropout rate, which is a +1, or gets us back to 0 to no change. And then we added another set of epochs to test. So yeah, we have exponentially increased by 1. Or a net increase, I should say, by 1. Starry Vibe says decrease. No, Starry Vibes, I'm sorry. We've definitely increased our runtime, right? Because we've added more parameters than we removed. We removed 1 parameter and we added 2. But messing with the dropout rate and messing with the epochs, usually a good idea, right? So let's get this running, because we know it's going to take a little bit of time. Yeah, so Osama says increase. Manoj says increase. Yeah, guys. So you're getting it. So yeah, we're definitely going to be waiting a little bit more here. And you can see here, previously we tested 12 different fits. Now we're going to be trying 24 different fits. And it says that we have 8 candidates. Is that right? I think that's about right. 8 candidates. 2 times 2 is 4, times 2 is 8. Yeah, we are trying 8 different permutations, right? So 8 different permutations, but because of the cross-validation and all that, it actually becomes 24 different runs that we're doing. Starry Vibe says, yes, I saw just 2 parameters. Yeah, Starry Vibes, we definitely a net 1 increase. So now we wait. And it's also going to take a little bit longer because we also increased our epochs, right? So based on Osama's observation that epochs hasn't had an impact yet, I think we doubled the number of epochs. Oh, excuse me, we 2.5'd it, right? So we're trying both 20 epochs and 50 epochs, and we're going to see what that is, right? Maybe that'll let us draw a conclusion and say, oh, epochs, it doesn't matter. We'll get the same at 20 as we'll get at 50, so you might as well go with 20 and save yourself the time, right? So while we're waiting, going back to the list, we've done our research, our grid search. We are in the process of documenting our results. So we're going to let this run. But what we really want to get to is we want to get to a saved model, right? Right now, we're just letting it run, and we kind of sort of know how to get back to the model, because guess what, guys? This CSV also kind of becomes like a recipe book, right? because now this is a recipe for you to say, if I ever get, if I ever lose my code or something happens, I can just say, write me a neural network with these settings, and I should be able to get back to approximately that level of accuracy, right? We've talked about a little bit of the randomization that happens and why you wouldn't get the exact number, but you'll know how to kind of be in that range as long as you use these same settings, right? Like I said, it becomes like a recipe. I need a neural network with 64 nodes. If I run it for 20 epochs with this activation function, I should be able roughly to get to this accuracy. Right? And that's a good thing. The way we definitely get back to that accuracy is by saving the model, saving the weights file, right? And that's what we're going to do when we finish this run. So let's see where we're at. Okay, so it's still going. It's still going to take a little bit of time. But I think that we can actually write that prompt now. So let's go ahead and take care of that prompt. So we're going to encourage ChatGPT. Okay, so this is another trick I'm going to share with you guys. If you see the grid search and how there's many permutations, and you're running this multiple times. Like I said, a grid search is not a one-time thing. You can see how this CSV file is going to quickly grow, right? Right now, we're kind of doing an abbreviated search, just kind of for time for this stream. But when you're doing 5, 6, 7 different settings for each hyperparameter, you're going to get into the thousands of permutations really quick. So one of the tricks that I use is I make the accuracy part of my model name, because you're going to get so caught up in, what was that save file? Was it the third run? Was it the fourth run? Just go ahead and make your metric part of the name. In some cases, I've also used the parameters for the network as part of the file name. But this way you can quickly refer, and you can always say, okay, yeah, let me go to that one because that one had the highest accuracy. Let me go ahead and use that model in my prediction, right? So that's what we're going to do here. We're going to say, give the file a unique name, but also include the accuracy as part of the name. That way you can quickly refer to it, right? Or in some cases, what you can also do is you can choose to give it the same name and then give the accuracy added to the file name. And then you can just sort really quick and say, whatever's at the top of this list is my best model, right? And you're going to do that simply because you're going to have a lot of models very, very quickly, right? So we're going to ask it to do that, see what code it comes back with. Okay. So it's going to have it's going to create a save models directory. And then I assume that it's going to be all the way down here. That's your logging. Here we go. So down here is where it's saving the model. All of that is just for saving the model. Um, there's the file name. Yeah, and then here it's going to just, best model is where it's up here. It's coming from the grid results, and it's going to save it in there. So yeah, that makes perfect sense. That's totally reasonable code. So we're going to go ahead and copy that over. And I want to put this in its own file. So let me go ahead and set that up in NN7. And I'm putting that in its own file because I don't want to lose the grid searching that we've done here. Go ahead and do this. And do that. Okay. So we're going to come back to this. We're not going to execute this just yet. But let's see how our current run is going. So our current run, it's going pretty well. We know it's going to run 24 different times, right? 24 different permutations times the cross-validation. But we're just going to, kind of hang tight here and see how it goes. I have a feeling it's going to finish in, right? Yeah, it's going to finish in. It's in the 20s. So let's just hang tight here, guys. G14 over on Twitch. Welcome. G14, you are my 200th 200 followers on Twitch. So thank you for that. Nice to have you. How is Relu getting a nonlinear relationship? And what does it mean getting nonlinear relationship? Fabrizio, where are you getting that from? Help us understand the source on that. That is 200 followers on Twitch, guys. That's fantastic. So welcome, G14. All right, this is going to take just a little bit more time. It's funny because you can see here, this is our 64 neurons, and that's taking 29 seconds, 34 seconds. But as soon as we go to our 128 neuron model, 47 seconds, 52 seconds. So this also helps illustrate a little bit about how the size of the neural network affects your training time, right? So I think that's pretty neat. All right, give this a little bit more time to run, guys. We should be getting pretty close to the end. And there's actually one more change we could make on NN7. We could cut down the cross-validation. That's going to also have a significant impact on the processing time. We have run, I think, 5 experiments so far. Yeah, we've run 5 experiments. So line 7 is where the new entries will be. Okay, there we go, guys. So here's our new confusion matrix. Not so great, right? There's a 27, a 12, an 11, a 19. Over here, there's a 13, a 12. So there's a 10. So some improvement on this side of the grid, not so great on this side, right? There's some terrible numbers over here with the 9, the 7, the 8, right? So those are not great numbers. If we go to our grid search, there we go. So we said we were up to lines, we said that line 7 would be the start, right? So these are all our new results. What do you guys think? Anything jumping out at anybody? What do you guys think? Anybody want to make any observations? Excuse me, guys. What do you guys think? Any numbers jumping out at anybody? Osama says 11th row is better. With 50 epochs. Okay. Yeah, that's one observation. Anything else? Yassine says a lower learning rate is better. Did we adjust the learning rate? I don't think we did we? We haven't adjusted the learning rate, my friend. We've only tried one permutation. Yeah, Osama says row 12. I thought that's what you meant too, Osama. Oh, yeah. I mean, 12 is the best of this run, right? And we can also say that that's our new baseline, right? Because we did beat our previous baseline. Our previous baseline, as Fabrizio pointed out, was row 4, 9534. But yeah, you're right, Osama. We have a new baseline, right? Line 12 is now a better result. But here's what's catching my eye, guys. What's catching my eye is the dropout rate. The dropout rate stinks, right? When we change the dropout rate, which is this value, right, the 0.5, we tried either 0.5 or 0.3, it's terrible. Here we got a 9.1, here we got a 9.3, here we got another 9.1, and here we got another 9.3. Why would we want to be at 9.1, 9.3 when we know that our baseline is already above 9.5, right? So we can confidently say that the higher dropout rates are probably not where we want to be. We could try lower ones. We can eliminate lower dropout rates. But if we were to just stay at 0.3, we're still going to get better results than going to 0.5, right? I think that's a reasonable inference from our data. But again, The meta point that I'm trying to make to you guys here is that you can't make those statements unless you're doing this, unless you're logging your results, right? And this is why we want to log our results. Because we can sit here and we can say, okay, you know what? I'm going to use my powers of observation and infer results here. It's totally reasonable for you to infer these results. So I'm willing to say that, hey, we can hold the dropout rate at 0.3, and we can certainly experiment with lower values, but we probably don't want to go higher than that, right? So Starry Vibe says, I think the more batch is better, but we haven't adjusted batch size, right? Batch size stayed the same. We haven't conducted any experiments on batch size. So Starry Vibes, you mentioned batch size. Yassine, you mentioned learning rate. There's no experiments there, guys. We're just doing one value. If it's just one value, it's not an experiment. It's a hyperparameter setting, but we haven't tried anything. Now, just so we're clear on this, right? I'm showing you a slimmed down version because, of time constraints, right? I'm trying to show you here in a single stream. But it really should look a lot more like this. And quite frankly, this is a little bit small. Like, this is the kind of thing where on a Friday, you want to fill this out with as many values as possible, that are reasonable, that make sense. And just let it run for the weekend, right? Leave your computer on and just let it run for the weekend when you leave the office. Right? But this still serves as a learning exercise where you can't make that inference, Starry Vibes, because we haven't tried anything. We haven't tried additional batch sizes. We've held it steady at 64. Okay, Starry Vibe says, I think it's the number of neurons. Yes, we did adjust the neurons. There we did try 64 and 128. So Starry Vibes is saying that has an effect. Does that have an effect? Let's see. We said line 7, right? So line 7, 64, 128, 64, 128, 64, 128. Yeah, okay. Yeah, I agree with that. So Starry Vibes, I think, is making a valid observation there, or inference there, right? That the models with 128 neurons tend to perform better, right? So that gives us additional guidance to go on. So yeah, I think that's totally reasonable. So let's go back to our new model. Remember, now we're going to focus on NN7, the seventh file. And this time, we're saving the model, right? Which will be key. So let's work on some of this. So we'll take Starry Vibes. We're going to eliminate the 64 neuron models. We said the higher dropout rates stink. And what about epochs? Did we make an inference on epochs? I want to say that it's neutral, right? Because line 11 and line 7 are the same experiment, just more epochs, right? See, and after a while, you kind of develop an eye to be able to read the CSV. Because that's what I'm drawing, right? Line 7 and line 11 are the same experiment with just different epochs, right? This is 20, this is 50. So that means that line 8 and line 12 are also the same with basically no difference, right? So let's go ahead and remove that and let's stick with 20. You could decide to stick with 50, but for the sake of time, I'm going to say stick with 20. So everything that we've done, can we add 256 neurons? Yeah, let's do that. We'll add 256 for Starry Vibes request. But everything we've done has led us to infer that this is an improved base for us to start from, right? So let's go ahead and run this grid search. This is NN7, and this time we're also going to save this model, guys. Remember, we've asked ChatGPT to add code to save a file, to save the file. Okay, what is this? The CV parameter grid must be in a range of 2. Okay, yeah, it didn't like me changing it to 1. That's fine. We'll change it to 2. All right. So this time it's going to run it 6 different times. The models are a little bit bigger, so it's going to take just a little bit more time. All right, so if you're joining us late, welcome. It's a good time to say hello and introduce yourself. It looks like we're going to be waiting about 2 minutes here because each one is taking about 18 seconds. The larger ones are going to take a little bit more time, right? Because we're trying 64 and 128, we said. No, 128 and 256 is what we're trying. So they're going to take a little bit longer, but we're going to be here for about 2 minutes waiting for these to finish. It already finished the 128. Actually, no, it's only done. Yeah, that's already finished with the 128. Okay, so there's the 256s. So we'll see if Starry Vibe's observation of, more neurons, more better holds up here. All right, I think this should be the last run. Right. So we should be getting to a confusion matrix here. All right, there we go. So here's our confusion matrix. Not great, right? 23, 23, 20, 18, 22. Not a great model. Not a great model, but that's okay. It's part of the experimentation, right? Good thing we have the ability to run hundreds and thousands of tests, right? The important part is here. notice that we now have a new folder called Saved Models. And here is our mince model. It's given it a unique name. And you can tell that it's also assigned it the accuracy of 9574, which matches what we have here, 9574. Here's the accuracy from the best model, right? So the beauty of this is that as we do these grid searches, we'll have a record of all these models that we can refer to in the future and say, oh, wait a minute, this is terrible. Let's go back to the other model. Or you're going to be swamped in models very, very quickly, right? It's going to be just something that's just part of what you do, right? So give me just a second. I want to do something very quickly. Let me just execute this. While we're waiting for that to finish, we're going to go ahead and repeat the same exercise, right? These, what is it? These 3 lines here represent our new tests, right? Oh, wait, hold on a second. Yeah, that's right. Actually, no, it's just these 2 lines. These 2 lines represent our new tests. We had a 128 and a 256, right? That's the only test we did. What do you guys think? And by the way, ignore line 17 for now because that's the one I just ran really quickly right now. But what do you guys think about lines 15 and 16? Because that's kind of like the slimmed down version we ran when we just wanted to try 128 neurons versus 256. What do you guys think? Anybody want to make an inference there? Again, what we're going through, guys, this result interpretation, super, super critical skill, right? Because you can see here how if you use this skill right, you can save yourself a lot of time, right? You're making data-driven decisions even within your own testing, your own work, right? But what do you guys think? Any observations here? Nobody? It's only 2 results, guys. Okay. So Yassine says maybe focus on other parameters. The number of neurons is neutral. Yeah. That's a totally reasonable inference, right? We can say, hey, look, 128, 256, we didn't really see a big difference. I mean, there is a slight improvement, but it's to the 4th digit, right? The previous model, 50 epochs, 128 nodes is better. Yeah, right? 50 epochs, 128 nodes. Yeah, Osama, I think I see where you're going with that. Osama is basically saying, hey, the baseline still holds. Our baseline is still higher, right? When we did it for 50 epochs and only 128 neurons, didn't beat the baseline. 256 neurons didn't beat the baseline. Totally reasonable to draw that type of conclusion, right? Yeah. Now, it still might be worthwhile to try more neurons, right? Because in theory, more neurons should help. But right here, we can say it's kind of a neutral change. Now, here's the new line. Now, this is an experiment I ran really quickly. I only ran it with 16 neurons, 20 epochs, 0.89 accuracy, right? Not surprising, right? 16 neurons, not a lot. But here's why I wanted to do that. So, oops. Okay. So here's why I wanted to do this, guys. Here's the model that we just ran, right? The 9574 with where we tried the 128 versus the 256 neurons, right? We came up with a quick hypothesis. We tried it. It's kind of a neutral result. Here's the quick test I ran for 16 nodes. 0.881 accuracy, right? And that's fine. I wasn't expecting anything more than that. But look at this. Look at this size versus this size. This is what? This is 189 kilobytes versus, what is this? 3.2 megabytes. Which model do you think is going to load faster and work faster? Which model is going to take up less space on your mobile app deployment, on your embedded chip deployment? You see it? Like, model size matters, guys. Node selection matters. That's a massive difference. I mean, what is that? 189K versus 3.2 megabytes is what? That's a difference of 15x, like 12x, right? This model is like 12x the size of this model, right? It makes a difference. It makes a difference how you choose to do this. So, earlier we were having the discussion, well, more epochs or just add more nodes or add more layers, but this is the net result. That's not without its consequences. Now, sometimes it won't matter, right? You could be working on some enterprise app and you have tons of space. It doesn't matter. But in a lot of times it will. And if you think about it, these two models, yeah, I mean, you probably don't want to use a model with 88 accuracy, but they're not too far apart from one another, right? But in size difference, they are way, way, way apart. This difference is not 10x, 12x, 15x, right? But this difference is. So keep that in mind, guys. The experiments, the layers, the nodes, it matters. It matters a lot. Okay? I hope that's coming across there. Okay. So Fabrizio says, Dennis, in this experiment, how many layers are you using? Yeah, good question. I think it's just 2. It's 2 layers. Yeah. No, actually it's 3, sorry. It's 3 layers, 3 dense layers that are being used. Okay. So I just want to stress this one more time. I'm showing this to you guys because because of time limitations on a single stream, and also because it helps me kind of help you guys understand how you can infer where you're guiding your future experiments based on your past experiments, because grid searches are not a one-time thing. So you run your grid search, you go look at your results, your logs, you run your grid search, go look at your logs, and you can kind of like knock it into shape and say, oh, okay, this is where I want to go next. I want to try higher values here, but lower values here. Okay, it's headed in this direction. Yeah, that beat my baseline. No, that didn't beat my base. This is like the thought pattern that you use as a data scientist, right? So just so we're clear, it should be a lot broader than this. It should look a lot more like this, even more complex than this. But I want to move on to the next portion. We're going to pretend that we did all these grid searches, we let it run over the weekend, we did all these things, and we came up with this model here. Well, let me refresh this. Yeah. We came up with this model here. This is now our champion model. It got us to what was it? A 0.9574 accuracy. We're going to say, hey, this is the model we're going with, right? But you have nothing to deliver right now. There's nothing for you to hand over right now, right? Because you're not going to hand over this file. This is your training code file. You don't deploy that, right? That's kind of like an internal function. And you can't hand over the weights file because it's important, but it's useless to your stakeholder. Your stakeholders don't want a weights file. They want a finished model, right? So that's our next goal here. How do we actually use this weights file, right? So if we go back to our list, this is the fourth item that we set out to do. How do we actually do the prediction cycles, using these models, right? Like this is like the end game of it all, right? So let's go back to ChatGPT, right? Because we don't write code, our employee does. Okay. So this is, I think, a reasonable prompt for what we need. So now what we're saying is we want a brand new Python file, I want to specify, that uses a model from the Save Models folder. It runs a prediction cycle on a brand new input. It should take the input, which we know has to be an image, right? And then tell me what the number is using the algorithm from the save file. And then we're going to say, please include a test harness where it could randomly pick an image from the MINTS data set, show me the image visually, right? So that way we'll know the answer ahead of time, and then tell me what the algorithm said what it was. So we should be able to get that in a single file. Let's see what ChatGPT comes up with. So let's copy this. And now we're going to go back to our VS Code. We're going to start a new file. And we're going to call this NN prediction. Because remember, we're done with training now. Now we are actually at the prediction side, or kind of like the deployment side, right? So let's see what it does. Loads the most recent MINTS model from save models, picks a random test image, displays it, runs a prediction, and prints the predicted digit. Okay. So it's going to find the latest model based on, I guess, date, right? Yeah, most recently modified model, which is okay. You know, that's not a bad idea, except that sometimes your latest run isn't your best run, right? There's no guarantee that your latest run is your best run. You kind of want that, but there's no guarantee of that. And we have that scenario, right? Because we know that our latest run was a bad one intentionally, right? And we knew, because I was trying to use something that had a smaller network size, right? But you know what? We're going to go ahead and continue with that because it's more likely to make mistakes, and I kind of want us to see that, right? So we're going to go ahead and keep that. But keep in mind that we could also just be hard coding it in here, right? In most deliveries, you're going to be hard coding and say, look, here's the weights file. We know it's a good file. We refine the model via 3,000 tests. So go ahead and hard code it in here. That's not a terrible practice. It has the test data. It's going to randomly pick an image. It's also going to do the pre-processing. It's going to find the latest model, load the test data, random selection of the item, display the image, and then it's going to pre-process it, predict it, and then output the predicted label. This is great. I think ChatGPT did a reasonable job of interpreting our needs. So let's go ahead and run this. Oh, here. And it's going to be NN prediction. Okay. So here's the number. What do you guys think? What number does it look like? Let me know in the chat. This is us being the human in the middle, right? What are we expecting the algorithm to tell us? Let me know in the chat. What are we expecting here, guys? Starry Vibes saying 1. Yassine 1. Okay, yeah, so everybody's kind of voting 1, right? Now remember, that's us being the human, right? And we're putting it up against a model that's little iffy, right? It's only an 88% model, and we know that the 1 has had problems with 7s, right? We've seen that in the confusion matrix. So if we close this out, it should give us an answer, right? Okay. So it's giving us a predicted label of 1 with a confidence of 1.00. Great, right? That's not bad. Let's do it again. Okay, what about this one, guys? This is our next one. What number is this? I don't know. It could be a 9, right, guys? Oh, it tells us. It tells us at the top the true label. Okay. So it's telling us that this is labeled as a 4, right? Because obviously the mince is a supervised data set, right? So it's telling us it's a 4. But it could be a 9, right? We know that 4 and 9 is kind of problematic in the algorithm, right? So let's see what it says. Okay. Okay, so check that out, guys. It tells us that it's a 4, but look at the confidence. Is anybody happy with that confidence level? It's a little bit better than a coin flip, right? 5419. That's not very high. On the first one, on the 1, we had a perfect confidence rating, right? But on this one, this is the algorithm telling you, I kind of think it's a 4, right? Yeah, Manoj says nope. Yeah, it's not a great confidence at all, right? Let's run it again. I can't wait for an 8 or a 3 to come up. Oh, there it is. Okay, so there's an 8, right? But that clearly looks like an 8, right? I don't think it'll have trouble with something like this, right? I think this will clearly be an 8. Although I guess it could be a 9 sometimes to the algorithm, right? So the algorithm says 8, and it's like a 90% confidence. So not a perfect confidence, right? We know what a perfect confidence looks like. But, it gave a reasonable confidence rate. Let's run it again. That's a 6. I don't expect that it would have problems with this, right? I mean, kind of hard to go wrong here. So I'm expecting a fairly high confidence rating on this, right? I'm expecting that it'll tell us it's a 6 and it'll give us a pretty high confidence on that. Kind of hard to look like anything else, right? So it's a 6 with a confidence of 0.8701. Not as high as the previous one, but reasonable. I'm surprised it's that low. Let's run it again. What do you think, chat? So if I remember right, the 7s were having problems with the 2s, right? 7 and 2s, were kind of problematic. Maybe this could even look like a 9 in some cases, right? Yeah, Yassine says it could also be a 1. Yeah. So maybe we're not expecting a high confidence here, right? Even if it's right, it might not give it a high confidence, right? But yeah, some people could say it looks like a 1. Oh, wow. It said it's a 7 with a very high confidence. I'm a little surprised by that. Anybody else surprised by that? It gave it a near perfect confidence level, right? I'm surprised by that. Anybody else? Let me know. Let's keep going. I want to get more 8s and 3s. I want us to get to an error. Okay. This seems fairly straightforward. Maybe that's a 6 sometimes, right? Because the bottom is a little fat. So maybe that's a 6 sometimes, but I think that's a 1 a lot of the times. Yeah, so that's a 1 with a very high confidence, just like the first one that we saw, right? Let's keep going. This is our first time seeing a 2. I think that's fairly high confidence. Yeah, it's a 2 with a confidence of 0.997. So here's an observation we should be making here, guys, right? Remember that this was a terrible model. It's only 16 nodes. The accuracy was 0.88 something, right? But we're not getting terrible results. We could be experiencing some positive variance here, right? That we're not getting a lot of the numbers that are getting errors, right? But it goes to show that even a model with not great accuracy from a anecdotal or, like a small sample type of perspective, not performing that terribly, right? I mean, this isn't bad. This is a 6, it's got a little bit of a longer tail, but I don't think that's going to throw it off. Maybe this is a 4 sometimes to the algorithm, but that looks mostly like a 6. Oh, look at this, guys. This time it said it's a 6, so it was correct, but it's the lowest confidence we've ever seen, right? That's less than like a coin flip. So that means it's spreading out its guesses over other numbers. So maybe it gave a little bit of confidence to a 4, or maybe to like, I don't know, like a 2 maybe, or a 9. I mean, I don't know what other number would confuse it with, right? But the confidence was not great on a 6. But still ultimately correct, right? The confidence level tells you a little bit about like kind of like what the algorithm's thinking, right? Because remember, algorithms are not perfect. They just give you the most probable answer. So this was the highest confidence level of the other ones. But to us as humans, the answer is kind of binary, right? Like you either identified it as a 6 or you didn't, right? So to me, this kind of illustrates how it illustrates or emphasizes the concept that algorithms give you the most probabilistic answer, not necessarily the right answer. So here we can say, oh, this algorithm is great. It gave us a 6. But underneath the hood, it gave us the right answer. But underneath the hood, kind of a shaky answer, right? Maybe not thin ice, but not the greatest confidence level, right? Let's go one more time. This is, I don't know, to me this always looks like a 4, right? Maybe sometimes the algorithm thinks it's a 9. Yeah, so it's a 4 with fairly high confidence. Let's keep going. That's an 8. Maybe sometimes the algorithm thinks it's a 9. Okay, so it's an 8 with an 84 confidence. That's not unreasonable. We haven't seen a lot of 3s. Okay, that's a 4. I think that's basically always a 4. Yep, 9972. Let's keep going. That's an 8. Maybe sometimes it thinks it's a 7 or a 3. I think 8s and 3s, we're getting a lot of errors in our confusion matrix, but a reasonable 8. Oh, look, that's our first error, guys. Did you guys see that? That's our error. It thought it was a 3, but it was clearly an 8. And if you remember, it was because the top of the 8 wasn't fully completed, right? There was a small separation there. So there's our first error, guys. It was an 8, but the prediction was a 3. So very interesting, right? Okay, so what have we learned here? I love going through those answers because this is what I mean when I tell people, I don't care if you're good at probabilities from the academic perspective, because probabilities from the academic perspective are very math intensive, I think overly so. But I do care that you know about probabilities from what it means when you're deploying a model of 0.88. It means that you're going to be wrong 1 in 10 times, right? it means that you're going to get low confidence levels like this that also make errors, right? So I hope that that's coming across. But what I really want to leave you guys with is that this file right here is the first file that we can actually hand over as a deliverable. We haven't done anything as a data science team from a business perspective until you have a file like this that you can hand over. Everything else we've done has just been experimentation, has been, kind of like the data science work, has been stuff that you discuss among yourselves in the team room, in the data science meetings. Like, you would never hand this file over to your stakeholders. Like, this is useless to them. The weights file is also useless to them, right? The grid search log is also useless to them. But when you start to do this, to do these predictions, to actually say, hey, take in brand new data, right? Accept data from the user. Now you're doing something that people can rely on, right? That people can use, that they can integrate in other packages. And now you can say, here's my saved weights file. Here's the Python code that calls that weight file. Use this and you're going to get an answer. Or, hey, this is the code that I'm going to use to run the API endpoint that other people are going to call. And that endpoint receives an image of a number, and we just return the answer from the algorithm, right? We're not training, we're not trying new parameters. That's all done. That's in the past. Getting to that prediction file, like that's the deliverable, right? That's the software that your team is delivering, right? Super critical to understand that, because you don't have anything until you get to this stage, right? You don't have anything until you basically finish these 4 items. Last week, we were kind of as I said, at an exploratory phase, kind of just feeling it out. There might be a viable answer here. But these 4 steps, as you can see that we took them in series, that's where you're stepping up to something that is a pro-grade experiment, data-driven decisions, model creation that is then successfully used by an end user, by another team, some non-data science team, right? And that's it. That's what we have, right? And also, just one more thing is that you can also see how when we did this, it runs faster, right? And you can run this over and over again. And then that feeds back to everything we talked about the size of the model and the speed. Because here we're testing it kind of just in a fun way. But that's another requirement they could tell you. They could say, yeah, by the way, we need you to do this algorithm. And we need the algorithm we're going to be querying the algorithm 1,000 times a minute. Or whatever, 10 times a second, or whatever it is that they come back to you with. Well, you need something that runs quick, right? Here's the image, here's the answer. Here's the image, here's the answer. That's not to be taken lightly. That's where your enterprise application development skills come into play, right? This is where it's a lot more of a software engineer exercise than it is data scientist, if that makes sense, right? Because at this stage, somebody could look at this and say, yeah, great, algorithm works well, but I need this to be fast. Well, making it faster isn't always a data science exercise. It's more of a traditional software development, right? And that's okay. You can do that. But there's a skill to that, right? All right, guys. Well, I think I hit all of the 4 items I wanted to hit today. So good news. That means there's going to be a part 8 to this neural networks. because we can't talk about neural networks without also talking about generative adversarial networks. So we're going to talk about that next week, which is good because I didn't want to cram that into today's session. Today's session has been long enough. But I hope that you'll be excited about the generative adversarial networks because it makes sense to start looking at as the next step given where we are today with everything else. So lots of good stuff covered today. I hope that I've given you some things to think about, some things to build on, because a lot of what we did today is kind of like the day-to-day work of a data scientist. Like if you didn't enjoy today's session, you're not going to enjoy the work of being a data scientist because this is basically like a lot of what you do, right? Like, yes, you have to do data collection and come up with pretty charts and visualizations. But what we did today is kind of like the in the trenches work of being a data scientist. Like this is like what we produce as data scientists, right? So I hope you guys enjoyed that. Lots of stuff covered today, guys. So really good work. Thanks for hanging in there with me. So yeah, we'll pick this up again next weekend with part 8 of neural networks. Okay. So as always, everybody, we live in such a crazy and dynamic world. So, I worry about all of you. Thanks for joining me today. Take care of yourselves. Take care of your families, and I'll see you guys next time. All right, so let's continue our next installment of neural networks. If you remember from the last session, I kind of said that there was 2 more things that I wanted to accomplish, right? I wanted to accomplish pro-grade neural networks, and I wanted to have us talk about generative adversarial networks. Kind of hard to have a series on neural networks without talking about that second one, right? So as a form of review, I want to talk about the pro-grade neural network work that we did last week because we covered quite a bit of ground last week. We wrote a lot of good code, but we also kind of elevated our code in our approach, right? And these are the 4 different items that I highlighted as kind of being necessary to be able to say like, yeah, this is a professional level of data science that we're doing here, right? This isn't just fooling around with code. This is actually like simulates what you would be doing in a working environment, right? So as a form of review, let's go through the 4 of these. And we'll go in order on these 4 for this one. Usually I don't care about the order. But in the chat, go ahead and tell me what is a grid search or what is the purpose of a grid search? Like why do you want to do that? Let me know in the chat, okay? I'll give you guys a minute to think about that. But why do a grid search, right? The grid search kind of kicks off this series of 4 different items, but why do we care about these? Let me know. Let me know in the chat. Osama, our good friend Osama says, hi, sir. Happy Sunday. I hope everything is going well. Happy Sunday to you too, Osama. Everything's going really well. We're just getting started here with what is potentially our last in this series on neural networks. But everything is going very well. It's been a good week. It's been a good week. So thank you for asking. Hope the same for you, my friend. Over on Instagram, I think it's Verka. Verka says, thank you for uploading videos for us and making the DS journey more happy to digest. Thank you for that. I appreciate that. Yeah, I mean, I think that's a good way of putting it, making the data science journey more happy to digest. Yeah, sure. I guess I also just try to make it less intimidating, right? I want to make sure that everyone's taking a professional approach to data science, but while at the same time making it less intimidating. So yeah, I appreciate that that's something you guys take away from it. So thank you for that. So Verka, you're welcome to stay over on Instagram, but you can also come over to YouTube if you want to get the wider screen view, okay? Manoj says, which machine did you buy, Dennis? I actually so I'm a Mac guy. I love working on Macs. I made the move to Macs maybe like 12 years ago, something like that. So I usually like the Mac Mini, but I decided to buy myself a Mac Studio. So it's a little bit of a step up. It's got much more GPU processing power. And we'll see if we can maximize that work today. The Mac Mini is a very capable machine. It was an M1 Mac Mini. And if you guys, and I know some of you, and I think this applies to you, Manoj. You've seen me work on it with the GPU testing that we did, right? So I do try to maximize the GPU on that. But now with the new machine, this is an M4 Max chipset, I believe. I believe that's what it's called. So there's the M1, there's the M1 Pro, and there's the M1 Max, I believe. So I got the Max, and I got a lot more memory than I had before. I got a bigger hard drive SSD in there. So it should be a much more capable machine than what I had before. But yeah, so maybe we'll see some of that today. So again, the question in the chat, guys, is why do we do a grid search? What's the purpose of it, right? So think about that while I address a couple more chats over on Instagram. Rayan says, is industrial engineering a good degree to get into data science, since industrial engineering has a lot of base in business and analysis in order to gain understanding on the fundamentals of data science and analytics? Sure. That's completely reasonable for you to draw that conclusion. But just make sure you're getting into data science because you like data science, as opposed to liking industrial engineering, right? That would be my only advice to you. But yeah, what you're saying is completely reasonable. Verka over on Instagram says, yes, thank you. Well, thank you to you too, Verka. Thanks for being here. Slothy Walker, what a name, says, I'm very sorry to ask this. I am not sure if this is the place to ask. I have been working as a data scientist in a startup and now want to move to a big MNC companies. What could be a path to do so? Big MNC companies. Not really sure what you mean by MNC. Sorry, I don't know that acronym. But Slothy Walker, if you'd like to, message me on that, those are the types of topics that I prefer to answer via one-on-one coaching, because it can be a long answer and it can also be an answer that's tailored just for you. So feel free to message me on that. And also on Sundays, I tend to focus on, on the task at hand here. Slothy Walker says multinational company. Okay. Yeah, it can be done, right? The jobs are out there, but every situation is different. Your background, your education, your motivations, your goals for it, as far as locations and titles and things like that. It's a very involved discussion, right? Okay, so let's get back to the task at hand. So I'm seeing some answers already. Okay, so Osama says, I believe the main role is hyperparameter tuning. Okay, cool. But why is hyperparameter tuning important, Osama? Why do we do that? Chet says, grid search is experimentation with model hyperparameters to improve performance. Nice, yeah. Yeah, not to nitpick, but it's not just improving performance, but it's also just trying to find a viable model, right? Because you don't really have a viable model until you can say yeah, we're within a reasonable range of hyperparameters that indicate that we can get to a good model, right? So if you guys remember, as I mentioned last week, what we did last week was kind of something that you would actually deliver, and you would actually say, hey, this is the work we've done. Prior to that, we were just kind of experimenting and just kind of trying things out, right? And that's another big part of data science that nobody talks to you about. For me, whenever somebody would approach, a business team would approach us for a project, you don't just say yes, or you don't just say no. you say, hey, give me a couple days to work on this, and that's when you go away and you come up with little example pieces of code, or hey, let me try this, or let me bring this in, and you as a team or as an individual can decide, yeah, there's kind of a solution here, or you can say no, this is probably not viable, right? So yeah, so Chet, we're not only just improving performance, we're also just trying to get to an actual answer, right? All right, so Yassine says grid search is the process of experimenting with different combinations of hyperparameters used to interpret the impact of each parameter model performance and end goal to find an optimal combination. Yeah, I like that. That's a great answer, Yassine. Thank you for that. Yeah, I think Yassine's answer is pretty reasonable. Manoj says grid search is hyperparameter tuning techniques to optimize model accuracy, operate in necessary parameters, operate necessary parameters open to being wrong. Yeah, I think you're on the right track, Manoj. And by the way, if you guys are shy or don't want to give a full answer, you can just go ahead and say I agree with Manoj or I agree with Yassine. Just to kind of encourage participation there. Over on Instagram, Verka is suggesting what I believe is that grid search is used to decide for coming up with better hyperparameter configurations. Yeah. Yeah, that's a pretty good definition also, Verka. So good. I'm glad that everybody's kind of like on the same page with that, right? So that's great. So let's go on to the next one. Why do we want to document results? What is the necessity behind documenting results? And if you want to talk about it, we can also talk about what we were documenting last week, right? If some of you remember that, feel free to do that. But why are we looking to document them? Like, why is that important? Like, why was that even brought up last week? Let me know. Denelson is saying a grid search is a way for us to automate the execution of several experiments for a model. Yeah, yeah, yeah. And Denelson, I'm glad you included the word experimentation in there, right? Because grid search at the end of the day is the experiments that we as scientists run, right? Because remember, at core, we're scientists, we just happen to be using data. But grid search represents a lot of that approach, right? Of what we mean when we say we experiment, right? So I'm excuse me, I'm glad you included that in there, Denelson. So let's think about the second one. In the chat, go ahead and tell me, why do we want to document results, right? Go ahead and think about that for a second. And I'm going to keep on trying to struggle with this chat thing, trying to get it up and running. But let me know why you would want to keep on documenting your results. All right, so Denelson is saying, what is happening there? What is happening there? Huh. I don't know if you guys heard that, but on my end, for some reason, I'm getting audio back. Why am I getting... All right, guys, sorry about that. I'm going to have to I had to close out my chat tools. For some reason I was getting audio feedback. Yes, Denelson says there's a slight echo. Yeah, sorry about that, guys. Let me know in the chat if the echo is gone. I'm pretty sure I got rid of that. If not, let me know. Okay, but let me kind of, get back on track here. Okay, so Denelson said, we document our results so that we can see how our model performs with certain values. For example, if we are seeing in our documentation that our model is performing well with a lower dropout rate. Yeah. Yeah, so we can see how the model performs at certain values. Yeah, sure. That's a good way of putting it. Why else, Denelson? Why else? I think there's a couple other reasons. You're really close to it. Paul says documenting helps you keep track of what you're doing and supports you in monitoring progress, mistakes. Okay, I like that you mentioned the support it gives you, right? What other kind of support can it also give you? I think there's other versions of that, right? What else is there, Paul? Manoj says it's important to track the baseline model so we document the results. Yep, that's another way of doing it, right? Or another justification for the documentation. I love the fact that you mentioned baseline. Yassine says documenting results helps us interpret the impact of these hyperparameters on the performance. Which ones are neutral, which ones need adjustment in the range, which are the most impactful, etc. Okay. Starry Vibe says it compares models and experiments. Yep. Get rid of that. There we go. Denelson says we will run our next grid search with something closer to 0 or just lower values. Yeah. Paul says also to capture any insights or hunches that you may have and wish to explore later. Okay. Yeah. Yeah, we're getting a little closer there, right? You're getting really close, Paul. I appreciate that answer. Starry Vibe says and communicate findings to others. Yep, that's also important. Also important. Chet says to compare different interactions of your model, you can't tell if a certain experiment is worth continuing without a point of reference. Yep. Also referring back to the baseline. Michael, hey, Michael, good to see you. Hello, Sir Dennis and everyone. I trust we're all doing well. Yeah, Michael, we're all doing really well. Thanks for being here. Delina, thanks for being here. I think it's your first time here, so thank you. Welcome. You might revisit a project months or years later. Good documentation helps you quickly understand your own work. Yeah. So these are all great answers. Okay, I don't see any answers over on Instagram. Manoj says agree with Delina. Yeah. So look, everybody is definitely on the right track. So I think the one item that I would add to all of you guys also is to remember that one of the beauties of data and data science, exploratory data analytics, things along those lines, is that data creates more data, right? That's something that I talk to a lot of my clients about, right? Data leads to more data. Questions lead to more questions. So another big reason why we want to document our results is because it shows the work that we've done and it shows the progress, and then that in itself becomes a data set. Because that in itself, you can start to say, okay, well, look, here's the trend of what our accuracy did during our grid search, right? Or here's the history of everything we've been through. Here's the history of why we think that this model is the best model we can come up with, because we already did 5,000 experiments and here they are, right? This is our proof to show that we did the work. We did the experiments necessary to get to this particular conclusion, this particular model, this particular insight, whatever it ends up being, right? But that in itself becomes a new data set for you to work with and to use as a as a like a statistical defense to say, hey, this is where we're at, and this is why we're at this stage, right? So all of those combined, kind of join into that. But that's really kind of what I want to make sure you guys understand, that it serves as that proof that you put in the work while at the same time being a new piece of data for you and your team to refer to, right? Okay. Saving models. Why do we need save models? And you know what? We're going to go ahead and tie number 3 and number 4 together. Why do we need to save models? Because you really can't answer the save models without understanding the prediction cycles, right? So what do you guys think? So in the chat, let me know. Why do we need to save models as we go along? And if you want, what is a best practice? There's multiple best practices, right? But what is a best practice that you'd probably would want to exercise while you're saving models? What do you guys think? Let me know in the chat there. I think over on Instagram, I had one more question from Verka. Verka says, this is my first time joining the series, so please can I get a bit more context to this? Okay, Verka, yeah, thanks for joining. And I'm going to answer because I have been getting a lot of new followers on Instagram. On Instagram, 2 weeks ago, I had about 21,000 followers, and now I have like 27,000 something. So it has grown quite a bit. So Verka, in addition to all the posting that I do, I also do live streaming. And this is basically known as my Sunday series, where I choose a particular topic and I will do a series of Sunday lessons on that topic. So we did one on the Introduction to Statistical Learning book. We did one on how to run a project. And now we're doing one here on neural networks. So you are joining the tail end of the neural networks series. This is our 8th or 9th, I think it's the 8th time, our 8th time meeting. And, this is kind of towards the end, right? Because the series tend to be a little bit shorter than this. Neural networks has turned into a longer series. But you're catching the tail end. Last week, we worked on going from just experimenting and trying different things to creating code that is much more of a professional grade, more closely resembles what you would do on a day-to-day work as a data scientist, like as a profession, right? And then today we're going to be looking at generative adversarial networks, and that's kind of what you're seeing up on the screen right now. So I hope that gives you some context. If you want to see the other videos in this series, you can go to my YouTube. I have a playlist that has all of the videos in this particular series. So feel free to go there too, okay? But I hope that gives you a little bit more context to go on. Okay, so on the question of number 3 and 4, why do we save models and prediction cycles? Starry Vibe says for predictions on new data, right? Yeah, that's definitely a reason why you want to save models, and to deploy for predictions on new data, right? Yassine says we save models for later use, either for prediction cycles or to save weights that we intend to use later for other training cycles. Best practice, I think, save the one that beats the previous baseline, or save any model that beats a certain specified threshold. Yeah, I think Yassine is giving us a pretty good answer there. So to the best practices, and maybe this isn't the best word for it, but where I was going with that is to keep in mind that you definitely want to save your models, because, as Starry Vibes point out, you will also use them for prediction or new data, but realize that some of these models are going to get very big very quickly on you. So at some point, you're not going to be able to save every model, or disk management will become a concern, right? You're going to have to be careful with how much disk you use, because the models can individually can be very big, and as a group, they can be a lot, right? Um, so, for example, if you were to run a grid search with multiple parameters, multiple values for each parameter, that means you're running thousands of combinations. And if you're saying, well, go ahead and save me any model that has an accuracy of better than 0.95, well, that can be a lot of models, right? Because you're about to run thousands and thousands and thousands of experiments, right? You could be saving easily, multiple hundreds of models, and disk space, disk management kind of becomes an issue at that time, right? So that's really one of the things that perhaps we'll see a little bit more today, because we should be dealing with bigger models today. But that is something you kind of want to keep in mind, and be able to say, well, wait a minute, hold on, that before I run this grid search, I better make sure I have enough space, or I'm managing the models correctly, because otherwise, you can end up stopping your exploration, or your grid search, not because of a bad code, but simply because you ran out of disk space, right? So keep that in mind, because that's just one of those practical things that you kind of only learn once you're out there, right? Nobody teaches you that in school, right? So good. I think we're getting all reasonable answers for those four. Let me take a quick look over on Instagram. I think it's Sarah. It's Sarah says, "Hey, speaking my mind here. Why does no one watch you? It's an open-ended question. Who wants to answer? Can you? Content seems really good to me. Why does no one watch you? Ouch, that hurts, but I think plenty of people watch me. So Itzar, I think it's Itzar. Feel free to join us over on YouTube. You're going to find more viewers there, or feel free to stay on Instagram. On Instagram, viewers come and go. But look, I mean, I'm not tied to who's watching or who's not watching. I'm just trying to put out the best content I can. That's all I can do, right? So glad you're here. I think it's your first time. Thanks for joining us. Lots of new followers over on Instagram. My follower and viewing and liking numbers on Instagram would say that plenty of people watch. Thank you very much. I've had some really good pieces of content go out in the last couple of weeks. But thanks for being here. Desert Apple says, I watch you. Oh, thanks so much. That is very nice and very creepy at the same time. I watch you. And Talib says, yes, you do, sir. Thank you, Talib. I appreciate it. All right. So let's get into some. So now that we're done with the review, let's get down into the new stuff, right? Let's get into talking about generative adversarial networks. And just like we did before, if you guys remember, we talked about how some of these terms in data science can be very intimidating, right? Like, some of this stuff can be kind of intimidating when you first hear about it, or first learning it, right? So I think that generative adversarial networks can be in that same vein, right? So, just as we did before, we're just going to talk. Just talk. What are GANs? What are generative adversarial networks? Go ahead and put it in the chat. What do you think they are? Right? You can choose to give a definition. You can choose to talk about how you build them. You can choose to do whatever you want, right? But let's just talk it out. Let's take some of the mystery out of it, okay? Talib says, we watch your content, sir. Thank you so much, Talib. Yeah, I think that our new friend was a little misguided. I think plenty of people watch, I get all kinds of messages, all kinds of requests. I've managed to build a great collection of clients that I coach on a personal basis. I have a tremendous set of clients that I really love working with. So everything I've done on social media, as far as the content and the viewership, has done nothing but bring great things. So I appreciate that you guys watch. But yeah, thanks so much for that, guys. So the question in the chat for anybody who wants to do is, what are GANs? What are generative adversarial networks? If you're not shy and you want to say, hey, I don't know, feel free to do that too. You don't have to do that, because I know that can be embarrassing. for some people. But let's just talk. What are they? What are generative adversarial networks? Lava T over on YouTube says thank you, Dennis. Welcome, Lava T. I'm pretty sure it's your first time here, so thanks for stopping by. Starry Vibes says is a type of neural network where a generator creates fake data and a discriminator tries to detect if the data is real or fake. Okay. Okay. Anybody else? Any other definitions out there? What is a generative adversarial network? And if you want, you can also just say, hey, I agree with Starry Vibes, or I agree with so and so. I don't know. All of those are reasonable replies. So what do you guys think? What is again? What is a generative adversarial network? Sounds scary, right? Sounds intimidating. Long word. Manoj says it's a type of neural network architecture used in unsupervised learning to generate new synthetic data that looks like real data. Okay. Starry Vibes is adding to their previous answer, saying this helps the generator produce very realistic data like images, audio, etc. Okay. Over on Instagram, Talib says it's a type of machine learning framework. Okay, Talib, tell me more about that. Because there's a lot of machine learning frameworks, right? But tell me a little bit more about that. And also on YouTube, Manoj, tell me more about the unsupervised side. Because you're the only one that mentioned unsupervised. Help me understand that. Okay, Yassine says GANs are a neural network architecture that has two entities, one with the goal to generate the closest content to reality, and the other one with the goal to catch any difference between the generated content and the reality. Okay, okay. Desert Apple over on Instagram says tries to create fake data. Talib is being very honest with us and says, I don't know about it. Talib, appreciate the honesty. It's not always easy to say I don't know, so thank you for that. So Desert Apple and Starry Vibes, I'm going to kind of challenge you a little bit on that because both of you mentioned fake data. Now, it's possible that what you guys actually mean is synthetic data. But help me understand what you mean by fake data. We may just have like a difference in wording here, right? But help me understand what you mean by fake data. Because both of you are the only ones that mention that. So let me know what you guys mean. So far, I'm on board with Yassine's answer, right? So let me read that again. GANs are a neural network architecture that has two entities, one with the goal to generate the closest content to reality, and the other one with the goal to catch any difference between the generated content. And generated content and the reality. Okay. Michael says generative adversarial networks are a type of machine learning framework specifically designed for and used in generative artificial intelligence. Okay. So Michael is hitting on a really important part there. That the reason why we are talking about GANs is because GANs are very, very central to the advances that we've had recently in AI, right? So that's why I kept on saying that it'd be really impossible for me to have a series for you guys on neural networks without mentioning GANs, because GANs are basically at the center of why AI is possible, right? Desert Apple says it starts with random noise and transforms it into something that resembles real world data. Okay. I like that. I like that. I think that does help clarify what you mean by fake data. So speaking of fake data, Starry Vibe says data generated by the generator, synthetic, not from the real data set. Yeah, okay. Thank you for that, Starry Vibes. Manoj says GANs learn to model the data distribution without being given labeled examples. Okay. Okay, Manoj. So I'm gonna challenge you a little bit more. Do we need labeled data at all for GANs? Do GANs require labeled data at any point? So Manoj, you're welcome to answer that, or if somebody else in the chat wants to answer that, let me know. But do we need labeled data for GANs? Is that a necessity? Something to think about, right? Okay, so Manoj answers right away with no. What do you guys think? What do you guys think? So now that Manoj answered, let's open it up to everybody in the chat. Do we need supervised data or labeled data at any point in GANs? What do you guys think? And I appreciate that Manoj has also said open to being wrong, because that's a sign of a good scientific mind, right? We as scientists shouldn't be like not grounded, shouldn't be stubborn in our thoughts, right? So if Manoj is saying, "Hey, look, this is what I think. I'm open to being wrong," that's a very healthy display of being open to the possibilities, right? Because you can be wrong at any time, right? So I appreciate that Manoj is displaying that open mindedness. Um, so again, the question is, do we need supervised data for GANs? And I believe Starry Vibes is answering that question, and Starry Vibes is saying yes. Anybody else? So Manoj is saying no. Starry Vibes is saying yes. What do you guys think? Let me know what you guys think. Yassine says, yes, we need it for the error calculation for the one that checks the difference between the generated and the real content. Okay. So that's 2 votes for yes. And Chet is saying, I don't think so. Okay. So that's, so we're 2 and 2, guys. 2 people are saying yes. 2 people are saying no. Michael is saying, I don't think so, both. I don't think so, both. Let me know what you mean by the both part, Michael. I don't understand the both part. Let me know what you mean by that, please. Starry Vibe says labels used to control the output. Ooh. Labels used to control the output. Maybe. Depends on how you mean that, Starry Vibes. Maybe. Maybe. Talib says, Talib says, for what? So Talib, we're talking about whether anywhere along the architecture for GANs do we need labeled data? That's the question in front of the chat. So what do you think, Talib? Go ahead and put an answer in the chat if you want. So while you guys are thinking about that last one, I want to go to this next chart, or in this next slide. And by the way, guys, I hate the way these slides look. You'll have to forgive me. It's because when I switched my machine, I didn't install the new fonts yet, or the required fonts yet. So the slides look a little funny today. Okay, so all of you were correct that when you mentioned the architecture, because that's what a GAN is. A GAN is not a code. It's not a library. It's architecture of how you use neural networks. Okay, and there's 3 components to it. There's going to be your generator, your discriminator, and your time, because GANs are very intensive in their processing, and we're going to talk about why. Okay, but you basically need, let's talk about these first 2 components. The first part is known as your generator. And that is, you can think about that as the neural network that you want to teach. That's the part that you want to learn in this entire process. The discriminator is what is the existing neural network that knows what to teach. So you have your discriminator that knows what you want to teach, and you have your generator that's trying to learn from your discriminator. So if we're talking about a GAN for images, we would be talking about, and let's say they're images, and let's say you wanted to be able to generate art pieces that look like Van Gogh paintings, right? Which is something that already exists, right? So you use your discriminator, you take your discriminator, and you have it learn Van Gogh paintings or paintings from a particular era or something like that. And then you have your generator that's going to try to recreate or learn what the discriminator already knows. And that's your basic architecture. And how long that process takes is a function of time and the processing power that you have available, essentially. Okay? So I came up with my own little graph over here, or chart. So we're going to kind of break this down. The first part is networks. We're going to break down the name, right? And the first part we're going to break down is the network side. Because each one of these boxes, the generator and the discriminator, is a neural network. So that's where the networks part of it comes from. The adversarial part of it comes because the two neural networks are going to sit there and talk back and forth to one another. And they're essentially going to argue. They're going to have this like adversarial conversation. So here's what's happening. The discriminator knows what the paintings look like. The generator does not. So the generator only has the option of starting randomly, right? So the generator produces something and says, hey, does this look like a painting we're interested in? And the discriminator essentially says yes or no. Okay, what about this one? No. What about this one? No. What about this one? Ah, that's a little closer. Okay. And now this network goes and learns from that feedback and says, oh, I was way off over here, but I was a little closer when I did this and this. And then it just keeps on going. How about now? Is this a painting we're interested in? No. Is this what we're interested in? No. What about this one? Yes, that's even more closer than you were before. Okay. And they're sitting there having that conversation back and forth. That's the adversarial side, right? That discussion. You're closer now, you're closer now. Nope, that looks nothing. Yep, you're closer, you're closer. Nope, that's wrong. That conversation back and forth. That's the adversarial side of it. And then the generative side comes when the generator basically becomes perfect, right? Because eventually, if you sit there and let the networks go and argue enough, have that adversarial conversation, eventually the generator can say, does this look like a painting? Yes, it does. What about this one? Yes, it does. What about this one? Yes, it does. How about now? Yes, it does. And now you have a fully trained generator. And that basically becomes what you want to publish. Because now your stakeholder, your project, your app, whatever, now has a reliable neural network, this reliable generator, where you can say, show me an image, show me an image, show me an image. And it will always consistently show you an image that your discriminator knew all along, that your discriminator was trained on. Excuse me, right? Okay, I covered a lot of ground there. Let me know if you're lost in anything. But this chart up here is very similar to what I've used with my stakeholders. I've given you an explanation that's similar to what I've used in the past. But that basically helps you break down the three components of a generative adversarial network. And by the way, I forgot to mention that you know how you hear about generative AI? This is that same generative word because that's really what the AI is, right? The AI is this final trained generator network that can produce things on command, right? Because that's really what you're trying to get to with GANs. That's the generative side that it can come up with things, right? Is it going to be perfect when it comes up with things? No. And I think we're going to see some of that today. But what is that? That's a hallucination, right? We're still seeing that now in generative AI and LLMs and all that, right? But that's essentially what a GAN is. It's the two networks going back and forth, having that conversation, and eventually you end up with a trained generator that you can now use on command to give you the things that you want. So, coming back to our previous question, do you need labeled data at some point in the GAN process? What do you guys think now? Does anybody want to change their view? Because we kind of we were basically tied, right? Does anybody want to change their view? Let me know. Fabrizio says, hi, Dennis. I know that one. They fight each other. You want the generator to reduce the loss function and discriminator to increase their loss function. So they produce an image. I want to see the epochs, how the generator learns, and then the output. You can give an image of a number distorted, and a generator create the number through minimization of a loss function. Yeah, sure. That's a pretty reasonable way to explain it. The loss function is what we'll monitor to figure out if the generator is actually learning, right? Because ultimately you want the lowest loss function possible, and that's how you know that you've reached a state where the generator, is doing what you want it to do, right? All right, so thinking about this chart, thinking about the explanation, the question in front of the chat is, do you need labeled data at some point? We were basically tied, right? We didn't really come to a conclusion on that. But now that we've gone through this explanation, what do you guys think? Let me know in the chat. I'll give you guys a minute to think about that. Michael says, yes, we do. Okay. Michael, I can't remember if you voted before. I don't think you did. So you're one of the new votes for the yes side. But we're still essentially tied, right? There's a few people that said no. What do you guys think? After seeing the chart, understanding the explanation, what do you think? Give you guys another couple seconds here to think about it. So Yassine is saying I'm still standing by my yes. Okay. All right. Last call for answers, guys. Anybody else want to answer? Um, Fabrizio says this is generative AI, no supervised learning. You are not classifying but generating an output which follows a random process similar to transformer architecture for word prediction. Okay, so Fabrizio is on the no vote. So, so Michael voted yes. Fabrizio voted no. That means we're back to being tied, guys. All right. So obviously we're kind of split on this. So I'm going to propose to all of you that the answer is yes. You do need label data at some point in GANs. Okay, Chet says, I switch. We need a target. Okay, Chet, you're on the right track. And thank you for being willing to be open to new information. And you're right, Chet. You do need a target. Because, guys, the discriminator. Tell me about the discriminator. We just learned that a discriminator knows what to teach. It knows what you're trying to generate. Right? How can you I also told you that's its own neural network, right? How can you properly train a neural network without having labeled data? Right? You have to have some labels for your discriminator. If you don't have your discriminator understanding the documents, the images, the sounds, whatever, it's going to be really hard to say that your discriminator is accurate. And remember, you're using that discriminator to kind of like almost like bootstrap you into the generator. So if you don't have a strong discriminator, you can't expect to have a strong generator, right? Like that's completely unreasonable. So yeah, you do need labels in your discriminator. Your discriminator is usually, there are going to be some exceptions, but usually you do want to have a supervised approach so that you have the strongest discriminator possible. If you don't have that to begin with, then everything down the road, including the generator, is going to be bad, right? Okay, it looks like Manoj has seen the light, and Manoj says, I switched to yes. Okay, thank you, Manoj. But yeah, guys, there is a supervised or a labeled approach to it because you want the strongest discriminator possible. If you don't have a strong discriminator, your probability of success drops drastically. Right? Because think about this, right? When you hear about OpenAI and the training they're doing, the crawling that they do of the documents, the data acquisition, wink wink, the data acquisition that OpenAI does, that's not going to the generator, that's going to the discriminator. Right? That's all they're doing. They're building up that discriminator. I mean, I know it gets more complex than that, right? But the point is that that's the side that they're building up, right? They're building up the side that helps create a better generative algorithm. So you can't do that unless you have many, many elements of supervised learning along the way, right? Would be very, very difficult to do to have a successful generator if your discriminator isn't very good to begin with. Chet says, at first I thought it was like k-mean clustering and then just adding random points with each cluster. I've never heard of GANs before last week. Okay. Well, Chet, I appreciate the honesty. Yeah, I could see why people would have that connection to k-means clustering. But the funny thing about k-means clustering is that you can also use that to create labeled sets, right? We talked about this. I think I did a live stream on Instagram on Monday, and we talked about this. That you can use, um, you can go from unsupervised data to supervised data, right? That's one of those little like advanced techniques that some data scientists use. And clustering is one of those ways to do it, right? Because once you've labeled your clusters, guess what? You have cluster data, right? So I could see why you would have that type of conclusion there. Fabrizio says, I agree, good point, Dennis, but what happens if the discriminator is synthetic data? Will the generator still do good results? It'll still give results, but the probability of them being good results has dropped, right, Fabrizio? And I had this discussion yesterday. I was a guest on a podcast yesterday. You can use synthetic data. There might be ethical questions around it, maybe legal questions in some cases, but the real concern is the quality, the effect it has on quality, right? And also keep in mind that not all synthetic data is the same. Synthetic data for images is different than synthetic data for text, which is different than synthetic data for like financial spreadsheets, right? So, can you use synthetic data? Sure, but you got to tell me more. Like, what is the use case? How much of the synthetic data? Why do you need the synthetic data? Can you justify the use of synthetic data? Not everything needs synthetic data, right? But yeah, I think it definitely lowers your probability of success, Fabrizio, right? Because this is also where you guys should be understanding the limitations of generative AI. Because guess what? If it's not in your discriminator, your generator, it doesn't exist to your generator, right? Your generator is only going to be able to kind of like mimic what is in your discriminator, right? So the size of your discriminator, the width and depth of your discriminator is also pretty important, right? So keep that in mind that they are correlated in their success to each other. If you have a weak discriminator, you're going to have a weak generative result, right? Fabrizio says there are cases where it's almost impossible to get data. For example, for fraud detection, I heard that people use synthetic data to create fraud cases to improve their algorithm, but not sure. And that is not GAN; it's just a normal XGBoost. It's off topic. So yeah. So Fabrizio, what you're hitting upon is what I mentioned about it depends on what kind of data you're talking about, right? So you're describing a scenario there where it's financial data, right? And I understand why they would do that in that case because fraud data tends to be something where you're going to have a lot of false positives if you're not careful, right? But here's the thing though, right? If you gave me transaction data like that, right? Like credit card transaction data, you're trying to find the fraud in it. There are techniques you can use to justify and say, well, look, I'm going to use synthetic data, but I'm using it within the same range, the same distribution, the same standard deviations as the original data set. I'm just amplifying it by creating more of it, but the data set fits the statistical parameters of the original data set. If you do that, that's probably the least harmful way that you can do to utilize synthetic data, right? Because you can make the argument of yes, the numbers are made up, but statistically they are still the same. I'm not introducing outliers. I'm not introducing a funny distribution. It's the same numbers from a statistical perspective, right? I would sign off on that. I'm okay with that, right? But you can't do that for every topic. How are you going to do that for text? How are you going to do that for images? How are you going to do that for like image recognition algorithms, right? Where things need to be fairly accurate, right? So synthetic data is like a whole other topic, and I'll probably stop here because I don't want to get too far into that. But it's very, very use case dependent. Very dependent on that. Okay, so we know we want a strong discriminator. We know that our generator is going to sit there and talk back and forth to the discriminator. And eventually, you come up with a generator. And the generator can now, on command, give you the stuff we need. So let's get into the coding of it. I want to get into the coding of it because I think this is where it gets really interesting, right? So what I want to do is I want to start with a brand new prompt. I was tempted to use the prompts from last week, but I think we should just use a brand new prompt because I also want to make sure that we're using the latest versions of Keras that will let us leverage the GPU usage from my new machine. But I think it's also healthy for us to kind of start all over and start with a brand new prompt. We're still going to use the Mints data set, which, if you guys remember, is the handwritten numbers that we were using last week. I think it'll still be good for us. And we're going to basically create a GAN to generate handwritten numbers, right? We're going to ask ChatGPT to show us the code for a GAN that can, on command, generate handwritten numbers. I think that'd be fun, right? I think it'll be fun to do that. So we're going to use ChatGPT, right? We don't write code on our own, right? But we can still make inferences and we can still make like assumptions of where ChatGPT is going to go with this, right? So knowing what we know, everything we just covered, do you think ChatGPT is going to start with the discriminator or start with the generator? Like what would it make sense for it to do? What do you guys think? Where would like a brand new GAN project start? I mean, obviously we're going to use the Mints data set. It'll load it in and all that stuff, right? But where are we going to start? Osama, we're back to being tied, guys. Osama says the generator. Fabrizio says the discriminator. Anybody else? Go ahead and vote. We are currently tied. Are we starting with the generator or the discriminator? Yassine says discriminator. But Osama says generator, right? So what do you guys think? Go ahead and vote. Go ahead and vote. What do you guys think? Where are we starting? Are we going to start it with the generator side or the discriminator side? You can also just, say you agree with somebody or you don't know. Either one is okay. But where are we starting? Over on Instagram, Postgrad Math. Hello, welcome. Thanks for being here. Feel free to stay on Instagram or you can join us over on YouTube. Any more votes? Okay, Deepak over on Instagram is voting generator. Deepak, thanks for being here. I think it's your first time. So thanks for being here. But Deepak is voting generator. Yes, Delina is also voting generator. Okay, so that means generator is... I think we're tied again. We're either tied or generator is slightly ahead. All right, last call for votes. Are we starting with the generator or the discriminator? Manoj says generator. Last call for votes. Last call for votes. Generator is definitely leading right now. I think it's like 4-3 or 5-3. Desert Apple says generator. Okay, so that's like 6-3. All right, last call, last chance for votes. Are we starting with the generator or discriminator? Starry Vibes is with the last vote is coming in with discriminator. Okay, so that means it's like 6-4. So generator 1. All right, if you said that we are going to start with the generator, wrong. So congratulations to everybody who voted discriminator. Even though you guys were in the minority, you stuck with it. But yeah, guys, the correct answer is discriminator. We don't have anything until we have a discriminator, guys. Right? We just said that the generator starts with no knowledge. The generator is going to start with random guesses. And the discriminator says, no, that's not correct. No, that's not correct. Oh, you're a little closer now. Oh, that's even more closer. No, that's not correct. So you don't have anything until you have a trained discriminator to say, yep, that's good. Yep, that's good. No, that's terrible, right? So we are going to absolutely start with the discriminator. So congratulations if you were willing to vote discriminator, because that was the minority vote. But if you voted discriminator, you are correct. This whole process, right, can't start until you have a discriminator. This conversation, this adversarial approach can't start until the discriminator is knowledgeable, right? You can't kick off that process of teaching the generator until you have a strong discriminator. So for those of you that voted discriminator, I want you to think about that. Excuse me, for those of you that voted generator first, I want you to think about that. Because if you don't have something to teach the generator, how can you start there? Right? So keep that in mind, guys. You have nothing until you have a pretty good discriminator. Okay? So I haven't verified that, but I know that I've written these in the past, like on my own, like before ChatGPT, and that's where we would start. So I'm kind of guessing that's where ChatGPT is going to take us, but we'll find out, right? We'll find out what code architecture ChatGPT is proposing for us. But just by looking at the architecture and kind of understanding GANs, it should be clear to you that you have nothing until you have a good discriminator. If that wasn't, and you did vote generator, I'm not picking on you because anybody can be wrong on any day. But if you voted generator, then I would revisit your understanding of the GAN architecture. Because it's literally impossible to start on the generator side. Okay? Fabrizio says, build a strong discriminator. The discriminator is strong at the beginning, but then the generator fights back and beats them. They are fighting. Yeah, that's the adversarial part of it, right? And the generator is not necessarily fighting it. It's just saying, what do you think about this? What do you think about this? What do you think about this? What do you think? And it's just doing that over and over and over again. And there's a discriminator just answering yes, 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 no, no, yes, and so on, right? But again, without that discriminator, you got nothing. So if you answer generator, might be a good time to revisit that. All right, so let's get started. Maybe a little bit of a longer prompt. So I guess I have to minimize. Where's my? Oh, what happened to my? Okay, there's my web window. Okay. All right. So we're going to use O4 Mini High. We've been using that successfully. And going to make this a little bigger for you guys. Let me know if you need me to adjust any sizing, because remember, I'm still working on a new machine here. But let's get started. So Okay, so I want to continue my work in understanding neural networks. I want to work on a GAN. I want you to show me Python code, use the MINCE dataset, and train a GAN to auto-generate handwritten numbers. I want to use the Keras framework, and I will be running this on an Apple M4 Max. So please make sure the code uses the best use of the GPU power is available. And I want to say make sure the Keras code, because Keras, I believe, has special instantiation for to make Keras use the GPU side, not the CPU side. Yeah, I think this prompt will work initially. I do want it to. We are going to make some modifications later, because where it gets really fun is where you can kind of stop where the generator is at, and you can basically like see the progress of how it's learning. Like you can see how early on the generator will make terrible mistakes, but as it gets smarter, you can kind of see the numbers forming or the image forming or whatever the case may be. So I think we're going to introduce some pauses in between so that we can kind of see the progression. And it's kind of interesting to see, oh, this is what it does after you do 100 epochs. This is what it does after 1,000 epochs. This is after 2,000 epochs, so on and so forth. It's kind of interesting to see that, at least I think so. So yeah, so let's see what ChatGPT gives us here. All right, so it's going to give us a self-contained Keras script, simple GAN on Mince, GPU settings optimized for Apple series using TensorFlow Metal, and it's going to save it as this. It's actually giving us a name to save it as. It's giving us our pip installs, which makes sense, and then that's our code. So let me copy the code and bring it in. Let me bring it into our Visual Studio. If you need this bigger, let me know. And we are going to call this scan.py, I think is what it requested. Okay, so let's take a look at this real quick. All right, it's bringing in TensorFlow, which makes sense. Make TensorFlow quieter for the logging. Okay, that's interesting. It's going to go ahead and check and enable my GPU, which is good. So we can see that it's going to be running 50 epochs, 256 batch size, which is a reflection of how big the images are in the MINCE dataset. It's going to go ahead and load in the MINCE dataset. It's going to go ahead and do a training of, well, I guess this is just a training data set, right? This is the function to make the generator. This is the function to make a discriminator. Now remember, just because it wrote it that way doesn't mean that's how it's calling it, right? These are just the function creation calls, right? We're establishing our losses and our optimizers for our output layers. And then these are our training steps, it looks like. So we can see here that we are calling our discriminator first, which makes sense. And then we're calling our generator after that. And then here is our actual training loop, or at least the definition for the training loop. And it's going to produce a sample image every 5 epochs. And it's going to generate and save images. That's great. That's exactly what I was hoping for, right? That it'll give us the images as it goes along. And we'll see that the first initial images are going to be complete nonsense, but they get smarter, right? So here's our generate and save images call. And then down here is our training. Okay. So everything seems fairly normal. I'm pleased that it's really such a small number of lines, right? It's it's 155 lines. That's not bad. That's not bad, right? Okay. So one of the things I want to do is I want to run the pip install. Make sure that goes okay. So we're going to use the same terminal and the same environment that we were using before. So I want to do conda activate nn2. And then here's our pip install. So that's going to go ahead and install the Mac specific TensorFlow that we're going to need. We're going to try to make the best use we can out of the GPU. Okay, so that looks like it went okay. I think that we are ready to run this. So actually, where is it going to be saving the images? Let me look at that real quick just to make sure we know where to look. Okay, it's going to be saving the models, which is great. You know what, guys? I think we're going to... I'm tempted to move this to its own directory so that we can kind of isolate everything that we've done. But you know what? There's a better way to do that. Let me create an archive folder here. Give me just a second, because that way we know that everything that's going to be added is going to be just for our GAN. So I'm going to move everything to the archive. And then that way we have isolated our GAN work. So everything, okay, so now everything in this folder is going to be just our GAN work. So let's kick this off. So that's going to sit there for a while. And you know what? Perhaps actually one of the things we're going to do is we're going to remove that call to TensorFlow to be quiet. We want it to be more verbose. I think a 0 will do here. I might be wrong on that. Let's let that sit and see where we end up. I want it to be a little bit more verbose than maybe ChatGPT told us it would be. Okay, there it goes. Okay, good. Optimizer for type GPU is enabled. Good. So that means that it should be using... Is there anything else in there about the GPU? Okay. So good. We're already seeing some epochs kick off there, guys. So you can see that we already have a generator loss and a discriminator loss published. And it looks like it's going to give us some of those updates. And I think it will also give us yeah, there's another one. What do you guys think of these losses so far? Tell me in the chat. All of you should be familiar with loss by now. What do you guys think of these losses? So the generator loss is showing as 1.0462. Discriminator loss is being shown as 0.9781. What do you guys think? And let me also look at the chat here. Fabrizio says, can we use PyTorch? Somebody help out Fabrizio. Somebody in the chat help out Fabrizio, please. Somebody give Fabrizio an answer, please. Yassine says, big loss. Yeah, these losses are big, right? And are big numbers good for loss or bad for loss? What do you guys think? And also, while that's running, if we go to VS Code, we have these, guys. So every 5 epochs, it's saving a generated image, right? So this first image, do you guys see numbers there? What do you think? What about this one? What about this one? What about this one? Don't you love seeing that progress? I'm sorry, but every time I see these things, I get super excited. Osama says higher loss is bad. Yeah, that's exactly right. That's exactly right, Osama. We want, remember guys, if you're new or you don't remember, we want the loss as low as possible. Low, 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 low. Fabrizio says it's improving. Yeah, and I love that, right? I love seeing these charts, right? Look at the first one. This is only after 5 epochs, right? This looks terrible. This could be anything, right? That's not much better. On this one, my eye is over here. You can kind of sort of make out a 6, right? Or this one here, this is kind of an 8 up here, right? And then after 20, oh look, that looks like a 1. That looks like, these look like 7s. And now here, right? So we're getting closer, right? It's learning. It's learning, right? Yassine says, Fabrizio, yes, we can if this was International Abducted Children's Day. Nice, I love it. CJ says psychiatry with Dennis. Yeah, I suppose it does look like those Rorschach check tests, right? However you pronounce that. Looks like an echography. Yeah, yeah, right. I mean, but we're seeing the progress is the beauty of it, right? I mean, look, this is our latest one. This is 30 epochs. But you can see here, there's really nothing that's visible, right? So you can see how the algorithm is kind of going through its ups and downs of trying to find that minima, right? Where it was closer, no, now you're too far. But meantime, the discriminator is telling it, right? The discriminator is telling it back and forth. No, 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 you were closer before, or that's better, no, that's terrible. We're seeing that in this. Let's look at 35. Okay, look, we got a 0, a 1, a 9. Arguably, that's a 4, a 3, a 5. Like, we're getting closer, right? Like, we're approximating an answer, right? So 40 is not great, right? I mean, this is kind of a 7, kind of a 3 down here. But it's nice to see that, right? It's nice to see that there's progress being made, and this is all from the generator. This is all from the generator saying, "Hey, let me produce something randomly, and then let me learn from what the discriminator tells me." Okay, here's 45. 45. There's a 3. There's kinda sorta a 0, kinda sorta a 7, kinda sorta a 9, right? Anybody else wants, if you see any other observations, let me know. But, this is kind of how it works. Now, we only asked for 50 epochs, so I think we're reaching the end here. Let me go back to the terminal. Yeah, we're kind of nearing the end here. So here's the loss. Okay, there we go. So now it's done. So here's the last loss. The generator was at 1.07 and the discriminator was at 1.188. What do you guys think? Because remember, we specified 50 epochs. And then let's go and look what that 50th result was. So this is the 50th result here. And then we saved both of our models. We have our discriminator and we have our generator, right? So what do you guys think? I mean, 50 is interesting, but I think we got some better results early on, right? Or earlier on in the epochs, I should say. Um, okay, I think number 40 is our best result. No, 45, right? That's a 0, a 1, a 9, kind of a 4, a 3, kind of a 5, right? I think 35 is more encouraging than 50, but that's part of it, right? Learning is not a straight line for these. It's going to be ups and downs. So this might be a scenario where we want to do what? We want to do more epochs, right? Because it feels like we were headed in a pretty good direction, right? So let me close these out. We have a saved model, but there's probably other things we could look in here, right? We could mess with the epochs for sure, right? We can mess with the layers, right? We've done that, right? We can mess with the number of layers, the number of nodes in the layers, right? For 50 epochs, that ran pretty quickly. So that means that we might be able to expand out the layers or the processing of the architecture of the networks is what I meant to say, right? So maybe we can mess with that, right? That's our generator architecture. What about our discriminator? Remember what we said about having a weak discriminator? So maybe we can kind of strengthen our discriminator a little bit more, right? Maybe we can mess with the dropout rates, right? There's a dropout rate that's being applied there. Excuse me, sorry. So let's think about this, right? Because remember, we have to kind of expand our thinking on what we're doing because we have this architecture in mind, right? So if we have an architecture where we want the discriminator to really know its stuff, and we know that it's going to be a labeled data set. We know this because there's only so many handwritten numbers. There's only so many values in the MINS data set, right? And we know that a dropout layer prevents what? It prevents overfitting, right? Or it helps you prevent overfitting. Right? Is there a danger in having an overfit discriminator? Given everything I just told you, do you want to increase or decrease this dropout layer or dropout value? What do you guys think? Is there a danger in having an overfit discriminator? Are we deploying the discriminator or are we deploying the generator? Think about that, right? So Yassine is voting for a decrease, and Yassine is saying no danger. Yeah, I'm tending to agree with Yassine. You want the strongest discriminator, right? You're not going to be deploying the discriminator. You're deploying the generator, and you know that the discriminator has a finite set of values you're trying to teach it, right? Just like before when we said the Van Gogh paintings, you want to have a network that does Van Gogh paintings. There's only so many Van Gogh paintings, right? Fabrizio is saying if the discriminator is too strong, the generator will not be able to fool the discriminator and will not improve. Okay, I can appreciate that perspective. Now, it's not that it won't improve, though. It's that maybe it won't reach perfection. It'll be harder to reach that perfection, right? And it might take longer, too. I'll definitely concede all of those things. But is it bad if the discriminator challenges your generator a little bit more? Because the flip side to what Fabrizio here is saying is that you'll also have a stronger generator when you do achieve more epochs, a lower loss, more time, more resources into it, right? So I think that there's an upside to it too, right? Fabrizio says it's good, but not too much. Well, why do you say that, Fabrizio? Because yes, it'll be harder for your generator to reach a lower loss, but when it does do that, it'll be a better generator for it. No. CJ says maybe it will be too strict on the generator if an overfit discriminator is okay. Does that mean that it's okay to accept more loss from the generator? Maybe. Because you have to remember, guys, that the loss is a really good quantitative way to look at it. But at the end of the day, it's still a generator. We're still generating images. They either look like numbers or they don't, right? I mean, look at these. Like, do you care what the loss is here? They either look like numbers or they don't. It either reads like text or it doesn't, right? That's kind of the trick to generative AI, right? Where even if you don't achieve a 0.00 something loss, does it look like what it's supposed to look, right? There's kind of like that qualitative element to it also. Do you care what I tell you what the loss is here? No, because these don't look like numbers, right? And the same thing can be said the other way, right? What if I were to show you, 16 perfect numbers here? Would you care what the loss is then? No, because that's the result I wanted. It generated the numbers I wanted, right? So it's a little bit of art, a little bit of science in this, right? But the point is that we should be applying everything we've learned to be able to say, okay, this is where we start experimenting. This is where we start making our own changes. And I'm proposing the dropout rate because it happened to catch my eye. But these are the conversations that we can have and say, well, what's the net effect of that? Is that bad? I don't think I'm hating that result. Let me try that. Right? We know that more epochs will also help. It's going to take longer, but we have a data point. We just sat here and it went through 50 epochs pretty quickly. So Epochs are usually concerned about the time investment, but I'm not concerned if we sit here and invest 200 epochs, right? 200 epochs would probably only take what, less than 20 minutes probably. So let's make a couple of changes and then let's get started, right? Because I do want to run more epochs. So let me change the dropout there. We have 64 and 128. That feels a little small, but let's go ahead. But to address the concerns that are we adjusted the discriminator. So a way we can do this is we can make the generator stronger, right? To address Fabrizio's concern, we can just make the generator stronger, right? So we can do that by changing the network size, right? We're going from 256 to 128 to 64. So why don't we just keep that all at 256? We've greatly expanded the network, right? So even though we've made our discriminator a little bit stronger, we can also make the generator a little bit stronger. And we can try 200 epochs. And we're still going to generate every 5 epochs, which means I want to delete these. Oops. Yeah, let's delete those. Okay, so let's kick this off, and we can still talk while it's training. Let's make sure we get through a training cycle. That's good. It's going to use the GPU, which is good. So yeah, the epochs are going to take a little bit longer to run, and we're going to run more of them. But there it is. Okay, look at that initial loss, 0.9878. That's already better than the previous baseline we had, right? At least for the generator, right? Which makes sense because we did strengthen the generator. Fabrizio says the generator is stronger. Yeah, we've improved it, right? So we should be uh, uh, expecting improvement there, right? So we'll wait till we get to 5 epochs to get that initial result. Now, if you remember, previously our initial result was basically a bunch of black boxes, right? And it looks like we got the same type of black boxes there. Okay, there's our second one already. A little bit more, right? A little bit more to look at. Maybe not a lot. Fabrizio says, let's see after it starts moving. Yeah, right? Maybe we'll see faster progress than we did before, right? Because before, there wasn't a lot of movement between Epoch 1 and like Epoch 30, right? But this is part of us running experiments and waiting for the results, right? Totally standard stuff for day-to-day data science. So while we're waiting, this is a good time for anybody to ask questions. If you're lost, if you're confused, or you just want to have some other commentary, let me know. But I'm pretty... Well, first, I want to recognize that ChatGPT gave us some pretty good code, right? Because, by the way, this is the fastest I've ever been able to train again. Part of that is my machine, but the second part is also the simplicity of the code, right? ChatGPT gave us some pretty simple code. I mean, think about that. We're generating numbers in only like 160 lines of code. That's crazy, right? It's pretty crazy. Okay, here's the next result. Here's 10. Anybody seeing numbers yet? Anybody seeing numbers yet? That's kind of a 4, right? Maybe there's like a 6 forming down here. Fabrizio says it's art. You know what's funny is one of the first GANs I ran was image generation for people, for faces, and some of the faces you get along the way are definitely like abstract art. Like you get some of these results and you're like, whoa, that's a crazy result. But it's clear, but you know, it still has elements of a face and all that, right? So yeah, Fabrizio, there's definitely a little bit of a appreciation that we can have for the art that's kind of forming it, right? And then it's crazy when you think about it that it's a math formula that's forming it, right? I mean, to me, that's also kind of crazy. But what do you guys think? This is a good time for us to have a little checkpoint. Are you guys with me? Are you lost? Are you amazed? What's going on here? Okay, 15 is available. Let's see. Okay, okay. A little bit more formation. You know, we might have a 6 or an 8 or something forming down here, right? So we're moving, guys. If you're over on Instagram, welcome. You're welcome to stay on Instagram, or you can join us over on YouTube where it's a wide screen and maybe a little bit easier to see. But thanks for being here. So it's going to take a while to run through these epochs, but it's definitely interesting. Fabrizio says, I am not sure, but I think the generator becomes stronger, but it's against a weaker discriminator, not sure. I think the discriminators it was also strengthened, right, Fabrizio? Because we lowered the dropout rate. And a lower dropout rate should lead to higher accuracy and lower loss in the discriminator. And also, you can see where this is also the element of time, right? GANs take time to train. Remember, we're only running 5 epochs in between each one of these images. Before, we've run 5 epochs in seconds. But there's a lot happening here under the hood, and I'm glad I have the bigger machine for it. All right, so this is after 20 epochs. First of all, I will say that I'm seeing better improvement after 20 epochs on this run than we did on the previous run. Maybe we're not seeing entire numbers yet. You know, that's going to be a 1, looks like. Maybe you got a 7 down here. But you can see the progression, right? Anybody else want to kind of give their opinions or give their view while we're waiting? I think this is pretty exciting, guys. I'm pretty excited by this. What do you guys think? I mean, we're doing this in 155 lines of code. That's pretty cool, guys. That is pretty cool. Okay, there's 25. 25 is also showing improvement, right? We've got a 4, a 9, a 9 over here. Fabrizio says, I see the LML in the first row, 4th column. Oh. Oh, okay. Okay. Thank you for that observation. um, yeah, I mean, it's all the algorithm learning, right? The algorithm is non-sentient, right? It's just a math formula trying to put in the right pixels in the right area, but it's getting there. It's getting there. All right, there's 30. Oh, look, we have a 5. That's the first time we've seen a 5, and arguably we have a 1 here. That could be a 4. That could be a 7, right? You guys with me on this? I mean, this is amazing. So we're basically just going to sit here. You know, you hear about OpenAI and maybe some of the Google groups also talking about how they are greatly constrained just by time, right? By time and GPU availability. And you can kind of start to get a sense for that here, even in our small scale experiment where we're using a fairly modest data set. But it does take a lot of time to process this because there's a lot happening, right? There's a lot of this conversation happening back and forth between the neural networks that get you to these results. And you have to sit here and you have to monitor it. You have to, you know, before we were worried about one network architecture, now there's 2 network architectures to worry about. So, you know, we're progressing, but it's definitely work to be able to do this, right? Okay, there's 35. 35 is now available. We have an 8. That's the first time we've seen an 8. There's a 9 down here. Yassine says, out of subjects, will the daily streams be back? You know, Yassine, that's a great question. Maybe, maybe. You know, I do enjoy the daily streams, but they do take a lot of energy out of me, right? So maybe I'll think about it. Thanks for the suggestion. Yeah, if you guys have been following me for less than a year, I did used to do live streaming on a daily basis. I might still get back to that. Let me know if there's an interest in that. You know, send me a note or whatever. But I might get back to that. You know, there's other things I want to explore. I'm also trying to dedicate as much time as I can to my coaching clients because that does require time on my part, and I have really great clients right now. So maybe we'll see. We'll see. Osama says at least 30 minutes per day. Oh my God, seriously? How about 10 minutes? 10 minutes. Okay, here's number 40. Okay. 40 is not as encouraging, right? I mean, you see some 9s, right? There's a 9. But yeah. Any other observations here, guys? I mean, I think this is just fantastic for the progress that we're making in such a short amount of time. So while we're waiting, there is another task we can work on. So remember that we have our discriminator and our generator, and it's a saved file, right? And as we spoke last time, what we're working on today, this code here, this is not our deliverable. This is not what you hand over to the to your stakeholders. What you hand over is the generator, is the code that will run the generator itself, right? Or run the prediction cycles like we did last time. Last time we were doing prediction cycles. Today it's basically generative, right? So we need that code. We don't have that. But we can go back to ChatGPT and we can say, hey, we know that you saved this generator file, right? Because this is basically our weights file, right? Now show us the code to use that and generate on command, right? So let's go ahead and do that. So are we expecting this code to be very long or very brief? What do you guys think? Are we expecting a lot of code or a little code? Let me know what you think. Yassine says brief. Anybody else? Are you expecting a big code file or a small code file? Remember, this approximates more of what we can hand over to like a business team or something that's ready for deployment, right? What do you guys think? Is that a small file or a big file? Yassine is proposing that it's a brief file. What do you guys think? Nobody else wants to give an answer? All right, so the answer is that it's going to be a brief file, right? Because all we need to do is we need to load in the file and use it. So this should be a fairly small file. All right, so this is saying it's going to be generate GAN image, loads the generator, and produces a new digit, and it saves it to a generated folder with a timestamp file name, so each one is unique. Okay. So we are going to bring that over to our Visual Studio Code. We are going to create a new. We're going to call that. Oh, come on. .py. We're going to put it in here, and it's only 48 lines. Makes sense. If anything, that's a little bit long because we did ask it to also display it to us, right? But yeah, 48 lines, it's all it's going to take. And this is what you're actually going to deploy, right? This is what you actually send out to your client. So before we run this, let's check on our latest run. So where were we? I think we were on 40? Yeah. So that's 40. That's 45. That's 50. That's 55. And then that's 60. 55 is interesting. There's a 1, a 4, a 0, a 3. Look at that. That 6 might be the clearest 6 we've ever had. I mean, doesn't that look like it was pulled from the Min's data set? I mean, that's pretty good. That's a pretty good 6, guys, right? That's not a bad 7, too. Like, this is pretty cool, like, where we're headed with this, right? But that's a pretty clear 6. Like, it's hard to mistake that for anything else other than a 6. Okay, there's 60. So 60, maybe this 6 isn't so great, right? Okay, so let's go ahead and run our generate image. I'm going to need a second terminal window, so give me just a second here, guys. Okay. So we're going to need this to be called generate image.py. So Python. Oh, Okay. There it is. Okay, so here's our generated number. Now keep in mind, this is from our previous run of the model, right? Because our current run hasn't finished yet, right? Is this a good generated number or not? What do you guys think? Anybody happy with this number? Fabrizio says that will generate the image with the weights capture from the GANs. Yes, Fabrizio, that's right. Because we're basically using the weights of that, the weights of the final generator, loading it in, and saying, okay, go ahead and run, and then this is an output, right? So what do you guys think? Anybody happy with this? Yassine says no. Fabrizio says, I'm not happy. Fabrizio says, can you show where the weights are storing? Yeah, we can do that. Denelson said, no, it looks like it could be a 5 or a 3. Yep. CJ, no. Yeah. Yeah, so this is not great, right? We're not ready to sell this as an app and make $1 million with it, right? But remember, this is from the previous run. So the code is still valid, right? ChatGPT gave us great code to just load in, that's all we're doing here, right? We're loading in the weights. We're saying, okay, generate a number, and that's the result. Now, just as before, I'm going to run this again to show you guys. Just as before, there's going to be an element of randomness, right? Because I'm rerunning the same code, and this is what it gave us. Now, what do you think? What do you think? Anybody happy with that? What do you guys think? Yassine says it's a decent one. Yeah, it's not a terrible one, right? Happy. Denelson is happier with this result. Yeah, but remember, same model though, right? Same model, but there's still that element of randomness, right? But it's the same model. I'm really curious to know what this will be like when we start using the new model. Because let's go to that terminal window. Because this window is where we're running our predictions, right? What we actually hand over. In the other window, give me just a second. In this window, we're still running our previous, 200 epochs, right? So we are on epoch 75, we're on epoch 80. So we're nearly halfway through that training. So let's go see what that looks like. So now this is epoch 65. Okay, 65. I'm seeing 4, 4, 0, 6, 7, 8. That's a decent 8. Right? That's an okay one. But when this finishes, we'll be using these weights and running it, right? So Fabrizio wanted to see the weights. So Fabrizio, we have two files. We have a file for the discriminator here, and we have a file for the generator. But we know that the generator is the one we want to use. We can use the discriminator if we want to improve our model in the future, right? So we still want to hold on to that, like a reinforcement learning type of thing. But the generator is what you want to load in your generate image, right? And you can see that it's doing that here in that path, right? Um, Also, and it's also saving it in its own folder, in the generated folder. So these are all the generated items that we ran. It's pretty tiny, but these are the generated numbers that we ran. Um, if you open what's inside, can you show? No, Fabrizio, because it's using its own like encrypted format to store it, right? That's the whole purpose of saving it in that H5 format. Okay, so now we're up to 85. Okay, so this is 85, guys. So keep in mind, now we're almost at double the number of epochs that we ran before. What do you guys think here? Oh, 90 is available. What do you guys think of this? That's a pretty good 4. That's probably the best 4 that we've seen so far, right? We're starting to get something that looks like a 2. And we haven't seen the 2s very often, right? So that's pretty cool, right? That's a pretty good 9. Over on Instagram, Mohammed says, I have a small question. What are the neural networks? Um, so Mohammed, I have an entire playlist on YouTube that walks through the neural network series. This you're coming in on week, I believe it's week 8, where we're talking about generative adversarial networks this week. Okay. But what do you guys think of this result 90? I mean, you can see the improvement, right? I mean, that's kind of undeniable. Okay, there's 95. What do you think? What do you guys think about that? The 2 is getting better, right? This 2 is like getting more and more refined, yeah? Fabrizio says I can distinguish 8 out of the 10, which is good. Um yeah, I mean we're approximating that, right? Yeah, I mean, I'm guessing which ones you mean because we don't have a good 3, we don't have a good 5, right? Both of those are still kind of lacking. Um, 8 cells out of 10 cells, but there's 16 cells on the screen, right? So I don't know what you mean by 10 cells. 14 out of the 16, yeah. Yeah, 14 out of the 16 you can take guesses at. Some of them are still a little weird, but that's okay, right? Because guess what? We still have another 100 epochs to go. Okay, so now here's number 100. Okay, there's a pretty good 9. A pretty good 9. I'm still not seeing a good 3 or a good 5, right? I mean, we're not even approximating those. But very interesting stuff, guys. Really interesting. Fabricius has 10 epochs before it looked better, I think. So 90. Yeah, 90 was pretty good. Maybe it's deviating from a global minimum. Sure. But that's a good thing, though, right? Because remember, you never know what that minimum is. You're supposed to kind of fluctuate around a little. The the path to getting to a good algorithm is not a straight shot, right? So it's okay for it to go up and down and kind of find its way. So yes, you're right about that, but the deviation's a good thing, right? And by the way, that goes for all algorithms. You know, that's not exclusive to GANs or even exclusive to neural networks. So I don't think we looked at 105 yet. 105 is also pretty good. So there's a 1, 0, 4, 6, 4. Those are two pretty good nines. We're making progress here, guys. Making really good progress. Remember, and while we're monitoring these results and we're talking back and forth, this is all still continuously running. And the big companies do this too, right? I mean, I remember hearing when they were talking about O3 mini, I believe, or O3 high, where it took months and months to train that model. Like even with their large data centers and their distributed GPUs and all that stuff, I mean, the training for those models is taking like months. They're measuring it in months, right? Even with all of their big resources. So you can kind of see how it becomes a very intensive effort in a very short amount of time. Because here we're talking about a black and white data set of numbers. That's a fairly straightforward image data set, right? And when you think about, other images, different size of images, and then you're talking about video, these models require a lot of training, a lot of training. All right, let's see where we're at. We're at 110 now. Okay. That's funny. That looks terrible down there. Who knows what that is? Um, but this is good, guys. I don't know. Maybe it's just me, guys, but I'm excited seeing stuff like this. I love seeing the progress, right? I love seeing the networks kind of guiding each other, right? Or at least the discriminators guiding it to try to find its path, right? I think this is exciting when you see stuff like that. Okay, there's 115. What do you guys think about 115 here? It's getting there. Getting there. Anybody else have any other thoughts they want to share while we're waiting? Fabrizio says, can we save the weights of Epoch 90 if we think that's correct? So Fabrizio, you can save the weights as often as you want. You can save the models as often as you want. But remember, this kind of comes back to what I mentioned to you about disk management, right? So let's quickly talk about that. So if I go to my other window and I do my files, look at this. This is our discriminator up here. And then this is our generator down here. And remember, the generator is where it's at, right? Like that's what we want. This generator is what? 9.3 megabytes. Just 50 epochs of a very modest neural network got us to the weights, got us to a weights file that is 9.3 megabytes. So you could save every epoch if you wanted to, but you have the disk space for it, right? I mean, this is a very simple collection of neural networks. When you do something that's more complex, when you do more runs, all of a sudden that disk space management becomes important. And then this is where I tell people that you kind of have to do that management of this, and where I tell people how, if you remember, one of the tricks I told you was to put your loss or your accuracy in your file name. Because eventually you're going to have to say, oh, I got to delete some of this. And you're going to say, okay, anything that wasn't at least 0.95, I got to get rid of. And it's really easy for you to sit there or to be able to sort by it or do a search and say, if this doesn't say at least 0.95, I'm getting rid of it. Right? So yes, you could be saving it for Fabrizio, but you got to manage it along the way. It's not without its risks. And also, you'll see it when we do our when it saves next. We're going to remember that number, 9.3 megabytes. Our next generator is going to be significantly bigger, right? Because we changed the neural network, right? We changed the generator neural network, I should say. So it's going to be bigger. It's going to be bigger. Delina says, do you have courses on Udemy? No, I do not, Delina. I really don't have any courses out there. I rather just do the live streams, So I have a YouTube channel. There's plenty of information on my YouTube channel, plenty of playlists on my YouTube. So feel free to check them out there, okay? So we're going to go back to this. This is still our window. This is still running. We are on epoch 125. So we're getting closer. Okay, so now there's two more results for us to look at. So this is what 120 looks like. So 115 and 120 are very similar. Do you guys see that? Not a lot of differences there. Here's 125. 125 is okay. And then here's 130. I don't know, guys. We're still flopping around, but not a lot of changes in those 10 epochs. I mean, are you seeing a lot between 120 and 130? These are all kind of like the same result, right? These three. CJ says join the school. Yeah, thank you for mentioning that, CJ. So Delina, and anybody else in the chat, I did put out an attempt to start my own data science school, where I was gonna do my own version of what I think you need for real world data science, and to put it out there. I'm putting it out there at what I thought was an accessible price point. But CJ, unfortunately, it's looking more and more like I'm going to have to put a stop to that effort. I'm not sure that I got enough people to sign up. I got about 35 people to sign up, which was great. I'm really appreciative of that support, but that's probably not a level that lets me, make the school self-funding and justify the time away from my clients and my other, business activities. So I'm going to make a decision on that soon, but it's possible that I'm going to stop that effort. I was really hoping to get a bigger response than that. But we'll see. Maybe I'll do one last marketing push, but unfortunately, it does look like I might put a stop to that effort. And and that's okay. Everybody will get their money back. I'm going to refund everybody. Nobody's going to lose a dime. But I just haven't had the response I would need to really justify that away, because I do have my own clients, and they expect me to be available for coaching. So I might just have to focus on that side of the business. Okay, so let's look at 135. 135, better, right? There's a lot more. There's 60468129 undetermined, 919 undetermined, 879. So we're getting better there, guys. Prince Kara, hey Dennis, how are you? Hey Prince, nice to see you. Prince, I'm pretty sure you've been here before, so welcome back. Glad you're here. Let us know how you're doing. Fabrizio says, Dennis, let's talk about other uses of GANs. Let's say we are working with genetics. Can we do bacteria gene creation with this? Sure, you could. I don't know enough about that world to know what the incoming data would look like. I think the challenge there would be around the pre-processing of it all. How do you make that data like readable to a neural network, right? Like, what does that pre-processing look like? I don't know the answer to that. But can you do it? Sure. I mean, look, technically speaking, you could be able you should be able to use GANs for anything, right? As long as you can develop a discriminator, you should be able to develop a GAN for it. So yeah, I mean, is it possible? Sure, sure. It would just take specified work for that data set. Okay, so here's 140, and then here's 145. So we're approximating the end of our run, right? Because we said 200 epochs. So I think we're doing okay, guys. I think we're doing okay for these epochs. Fabrizio says, K-MERS is a way to store 10 sequences of genes, and you can use a neural network. My professor was using transformers, RNN, LSTM, so this can be done too. Okay, great. So we have about 55 more epochs to go, guys, and we'll have a new saved model. Any other thoughts that people want to share in the chat? My intent is that once we finish this run, we'll save out the weights file. We're going to look at the size of the weights file because it's going to be different. It's going to be bigger for sure. And then we'll do a couple of runs as a generator. In other words, the final product. And then we'll kind of wrap up from there, guys. But any other thoughts or any other things while we're waiting here? I mean, are you guys excited by this? I think it's pretty cool. I think it's cool that, math formulas are doing this type of generation for us. This is where it all started, guys. So everything you're seeing now with the video and the voices, the replication of the voices, all that stuff. I mean, this is the core of it. GANs sit very much at that center. Highly underappreciated how much GANs contribute to, basically all the cool stuff that we're having now. It's very undervalued in that way. All right, there's 150, there's 155. Okay. I think 150 is slightly better. Slightly better. Shurzay over on Instagram, thanks for joining, my friend. Shurzay says, came in late. Please, what tool are you using? Like MS Azure, Databricks, or which one? Oh man, Shurzay. I love that you're here. I think you're one of my new followers. So Shurzay, one of the things that people who have followed me know is that I am not an advocate for having to learn data science as a cloud tool, okay? That's probably the biggest mistake people new to data science are continuously making. Do not tie your learning to, well, I also have to learn Google Analytics. I also have to learn AWS. Just get a computer. Just get a computer and get Python on it. That's it. That's all you need. You can get so far with that. You don't even need GPU. You can do a lot with CPU. So, you mentioned Azure, Databricks. You don't need any of that. You don't need any of that at all. So, I mean, all I'm doing is I'm using a terminal window and I'm using my own machine. I use my own libraries or library installs. And yes, I use VS Code as my IDE, but that's it. That's it. You don't need anything else. Just a terminal window to type in your Python commands. That's all you need. So don't let all that nonsense and all those courses they're trying to sell. Oh, you got to get this certification. No, you don't. Just get started. Start working. Start running experiments. Forget all that nonsense. All right. So here's 155. Eh. And then here's 160. That's okay. 165 just came up. I don't know, guys. Like I think we're kind of hitting a little bit of a diminishing return on the results. Yeah. What do you guys think? Maybe feels like it, right? So this is maybe where we'd experiment with a larger neural network, right? But it does feel like we're kind of diminishing results at some point. Toshiro over on Instagram says, Hola. Well, same to you, Toshiro. Welcome. Glad to see you. I think you're one of my new followers. So anything we can help you with, let me know. Toshiro, right now we are waiting for our latest run of a GAN to finish. We have about 35 more epochs to go. So maybe another couple minutes here, maybe another 5 minutes. But thanks for stopping by. Hope you're doing well. So when I was talking about I never use cloud, why they use that maybe for production. Well, when you say they, I don't know who you're referring to, but let's assume you're referring to other people online. The only reason they're doing that is because, one, they don't know any better, right? Most of the influencers out there haven't worked as a data scientist. They're just trying to get money from you, right? So they're just trying to sell you a course or a certificate or really just trying to come up with fake content, right? Like, because they're not data scientists, so they don't have legitimate ideas, so they invent these things of the 5 certifications you must have. No, you don't. You don't need any of that. But it makes for good content, right? So I think they do that just because they don't know any better. There's very, 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 very few people out there like me that have worked in the industry and are doing content, right? So be very cautious of who you listen to out there. Okay, here's 170. We got a couple of good 4s, and this 2 over here is shaping up pretty nicely. So that's good. Oh, this 8 is shaping up pretty nicely too. So maybe we're getting improvement again, guys. There's 175. Okay. Okay, so maybe we're on an upswing here and getting more improvement. I will say this though, we're really not getting a lot of the number 5s. I mean, down here there's kind of some forms of a 5. In this corner there's also some generation of a 5 down here, but not a lot of 5s. Right? Up here there's a good 0. So that's a good 0. That's a pretty good 4. This 2 is shaping up, right? Oh, whoops. Didn't mean to. That 2 is looking better, right? All right, guys. So another 25 epochs or so, and we'll be able to get to our new generator. And remember, we're going to keep an eye on the size. We are at 9.3 megabytes for our generator, but that is 100% going to increase. But we can rerun our generator code here using the new model, and we should see significant improvements. So let's go back to Visual Studio Code. Okay, so now we have 180 available. 180, Oh, this is now forming into a 9 in this lower corner. I thought that was forming towards a 5. Doesn't it look more like a 5 here? But in only 5 epochs, it went ahead and formed something more like a 9. That's pretty interesting, yeah? All right, just 20 more epochs, guys. Just a couple more minutes here. I'm really happy with the way my machine is performing. I have tried to run GANs on my Mac Mini, and it wasn't anywhere near this fast. So glad that the timing of me getting this machine and this course kind of lined up that way. All right, so here is 185. CJ says 2.5 hours already. Feels like we just started. Hey, time flies when you're having fun, right, CJ? Because like I said, I'm amazed by this. I love generative AI, so I love seeing like the roots of where it started. So yeah, it's gone by quick. But I gotta tell you guys, these take a lot out of me. I'm tired after these things. You guys forget that I'm an old man, so I'll get tired after this. When this is done, I'm gonna have a little bit of breakfast. I'm gonna sit here. I'm gonna watch my shows. Right now, I'm watching Ted Lasso. Nobody spoil it for me. I'm new to Ted Lasso, but I'm gonna sit here and I'm gonna binge watch Ted Lasso. Gonna let my mind just relax for a little bit because these things are hard to run, guys. It's hard being a live streamer. Jeez. But yeah, CJ, it's been a lot of fun today. It's I mean, to me, the GANs is just kind of like amazing, right? Like I feel so lucky to be able to live in these times. But yeah, it's already been 2.5 hours. Crazy. Okay, so here's 190. 190. This little square down here hasn't really kind of revealed itself yet, right? I mean, there's kind of different things. It's tried to be a 7 a couple of times, in some of these epochs, but who knows where that's going to end up, right? But that's 190, so only 10 more epochs, guys. 10 more epochs. Fabrizio says, can we do a class on transformers and reinforcement learning next time? Maybe. Transformers could be a whole series, right? So maybe that could be a series. Maybe. Yeah, if you guys have suggestions for series, let me know. Maybe that could be a series. I appreciate the suggestion, Fabrizio. Delina says, I'm trying to do your steps on my laptop. Danger, danger. Danger, danger. A laptop is usually not enough processing power. But let us know how that goes, Delina. Let us know. Because remember, guys, you're also seeing this speed based on GPU, right? We specifically asked it to use the GPU versions of Keras and TensorFlow. And judging from my past experience, this is using the GPU because I've done this on CPU and the epochs do not happen this fast. Okay, so here's 195. So this is like the second to last check we're going to get, right? Because pretty soon it's going to hit the 200 epochs and then we're done training. Yes, I mean, this is still not terrible, right? Not production ready, but not terrible, right? And then when we get to 200, we'll be done. CJ says, for the generator, is it mandatory that it starts randomly, or can we give it a portion of number and let it guess the rest? Yeah, so CJ, so now you're talking about how you incorporate this into generative AI, right? Because in generative AI, we do prompt, right? We do say, hey, don't just draw me any number, draw me a 6, draw me a 3, right? So it's not mandatory that it starts with randomness, but the early versions of it definitely started with randomness, just like we're doing it now. Okay, guys, so here's 200. That's not bad. So now we're done, right? So now if we go back to our terminal, it should be sitting there waiting for us. Yep. So excuse me, sorry. So it saved it. It saved our model, and it saved our generator and our discriminator, right? So if we go to our other window, so remember, our generator is 9.3 megabytes. Our previous discriminator, I should say, was what is that? 880 kilobytes. 9.3 megabytes, 880 kilobytes. Okay. Now let's see what they're at. Whoa! Look at that. That's 18 megabytes. So we doubled the size of our generator. We're at 18.4 megabytes for our generator, and roughly the same for our discriminator, which makes sense, right? Because the discriminator, we played with the dropout rate, which wouldn't have a material effect on the size, right? Because we didn't change any layers or the nodes, right? So the weights are the same, right? But on this one, we did expand the neural network, and we just a little bit less than double the size. So again, I'm just saying that to illustrate that you could be saving every epoch, you could be doing a lot of things, but you can't ignore disk management. You can't ignore what your final deployment looks like. 18 megabytes is not a lot on a desktop or on a server, but it's a lot for a phone, right? If you're going to be deploying this on a phone app, what then, right? There's still ways to get around that, but things to consider. Okay, so now we can use this to generate. All right, so here's our first generated number. What do you think? What do you guys think? So this is using our new, bigger generator, right? What do you guys think here? Nobody? Nobody has feedback on our new result? I think that's a 1. So yeah, that's a reasonable one. Some people might say a 7, right? But that's only one example, right? Let's try another one. Because remember, some results are going to be better than others. Oh, look at this one, guys. What do you guys think of this one? Fabrizio says that's perfect. Yeah. Yeah, I mean, can we agree that that is the best generated result we've had so far? Like, I think we can, right? I mean, that's pretty much a perfect 9. Like, I think it'd be hard to say that we've had a better generated result than this, right? I can't think of anything else that we've generated that's been better than this. What do you guys think? Best 9 ever drawn by a computer. You know, Fabrizio, I love the way you put that because it was drawn by a computer, which is crazy, right? It was drawn by a math formula, right? So, yeah, I mean, that's probably the best number we've had. Let's go for another one. Okay, what about this one? Not so great, right? This is kind of a fail. I mean, is that the start of a 5, a bad 4? Like this is not good, right? Like that one is not good at all. Osama says it's a bad 5. Yeah, it's like a bad 5, right? So this isn't great, right? Let's do another one. Hmm. How now? What about this one, guys? Fabrizio on the last one says not good. Yeah, the last one was not good, Fabrizio. What about this one? Is this one any better? Obviously, the obvious answer is that it's an 8, but to me, it looks like a reversed 6, right? Like a mirrored 6. You could also say it's the letter A, right? So, not so great. Not so great there, right? What about this one? Fabrizio says it's an 8, but can be better. Well, you can't say that, Fabrizio, right? Because it's all like it's in the eye of the beholder, right? Some people are going to say it's another number, and that's the hard part about generative data, right? That you are creating synthetic results, and they're not always going to be the same thing to everybody. So it can be an 8 to you, but it could be a number to something else to other people, right? I mean, that's the trick to all of this craziness that we go through, right? See, this one is could be an 8, it could be a 4. I mean, overall, it's just a bad number, right? One more, guys. Okay, what about this one? Kinda, sorta an 8, kinda, sorta a 6, right? All right, so Fabrizio's seeing an 8, right? Some people would see a 6, maybe. So I hope you guys are seeing that it can vary, right? We saw a really good 9 and we saw some not so great numbers. Same generator. So we still have work to do on fine tuning the generator, but that's just the way it goes, right? That's just the way, these things go. But I hope you've been able to kind of understand the different components that are required to do all this, right? Because we talked about a lot of components, we trained a lot of components, and we also invested the most time in training today, right? I mean, We've run 200 epochs before, but they were much quicker, right? But today we invested a lot of time in training essentially the same architecture, right? So this is where we would continue the experimentation, because guess what? You can do a grid search in neural networks too, right? In generative adversarial networks too. There's nothing stopping us from having a grid search for these same architectures. It's a lot more complex and it's going to take a lot more time, but the same approach applies. You're still going to say, okay, well, I'm a scientist. I know how to try different hyperparameter values. I know I need some tuning on my hyperparameters. We did a form of tuning with when we adjusted the dropout rate, right? Not grid search, but experimentation nonetheless. And this is where you go, and this is where you start, and this is why it's time consuming, and why, and rather what you're doing on a daily basis as a data scientist. Like, this is the job, right? So I hope that's been helpful to all of you. And I think that this will be the last one in the neural network series, because I think it has been interesting. So I want to thank all of you for joining me for this series. I hope today was beneficial. I hope you can see how today, GANs are a big part of what you're seeing in the current generative AI craze, or generative AI era that we're in, right? Because this is where you start to kind of see the power of neural networks when they're kind of working alongside each other. And also the fact that we are now not just thinking about them as individual neural networks, but we're thinking about them as architectures. And that's really what it comes down to, right? What we know what the components are, but now how can we put those components to work for us and have it be a smart machine that generates things for us, right? So I think that's pretty cool, pretty exciting. So thank you so much for hanging in there with me. We went for almost 3 hours. I can't believe it's already 3 hours on my end. But yeah, I think that wraps up the neural network series. If there's anything I can help you with, please let me know. Send me a DM. I'm also available for individual one-on-one coaching. But just really thank you so much. I'm so grateful I get to be able to do this with all of you guys. And as always, as I tell you guys, we live in a very crazy and dynamic world. So please, take care of yourselves, take care of each other, take care of your families, and I'll see you guys next time. Hey everyone, good morning. Happy Sunday. Hope you're well. I'm so happy to have just wrapped up a pregame session over on Instagram. So I hope that you've made the move over to YouTube, because I am going to be doing the class here on YouTube. So thank you so much for joining me on this beautiful Sunday. This is the kickoff session to the Introduction to Statistical Learning book that we're going to go through. My intent is to go through for the next 8 Sundays. We're going to be doing a live class that's going to cover all of the chapters as we go along. So my intent today is to cover chapters 1 through 3, and then we're going to do 4, 5, 6, and so on, all the way to chapter 10 in 8 weeks. So I'm so excited to see everyone. I've been working on my educational setup here locally with my machines. I've been developing a deck. I'm going to be bringing some new things to you. So I'm just really excited to get started. Really happy you could join me. If you're not able to join every single session, that's okay. I'm saving the replays here on YouTube. And then I'm also adding my own, I'm going to add them all to their individual playlists, so you can always refer to them in the future. But yeah, so just really happy to see everybody. I am streaming on a couple of different platforms that do allow for the longer format, but the primary platform will be here on YouTube. And I'm already seeing some people in the chat, and you can see the chat up here over my shoulder. So let me also emphasize that you are welcome to stop me and ask questions at any time. I'm very big on interaction back and forth, and also it's possible that I might overlook a question or overlook a particular concept in the book or something that I'm not explaining clearly. please feel free to stop me. I do not mind that at all. So, just kind of want to make that clear from the beginning, just to make sure that everybody is comfortable, with understanding and kind of how we're going along. But like I said, it's the Introduction to Statistical Learning book, obviously a very important text when it comes to the world of data science. And I want to make sure that one of the things that I'm really big on is I'm really big on being intellectually honest, right? I don't want to steal any of the author's work. So I want to thank the authors of the book. And I hope to be building upon what they've already published, not copying, but building upon what they're doing. So I hope to be, paying them the proper respect with that. And, hopefully you'll see some new things as we go along, because I'm going to be, kind of adding my own thoughts and whatnot. Okay, so to kick off, I want to make sure that I address some of the chats. We already have an active chat. We haven't even started. We have an active chat, so that's wonderful. And again, feel free to stop me at any time. So let me make sure I look at some of the chats, and I can pop them up on the screen here. Actually, first chat is from Patrick. So Patrick is going to be acting as our moderator today. He's going to be helping me in the chat, just in case I miss anything. So thank you for that, Patrick. Llama Land says, hello, been waiting all day for your live. Oh, thank you so much. I appreciate that. Yeah, I mean, for me, it's morning. For me, it's 8 a.m. in the morning, but I do realize that for some people, it is later in their day. So thank you so much for staying up with me. Giuseppe says, saw your post yesterday on IG, and I'm currently reading the book. So excited to learn more about it. Yeah, right now is back to school time in some parts of the world, and a lot of parts of the world. So I'm getting this comment a lot where people are saying, oh, I just bought the book, or my class is in the second week of the book, or something along those lines. So yeah, so I'm glad it's lining up for you there, Giuseppe, and maybe I can just kind of give a different take on what you're going to learn in other ways. And like I said, I'm going to be adding my own twists and turns. I'm really excited to be showing some of those very shortly. It's going to be in some of my early slides, okay? 8G-Man says, looking forward to this. Thank you, 8G-Man. I'm looking forward to it too. Tariq says, will you post this as a video as well? Yes, absolutely, Tariq. Like I said, it's going to be on my YouTube. The replay will be on my YouTube. And then I'll post an alert on Instagram when that replay is available. It should be right after this session ends. And also keep in mind that the last time I did a class, we went for 2 hours. I expect that we're going to do something similar. So, if you have to step away, that's okay. Come on back. Maybe you missed the first hour. We'll probably be here beyond an hour. So come on back, check in. You can pop in late, no problem. Patrick, thank you so much for the assist there. Appreciate that. Joseph, hello, Dennis. Hey, Joseph, how are you? Good to see you again. Issa says, I hope next week we can have an overview of what topics will be discussed. I am still on chapter 2 right now. We're going to do that today. I'm going to start off with a philosophy and my goals for the class, and we'll go from there, okay? Tariq says, awesome. I'm currently traveling and can't join today. I greatly appreciate this type of content. Yeah, I can appreciate that not everybody will be available every time. So it will be, the replays will be available. Feel free to come back and look at them anytime you need. Hello, sir. I thought of starting the Python Data Science Handbook by Jake Vanderplas, but you are suggesting ISLP. Which one should I start? Issa says ISLP is a good start. It is beginner friendly. Ooh, I'm not sure if I'd agree that it's beginner friendly. To me, it's a book that is very hard to learn outside of the classroom. I mean, personally, I think I'm taking a big risk trying to teach the book. I mean, who am I to tell you how the book is? But what I'm trying to do is I'm trying to show you the real world side of it. And like I said, I'm going to be adding my own twists and turns. So, just hang around a little bit, Issa. I think your question will be answered, as we go along. Okay. AJ Patro says, is math a prerequisite to ISL? So AJ, I'm going to tell you no. And the authors will also tell you no, and I'm going to show that to you as we go along, okay? So great question, and, I see a lot of familiar faces in here, so I know you guys have attended my streams before. So most of you know how I feel about math and data science. I think the requirements are overstated, and, I really don't agree with a lot of the data science influencers or other, every once in a while I'll catch little glimpses of other accounts, and I really don't agree with people who overemphasize the math. Personally, I think it's an intimidation tactic, gatekeeping, whatever you want to call it, where people overstate it. But, I've been in the business for a long time in the real world, and I can tell you that you're mostly using libraries. So I like my staff, the data scientists who work for me, to have a good understanding of math, like a general understanding of what's happening, like, kind of underneath the code. But if you're writing native math and having to look up formulas and things, there's something wrong in your process. You've gone off track in your process if that's the case. And also, there's a lot of risk in writing your own math, right? I mean, having a math formula in front of you and implementing it properly in code are two completely different things, right? And sometimes those errors aren't obvious. Sometimes they're errors that you won't discover for years, and that's a massive problem, right? They can be very small errors. So I think you're going to be fine, AJ. Not you, AJ, but anybody in the chat or anybody listening who feels intimidated by the math and data science, I get it. It can be intimidating, but don't be. I'm going to make it as easy as possible on you. I'm going to give you kind of my own take on some of the math, okay? Kartik says, I even started ISLP by myself. You're brave. You're brave, Kartik, so good for you. Good for you. That's a bold statement, so good for you, my friend. Siddiqui says, I am very excited about these classes. I am too. This is fun. Like I've mentioned before, I will never, ever, ever, ever do pre-recorded instructional data science content. If you guys ever see me doing that, you can definitely say Dennis has lost his mind, because to me it's boring to put together. I can't imagine anything that I want to do less than sit here and put together pre-recorded data science content. And two, I think it's boring for you guys. I personally don't sit through that content. I think it's boring. So why would I want to produce something that's boring for me and boring for you? So I do these live. I stream as often as possible. I'm going to be streaming quite a bit, for the next few months here. So hopefully you'll join me and keep on coming back. But yeah, I'm looking forward to these two just because this is fun and, lets me spend some time with all of you, okay? Llama Land says, this book is more math-oriented than the hands-on machine learning one. Not necessarily, my friend. Not necessarily. And I'm going to show you that. I'm going to show that to you, okay? So I'm not sure if I agree with you. I think the authors do a great job of explaining it without requiring it. Because, they're ultimately, this book is still very code-based. And when it's code-based like that, they're still relying on libraries. So I disagree with it being more math-oriented. There's math in the book, but it's not something that's, required for you to do in the book. Like if you look at their exercises, right? None of their exercises in the whole book, their labs and all that, none of them require you to write your own math, right? So that's kind of the measure that I use. Video Game says, hi, Dennis. Hi, Video Games. Nice to see you. Thanks for joining us. Neiman Stravan says, this sounds exciting. Oh, well, thank you. I'm excited too. So thanks for saying that. Llama Land says, I'm mostly afraid of the SVM math. It is heavily emphasized on duality and Lagrange things. Yeah, okay. But how many times are you going to be using that in your career? I mean, you got to think about the practical side of it. I could think of 5 other things that you are much more likely to use than, SVMs, right? So don't worry. We're going to be just fine. We're going to, get through this step by step. I don't think we get to SVMs for a couple of chapters. I can't remember what chapter number it is. So it'll be a couple of weeks before we get there. And quite frankly, I'm just preparing the material as I go along. I've only prepared this week's material. I'll prepare next week starting like Thursday or whatever. Because, we're just going to take it step by step. And like I said, I'll be showing you some of the real world stuff I'll be emphasizing the real world stuff. Okay. All right. So that was a good introduction as far as the chat goes. So you guys ready to get started? I'm ready here. So I'm going to switch over to my classroom view. We're still going to have the chat. So like I said, we still have the chat. You guys can still see me, and you're still going to see my desktop, my instructional desktop. Like I mentioned earlier, if you need to stop me for a question, please feel free to do that. I also believe in the Socratic method, so feel free to let me know. I'm going to be asking you questions, right? I'm going to be throwing out questions to the chat. So keep your speakers on, keep your headphones on. Feel free to participate as much as you'd like, okay? And there's no wrong answers, right? So nobody needs to feel like they're going to give a wrong answer, right? We're all learning. Amit says, hi, would you cover it application-wise and industry-wise? Maybe. I think the authors have something to say about that, right? So maybe, so I'll be pointing out some of those things. Okay, all right, guys, so let's get started. So I'm calling this the ISL book guided discussion because, again, my intent is to honor the authors, not copy their work. So my guide to you will be around the things that I find are important, or maybe I'll be expressing things in a different way than what the authors do, because I've seen it in the industry done in a slightly different ways, or just expressed in different ways. So that's really the goal here, right? To provide a guided discussion while still honoring the book and, honoring, really just the high level of instruction that's available in the book, okay? So today we're going to cover 3 sections. This is the first section. In this section, I'm going to give you a little bit of an introduction and my own philosophy. We're going to have a kickoff to explain how I see us working together, and then also a class agenda, all right? So the first part of my philosophy is that I take data science as a very serious profession. I equate doing data science like a lawyer or a doctor. It's an academic profession, but it's also a learned profession. You're going to learn things in, sorry, let me get rid of this chat on my screen. You're going to learn things in the classroom, but you're also going to learn things on the job, right? If you're a lawyer learns a lot in school, but they don't learn how to always stand in front of a judge and be like a litigation attorney, right? That's like a whole other set of training they do after they graduate. So my intent here is to help you show you some of those combinations of the academic side and the real world side. And then you'll also understand that there is no shortcuts, no hacks to how we go about actually doing data science, right? We are not here to crack the data scientist interview or all those other things that you hear about. We are here to do, professional level work in data science. And then finally, a data scientist must maintain flexibility in thought, in their approach to problems, in how they see the world, how they see different models and the different business issues that are in front of them. So I'm going to try to put an emphasis on that for all of you here. Okay? All right, before I go to the next screen, quick question, guys. How does my audio sound? I just realized that I have my fan on above me, and I don't know if the microphone is picking up on the fan or not. What do you guys think? Is the audio coming through okay? Give me some feedback in the chat, please. Let me know how my audio is sounding, because otherwise I'm going to have to shut off the fan. Is everything sounding okay, guys? Okay, so Patrick says audio is great, no problem. Okay, thank you for that. All right, so next screen. As I said, I teach with the Socratic method, so I'm going to be asking you questions. So please, feel free to participate and let me know if you have any thoughts, or I'll be asking questions, getting feedback from you guys. So it helps the class go a little smoother that way. Also, you will not be ready for a job after this series, but I'm going to help you build a pretty good foundation. The ISL book, just to give you kind of the scope of things, the ISL book is typically just one course in a full master's study, right? So there's a lot more to learn, things that you want to kind of get deeper knowledge on from the ISL book. But I just kind of want to set that expectation for all of you that you should still be doing work on your own. You should be doing work beyond this book. Because again, our goal isn't just to land a job. Our goal is to dedicate ourselves to the profession of data science. That's kind of why I do these classes, because I want to build that professional mindset in data science. All right? All right, so thank you so much for the feedback in the chat. I'm seeing that the audio is good, so I'll keep it. Okay, so going to the next screen. All right, guys. So here's where it gets a little bit, more exciting, because this is kind of, where I'm adding my own secret sauce to the approach, right? So Introduction to Statistical Learning, ISL, has long been recognized as a book that gives you a really good foundation for professional level data science, right? I mean, this is not a quick tutorial or anything else. It's a very, dedicated book. It started off as ISL for R, which was known as ISLR. And then I think in the past 3-4 years, they've developed a Python version, which is known as ISLP, right? And we've already seen some questions in the chat about that, about, should I take this one? Should I take that one? Personally, I learned on the first or second edition of the ISLR book. So I actually took this course in R. And one of the things I've also recommended, if you look at my roadmap for students, I recommend that everyone start with the R version. And even if your favorite language is Python, as it should be, take the R version and convert the code to Python. If you do that, that's a very valuable exercise for your learning. Okay, so something for you to consider there, guys. Start with the R version, understand the concepts, and then do the labs, but in your own native Python code. Super valuable exercise. So we have R, we have Python. My addition, my addition, or rather my intent again, is that I want to build upon their work. I want to build upon their work and, honor the ISL authors, because it's intellectually dishonest to copy somebody else's work, right? So my addition is that I'm going to do this entire course using Gen AI. So this isn't going to be ISLR or ISLP. I'm naming this ISLA. This dovetails into some of the previous videos and some of the previous content that I developed about what the future of data science is, because I truly believe that this is the future of data science, where we are going to be code editors, not code writers. So that is something that I'm calling the blank screen effect. So nobody in data science, and even in code development and software engineering, should start with a blank screen anymore. There's a lot of industries that shouldn't start with a blank screen anymore, right? If you're a lawyer, an accountant, a real estate agent, a software engineer, and you're starting with a blank screen, you're done, right? You're done. You shouldn't be doing that anymore. And we as data scientists shouldn't be doing that anymore. So we are going to write. We are calling this the ISLA course, and we are going to have these goals, right? We're going to be data scientists that are heavily aided by AI tools for development. We're going to learn the concepts from each chapter, but then we're going to take that understanding to become prompt engineers and prompt an AI tool. And then our goal will be to edit and refine the code to reach a deliverable state, but we're not going to be writing any code natively, or as little code as possible natively. Okay? So that's really kind of the twist that I'm adding to this, because I don't want to sit here and write code on a blank Visual Studio screen, because that's simply not the way that you're going to be doing it in the workforce. I think in as little as 2 to 3 years, maybe even faster than that, maybe 1 to 2 years, right? So that's really, it would be worthless for me to just kind of teach you the book that way. We're going to look at it strictly from an AI perspective. So we're going to sit here, we're going to learn the concepts, we're going to use ChatGPT, and we're going to work accordingly, okay? So I hope that, that you find that exciting, because I really, I truly believe that this is the way of the future, right? A lot of when you hear about people being threatened by their jobs or having their jobs threatened, this is why, because you'd be starting with a blank screen and you'd be writing things that Gen AI can do for you very quickly. So our goal here is to adapt with the times and start learning data science as a scientist that uses Gen AI tools to assist their work. All right. So how do you guys feel about that? Everybody still with me? Send me some feedback in the comments, but I'm going to keep on going here. So here's what I think about the agenda. So I'm going to be going chapter by chapter, and I'm going to give you guided instruction for the highlights of the ISLA book. But you should still feel free to do work on your own. And I'm going to be giving you like little like ideas for things that you could be doing on your own. That's how we're going to close every class, okay? I'm not going to cover every single section, but I'm going to give you the highlights. And then we're also going to do 1 to 2 exercises as a lab together. And then you can build upon those if you'd like. And then I'm also going to be working off the ISLR version 1 PDF. You are welcome to work from other versions, but that's the one that I like. That's the one I learned on. It's the one, I'm going to be using the PDF on the screen, but it's the one that I have the hard copy for. So whenever you see me holding a hard copy, this is the R version. I've had this book forever. It's so dirty. I hate even showing it because I've had it forever. But yeah, so that's the version I'm going to be using. So feel free to follow along with the same version, but you know, it's up to you, you know, how you want to go about them. There's a couple versions available on the website. Okay, good. I'm seeing some good feedback in the chat. People are on board with it. Explore the beauty. Good to see you again, my friend. Says this makes sense. Good. Patrick says ready to build some Gen AI skills along with my DS skills. That's the goal, Patrick, right? Because this is going to be the future, right? If you're sitting there with a blank screen, yeah, that doesn't make any sense. So yeah. Very much looking forward to learn this mindset, since how many courses think about that. You know, Llama, I like to think I'm the first person bringing. I think I'm certainly the first person bringing this book in that way, right? The ISLA approach, right? I don't think anybody else is doing that. I know there's other people doing, you know, obviously Gen AI with data science, but you know, we're going to learn together here. But I do think that we are breaking new ground in that regard. But again, this is the future. This is the future of data science. This is what you guys need to be learning if you want to, you know, kind of advance forward. So Melly Dare says you can find the book on Z Library. You know, you can find the book directly from the authors. You know, because I researched this prior to starting because I don't want to violate any copyright laws. You know, I'm very big on respecting people's intellectual property. The authors themselves make it available. You can go to, yeah, thank you, Patrick. Patrick has put that in the chat. Yeah, statlearning.com. They freely make it available. Anybody can download it. I don't think it's always been that way. When I first got this book, I think you had to provide your email or something like that. But yeah, but now they just give it completely free. So Amit says, I'm here to revisit the ISLR book. It has been 6+ years since I haven't revised it. Yeah, that's a great idea, Amit. And maybe you'll pick up new ideas when you're looking at it from a Gen AI perspective, right? Because again, we're not going to be writing code. We're not going to be sitting here copying the code from the book. We're going to be using Gen AI tools. Joseph says, I like the idea of integrating Gen AI and DS as it will be the future. Yeah, great feedback, Joseph. Thank you for that. Glad to see you guys are on board with it. Again, I really think that this is the way all development is going. So I'm going to show you how I would go about it. All right. So let me see what else I have on the class agenda. Yeah, so as I said, you are encouraged to get that PDF and get it prior to each stream session. My intent is to provide these classes every Sunday from now on. I make the announcements on Instagram, and I'll also I post some stuff in the community section of YouTube, but I'm not sure how many people will read that. But yeah, you're welcome to follow me on Instagram. Feel free to subscribe here on YouTube so you get those alerts. And the live streams will be hosted here on YouTube, as I mentioned earlier. All right, so these are the topics that I intend to cover. Or rather, this is what's covered in the book. General concepts is what I'm calling chapters 1 and 2. And then chapter 3 focuses on linear regression. And then you can see the different sections that are covered in each chapter. And after today, it's my intent to do one chapter every week. So some sessions will be shorter than others. But this is the schedule that I intend to keep following along with these chapters. So somebody mentioned SVM. Yeah, so SVM, we're not even going to get till chapter 9, which will be the second to last week. So that's 7 weeks from now. So if you're intimidated with the SVM math, that's okay. We're not going to be there for a while, okay? And yeah, okay, so before I go to the next screen, Melly Durr says, what is Gen AI, please? Okay, so Gen AI, we are referring to generative artificial intelligence tools. My focus will be on ChatGPT. You are welcome to use another tool. But basically, we're going to be asking AI to write the code for us. So that's what we're talking about when we're referring to Gen AI. So the ISLA that I'm proposing, the A stands for artificial intelligence, okay? Maybe it should be ISLAI. You give me some feedback on that, guys. I kind of like the ISLA. But you guys, let me know if it should be ISLAI. Giovanni says this is going to be great as I am to start iMaths in data science. Well, great, Giovanni. Good to see you here. Isa says Gen AI is generative AI like ChatGPT. Thank you so much for the assist in the chat, guys. I don't always see the assists ahead of time, but thank you so much for jumping in there, guys, and helping each other out. That's wonderful. I love seeing that. AJ says, so it will be AI code and our job will be refactoring and debugging it. Absolutely, AJ. That's a great way of putting it. So it's not just going to be about refactoring, though. I call it, you're going to have to be a data science architect or a software engineering architect, right? Because you're going to have to kind of see all the different pieces that you need in your code. So as a data scientist, you might say, okay, well, I need some code to do my training. I need some code to do my cross-validation. I need some code to do my runtime predictions. Let me make those separate classes. So I need 3 separate classes, and they need to talk to each other this way, and they're going to talk back and forth using this data approach. So you are still going to be adding all that design, that architecture level design, and then asking ChatGPT to write that, right? We're not going to see a lot of that today, but in the future we are going to see that, where you are going to be more like, okay, it's not just ChatGPT, give me code. You still have to guide it and say, well, I need this object, and then I need this object to look like this because it needs to talk to this other object, and then I need the code to consume those objects, right? So you're not far off the mark, but it's definitely going to be more than just refactoring and debugging. You're going to have more of a design mindset to say, oh, okay, yeah, this is like my business stakeholders approach me with this problem, but this is how I see it in my mind. I need these objects. I need this data. I need to pull it from this source. So that's what you're going to be doing more of, okay, AJ? If I lost you in a couple of those terms, that's okay. It's going to make more sense as we go along in these coming weeks. Kartik says, is there any community or on any platform you guys are on? Kartik, not yet, but I am going to be launching a Discord soon. I have a Discord ready to go now. I just wasn't sure if people were interested in it. But yeah, I'm going to be sending out something on that soon. Okay, so bear with me on that. Ashish votes for ISL-AI. Rahul votes for ISL-AI. Okay, I'm kind of liking both of those. Isa upvotes ISL-AI. I like ISL-AI. So Explore the Beauty is the only one that's with me on ISLA. I kind of like ISLA, but there's clearly ISLAI sounds better, directs it to the uses and intended for this series. Okay. Or Joseph puts the I in lowercase. I'm wondering if that's intentional. I think it is, Joseph. But yeah. Sravan says, sorry to ask, but how can we reach out for any questions or doubt? Right here, Sravan, you're in the right place. So feel free to put them in the chat. I will try to address the chat. As you can see here, I do try to pause and address the chat. Or if something is not clear, feel free to put something in the chat. If I miss a question, I'm gonna do my best to scroll up, or maybe Patrick can remind me if I missed a question. But you're in the right place to do that. And like I said, I might start a Discord to help all of us kind of stay in contact throughout the week. But we'll see, okay? All right, so let me go to the last screen in the intro here. So I want to emphasize something with you, that if you were to take classes from an Olympic athlete who throws the javelin, right, as an example, they're going to show you like the highlights, like the main like factors in how to do things, right? They're going to tell you like, oh, you need to hold your arm this way, you need to run this way, and then you throw it at this point. They're going to give you like the high level pointers, right? But you might have questions like, well, why does my wrist have to be this way? Like, how do I know where to put my wrist, on the actual thing? And that athlete is going to look at you and they're going to say, I don't know, I've just always done it that way. I've been doing it for the last 15 years. I don't even think about it anymore, right? So I'm telling you that I feel that way also, where there's going to be things that I've been a data scientist and a software engineer for a long time. So there may be times when I'm going to say something that is just normal to me, but maybe you guys don't understand it, or somebody who is new to the industry wouldn't understand it. So feel free to stop me and let me know when you need more detail. But there might be times when I'll tell you, I don't know, I just always done it that way. I just the way we do things, right? So if that happens, I'm kind of just setting that expectation with you guys, because it may very well happen. But just keep in mind that I may just gloss over things, not because I'm trying to be fast or anything, just because I haven't thought about it in so long. So bear with me on that, okay? All right, so let's get into section 2. So in section 2, and by the way, this is the second of 3 sections we're going to cover today, right? So in section 2, I have basically condensed chapters 1 and 2, and then maybe we can talk about some self-study that you can do based on chapters 1 and 2. And it sounds like some of you have already read chapters 1 and 2. So that's good, okay? All right, so again, I'm going to be trying to break things down for you in a simple way, in a real world way. So one of my biggest takeaways from chapter 1 is that what exactly does it mean, introduction to statistical learning? Like, it doesn't really like ring a bell in terms of like general topics or professions, right? So the authors establish that introduction to statistical learning is essentially data science. I think that they were maybe locked into the title because of the previous works that they had done. I think, what was their first work? I think it was Elements of Statistical Learning or something like that, ESLP. But this is basically a data science book. So I want to establish it to you from the beginning that when you hear ISL or the ISL book, you should be thinking data science, because this is essentially a data science course and it's a data science book. Personally, I took this course as part of a applied statistics master's study, because that's what my master's studies were in. I did it a long time ago, so data science degrees weren't even available then. And maybe you live in a state or a country where none of the universities that you're considering have a data science course. So applied statistics might be the closest you can get, and this book or this type of course would be part of that. But let's establish from the beginning that statistical learning is a synonym to data science, okay? The next thing that they emphasize, or that we think about when we think about data science, is we think about the different types of outputs. And the authors emphasize that there are quantitative outputs, there are qualitative outputs, and there are clustering outputs, right? Those are basically like the 3 things that data science can do. Okay, guys, so this is me using the Socratic method. In the chat, feel free to pick one of these and give me your 10-second elevator pitch on what's one of these outputs. What is a quantitative output? What is a qualitative? What is clustering? You don't have to do all 3. Just pick one. Hopefully you guys will pick different ones. What do you guys think? Somebody give me an example of these outputs. So I'm going to give the chat a couple of seconds here. But drop me in the chat. What do you guys think? What are we talking about when we mean quantitative or qualitative or clustering? Give me your 10-second elevator pitch. Don't be shy. Put it in the chat, guys. All right, Joseph says a quantitative output is one that yields a numerical value. All right, anybody else? I'm not going to give my answer right away, right? Because I don't want to bias you guys. Quantitative output is measurable. Okay, cool. Quantitative output is something we can count. All right. What about qualitative? Anybody want to take on qualitative or clustering? Quantitative output is like an output of a regression problem. Clustering is trying to find out a correlation among available data. Okay, Seed None, welcome to the chat. Thank you for volunteering for clustering. Qualitative says insight about data, maybe. Ooh, Ashish, but isn't everything we're doing insight about data? Give me a little bit more. I think you're on the right track, but give me a little bit more. But insight about data is everything. Is all data science, right? The three are all under supervised machine learning tasks from an ML perspective. Okay. Now remember, guys, this is all in chapter 1, right? So they haven't even proposed any models at this point. They're just talking in chapter 1, right? They're just kind of laying it out for you. So don't be tied to, oh, this is regression, or this has to be this, right? They're just talking in generalities here. So don't necessarily tie it to a model yet, right? Patrick says a qualitative output is a rejection of a hypothesis. Okay. Isa says regression is quantitative. Muhammad says clustering. Muhammad, welcome to the chat. I don't think I've seen you before, but welcome. Clustering, grouping according to similarities. All right. Melly Dare says qualitative is like colors, etc. We can't count it. Ooh, Melly coming in strong with the unique description. Nice. You know what? I'm not hating that description, Melly. Good job. It's a unique description, but I'm not hating it. I think I'm with you. Okay, Kartik says qualitative is classification. Trap Bushali, Trap, welcome. I don't think I've seen you in the chat, so thank you so much for joining us. Qualitative is sentiment analysis. Okay. Give me a little bit more on that. You're not wrong. I like that you tied it to an example, like a programming example, but give me a little bit more. Why would you use it for sentiment analysis? 8 G-Man says quantitative would be something like the average of a sample. Qualitative is the average of a sample A is bigger or smaller than sample B. Clustering would probably be seeing trends within a data set. Okay. Amit says clustering is something where things can be grouped on the basis of some common quantitative, qualitative parameters. All right. What else we got? Quantitative outputs is like prediction of value, like house price. Okay. Qualitative is an output that helps use descriptors, words, pictures that help understand the nature of the data or observation. Yeah. Okay, Joseph, I like the way you put that. Oh, by the way, guys, no using ChatGPT. I forgot to mention that, because Joseph, you wrote a beautifully written answer, so it's almost too suspicious. But I'm going to give you credit for that. But no using ChatGPT, guys. All right, that's not quite the purpose of the exercise. Clustering is kind of sorting things like fruits. Okay. Quantitative is a numerical way to represent the output. I like the way you put that, AJ. No name. Welcome to the chat. I haven't seen you here before, so welcome. Quantitative is about finding insights or numeric forms about data, about relationships between two or more features of the world. Data about between two or more features of the world. Qualitative is about intrinsic, contextual information. No name. I'm generally on board with your answer, but help me understand why it has to be two or more features of the world. Give me a little more information on that. What do you mean by that? Joseph says, promise it wasn't ChatGPT. Took a while to phrase it. Well, it was very well phrased, Joseph, so I appreciate that you took the time to do that. Good job, my friend. Qualitative has a spectrum. Okay. All right, these are all great answers, guys. Great answers. Some really quality answers here in the chat. So my intent is not to signal out any one person because I don't want anybody to feel bad about their answer. But you guys are definitely on the right track. So quantitative is definitely, I think most people got quantitative correctly, where it's some sort of a measurable output. Somebody mentioned house prices. Yeah, sure. That's definitely a quantitative output. There's tons of quantitative outputs. But basically, quantitative outputs is when you can put a numerical value on it. Qualitative output, somebody in the chat accurately described it as being like a classification problem. And that is 100% correct. You are typically saying, I can take in numerical inputs, but I want to give it a classification for some sort of a description. Or somebody else also said about how it helps you to put it into plain English words, and that is a very good way to put it, because classifications, those qualitative outputs, can be anything you want. You can name them whatever you want. You can have as many as you want, right? So that's what you want to take away from qualitative outputs, that it's basically different categories that you can have, and you can have 2 categories, 4 categories, whatever you want. It doesn't matter. Okay? And then for clustering, I want to find, somebody did it perfectly. Yeah, here we go. So Amit, I think you gave a great answer on this. Clustering is something where things can be grouped on the basis of some common quantitative, qualitative parameters. That's a great answer. That's a really good way of looking at clustering. Basically, you can say, I have these different items, and I'm going to group them by the different attributes that they have. Those are going to make my clusters based on the values of the attributes. And those attributes can be qualitative or quantitative. And I'm going to put them in these clusters. And then that way, and the reason you would want to do that is because then that becomes your model, right? For future predictions, you can say, when something has these attributes, go ahead and put it in this cluster, right? To get a little fancier with it, you can also figure out the clusters on a plane, and then you can figure out how related clusters are to each other, or how different items are related to that individual cluster, right? So that's why you would want to do that. So I think you guys did great in that. So a couple of things that I do want to point out, though, is that you shouldn't be thinking about them as supervised or unsupervised at this stage just yet, especially when it comes to clustering, because there are clustering approaches where it doesn't have to be supervised data. You can use clustering for unsupervised data. If you don't know what supervised and unsupervised is, don't worry. We're going to cover it very shortly. But remember, guys, this is just page 1, chapter 1, right? So it's too early to start kind of thinking ahead in terms of, it has to be supervised, it has to be unsupervised, it has to be this type of model, it has to be this type of data, it has to be a regression problem. Let's just accept this for what it is, right? We just have to understand what the different outputs are that are possible from models, right? And also, I think the authors lay this out because it's very difficult to come up with other problems or some business problem that you're going to face that don't fit one of these 3 items, right? There's usually some way that you can tie back all your future work, all your future models to one of these 3, okay? All right, Patrick is giving a shout out to Joseph for his description. So yeah, I love the fact that you guys are encouraging and helping each other in the chat. Keep that going, guys. All right, so let's go on to the next slide. Another thing that I really liked in chapter 1 is that the authors lay out these 4 premises. Or premises is my word. I don't think they call it that. But they kind of lay out these 4 different thoughts for you to work with. The first one is that the approaches in the book are the most widely applicable across industries, and I completely agree. So somebody earlier, when we were doing our intros, asked about that, can you relate it to the work environment, to industries? Well, the authors are already telling you, hey, this is what you need in most industries. We have intentionally picked these models because we think that these are the most applicable for you when you are in the real world. So that's why I didn't answer that question directly previously, because I knew I was coming to this. And the authors are basically telling you, hey, we chose these on purpose. We've seen these in industry and we think these are the most applicable. So keep that in mind as you go through the book. And just, kind of, you're in good hands in terms of saying, hey, these are the ones that you should be studying because you're going to be able to find applicability in the future. All right? Second item that they also emphasize is that no single approach is going to work in every single model, every single problem you come across. You're going to have trade-offs where one model would be good and maybe not so good. And the words you see in brackets there, and experiments conducted, is my addition. Because the authors don't really say that, but this is what they're implying here. Where you should never say, well, let me take that back. There's that old saying that when you have a hammer, everything looks like a nail, right? So you're going to be tempted to say, oh, I learned regression models today, so the next problem you come across, you're going to try to apply regression to it, right? But that's not the right approach. That's not a scientific approach, because the scientific approach is to conduct experiments and to try different models, right? You have these in the real world, you're going to have these champion model searches where you have a problem and then you try different approaches. Let me try a regression against it. Let me try gradient boosting against it. Let me try a neural network against it, right? So that's what the authors are trying to get across here, that you shouldn't get married or feel like only one model is going to work. You should be approaching it with an open mind and trying different models and conducting those experiments. And again, experiments is my addition. They don't say that, but that's really what they're describing. I mean, that's what we do. That's what I do with my teams. When I lead teams, we conduct experiments. That's the science part of data science, right? So that's the second part that I think we should pull away from chapter 1. The third thing, I'm going to read this verbatim. I don't like reading slides, but I think this one is worth reading. We assume that the reader is comfortable with basic mathematical concepts, but we do not assume a graduate degree in mathematical sciences. And they go on to explain a little bit in that section, in that paragraph. And this comes back to the previous discussion we had. Somebody asked about the math, and they were intimidated by the math. The authors themselves are telling you that you do not need a lot of math. And I agree with this. I have seen this in industry. I have led many teams throughout the years. I've hired dozens of data scientists and run hundreds, if not thousands of team meetings. And we've never once sat there and discussed math formulas back and forth. That's just not how data science is done in the real world. I'm going to show you a couple formulas to get you, off the ground, kind of understand the inner workings. But you don't need, this deep understanding of math, okay? And again, it's not just me saying it; it's the authors. The authors are saying this. I copied this directly from the book, and I did that because I know that a lot of you have approached me in the past about the math, and oh, maybe I'm not so good at it, or maybe I shouldn't take this course because of. Don't be intimidated, okay? You're going to be just fine. You need to have an understanding, but it's nowhere near as deep as some of these other books or other things you see on social media or whatever emphasize. To be frankly honest with you, when I see the videos or the postings where people overemphasize the math, that person has told me that they have zero real world experience. They're basically faking it. They have never had a data science job in their lives, because that's just not how it's done when you're out there in the real world. Okay? And then the last thing that the authors give in these 4 premises is that the book focuses on real world problems. And they give you a lot of real world data sets to work from. I'm not sure if we're going to be using the same data sets that they emphasize, but they do say that, hey, we've tried to make this as realistic as possible, and they've done a pretty good job of it. So, take those 4 premises as you'd like, but I think they're really important. That's why I pulled them out to highlight here, because I got a lot out of these premises, and I agree with them. I like their approach. So that's I think those are important for you to read. So make sure you catch those in your edition of the book. Okay, you guys with me? I think we're making good progress here. So give me some feedback in the chat. Let me know that you guys are doing well. But I'm going to move on to chapter 2 while I'm waiting for that feedback. And you know what? Here's another opportunity for you guys to participate. So chapter 2, they start off. Well, I don't think they start off. This is just what I pulled out. They start off. They wrote about predictions and inferences. Okay, so there are two things in data science also. And really, some of these are kind of like statistics oriented. Predictions and inferences. Who wants to kind of give a challenge or take a shot at giving me definitions for each of these? You guys did great earlier, right? So feel free to do it again. You know, really short descriptions, and I'll even give you guys a hint, because in my interviews, I give a question. One of my interview questions is, what is inferential statistics? And can you give me an example of inferential statistics? That is one of the questions I ask in my interviews. So I think this is really important. That's really why I pulled this out. So great. AG Man says, let's keep moving forward. Wonderful. Thank you for that feedback. All right, guys. So I'll give you guys a minute here to feel free to, add your feedback. But tell me, what is a prediction, or what are predictions and what are inferences? In some cases, some people might say that they're the same. Are they? I don't know. But I'll give you guys a minute here. Tell me, what are predictions and what are inferences? So give you guys a little bit to think about it. So Kartik says prediction is based on one variable or more. We try to predict another variable. Okay, Kartik. So now give me inferences. I'm gonna take a little sip of water here. I came prepared, guys. Last time we were here for 2 hours. We might do the same. We might do longer. But I'm prepared. I got my water. I had a big breakfast. I'm prepared to be here as long as this takes. All right, so Kartik has volunteered his answer. Nobody else wants to participate? Melly Dare says prediction is to give the result without being sure about it. Okay. But Melly, isn't all of data science like that? Data science is really a kind of making educated guesses, right? Remember, guys, and we've talked about this before, data science does not give you the answer. It gives you the most probable answer, right? Never forget that. I want you guys to burn that into your brains. Very important to remember that. So, Melly, I'm on board with your answer. I think you're on the right track. But we're always unsure about our results in data science, right? So let me know if you want to expand on your answer, okay? Okay, Patrick says inferential statistics refers to calculating statistics from the data, like mean, standard. Predictions are new data points that are statistically consistent with our data. Okay. So Melly adds, inferences is to give the results based on what we see. All right. I can be a little bit on board with that, Melly. Feel free to expand on that if you want. 8G-Man says inference is what you conclude from your analysis. A prediction is what you expect to happen in a foreign data set based on inferences you made from other data sets. All right, AG-Man. I think you've provided the best answer so far. I'm on board with that answer. Prediction is making a guess based on unseen data. Okay. I would refer inferential statistics to measurements of correlation or causation between two or more variables. Oh, no name. Good answer. We're going to come back to your answer, my friend. I like the answer. Sravan says predictions talk about future and inference may be talking about why. Ooh, Sravan, I like it. I like it a lot. Wow, Isa, you guys are doing great. You're refining the answer with every message, because Isa writes, inference is based on the relationship of the variables. Love it. Great answer, Isa. Okay, guys. So, as a group, as collective answers, I think we've gotten there, right? I love different elements of these different answers, right? Okay, so Kartik, we're going to go back to his answer. Prediction is based on one variable or more, and we try to predict another variable. Yeah, that's exactly it, right? We're taking what we know, and we're trying to make predictions on the future, on what can happen on unseen data, right? Somebody else wrote about unseen data. So that's a pretty good example of predictions, right? In other words, you could also say, if X happens, what is gonna be the result of result Y, right? We know that X happened. What is result Y? You're making that prediction, right? And then inferences, No Name, Sravan, and Isa, I think collectively provided a great answer. And Isa basically sums it up, where inference is about the relationship between X and Y. In other words, what is the impact or the I guess that's the best word for it. The impact. If we know that X has changed, what is the impact on Y? Right? Just because X changed by a value of 1 doesn't mean that Y will change with a value of 1. There could be like an exponential relationship there, right? Where X changes by 1, but Y changes by 2. So that's where the difference lies. Where prediction says X happened, what is Y going to be? Inference is X is this, but now it changed. X increased by 1 or decreased or whatever you want to do. What's going to be the effect on Y? So that's what you kind of want to do when you want to think about these, where what's going to happen in the future, and then what's going to happen because something else already happened. I also want to highlight 8G-Man's answer, because that was a really good answer about what you expect to happen based on the inferences you made from the other data set, because inferences can also be used for predictions, right? So I think you guys are doing great in those answers, but I want you to keep that in mind, that there can be two types of conclusions that you're coming to, okay? Let me look at some of the other chats. Yeah, Muhammad, that's a pretty good answer. Predictions are the results of new incidents based on past experiences, yeah. Inference is providing evidence to your hypothesis on the basis of parameters. Yeah, I mean, that's a good one. Joseph, yep, I'm on board with your answer. Seed, none. Did you just describe classification versus regression? No, I did not. So seed, none, like I mentioned earlier, right? We're still in chapter 2. Okay, this is I think page 10 of the entire book. So don't jump too far ahead on me. Don't think about models. Don't think about business problems or anything else. Just take in the data, right? Because all we're doing is establishing the foundation for what's possible within statistical learning, within data science, right? That's all we're doing right now. So I love that you're participating, but let's try, all of us, to not get ahead of ourselves. Because it's easy to kind of get drawn in by the modeling and everything else. We're just talking here. We're just talking. Establishing a foundation, right? So inference is correlation of two variables. It can be, yeah. You can use inference for a correlation, sure, because it will tell you a little bit about that relationship between the two. It will also tell you if there's a relationship at all, right? The inferences don't have to exist. Sometimes they do, sometimes they don't. But yeah, Kartik, that's if you want to think about it in those terms, yeah, I'm on board with that. All right, let's go on to the next section. So this is one of the charts that the authors put together, and it's a chart where they ask you to think about interpretability versus flexibility, and they're giving you an idea of some of the different models that you could be using along the way, and as far as how they grade on these two scales. Sometimes these will be important, other times they won't. Interpretability is a big topic when you get to the business world. Some models require a very high some problems that you have that you're going to come across in the business world require a lot of interpretability, others don't. So that's going to affect your model selection. So as an example for that, the example I always give to my teams is that if you're working for like a bank, like let's say you're working for like a credit card company, and you use a model to help you determine whether you give somebody a credit card or not, right? Like a credit scoring model. In the U.S., it's illegal for you to deny somebody without giving them an explanation of why. You can't deny somebody and not tell them why. Maybe that applies in your country, maybe it doesn't. But that's a place where you need a model with high interpretability. You can't just say no. You have to say no, and this is why. So now your selection of models has decreased a little bit, right? Because now you have to you are required to use a model that has interpretability. Are all problems like that? No. Some problems you don't care why. You just want the better answer, right? So you keep this in mind. That's why this chart jumped out at me, because that's one of those real world things where you're only on chapter 2, so you're thinking to yourself, well, why do I need to know about interpretability, right? Well, that's why, because in the real world, that's going to be a big topic, whether something needs to be interpretable or not. All right, guys. So next chart. There, again, we're talking basics here. Supervised learning and unsupervised learning. Somebody brought this up earlier. But yeah, so now is the time to think about this. Give me some definitions for supervised learning and unsupervised learning. And again, this is a question that I ask in interviews. In fact, it's usually my first question. I love kicking off interviews with this question. My question is, what is unsupervised learning and what is supervised learning? And give me a real world example of each. So you guys are welcome to answer either one of these, or give me an answer to the interview question. But you're going to come across this in interviews, guaranteed, right? So go ahead, chat. I'll give you guys a minute here. Let me know, what is supervised learning and what is unsupervised learning? Give you guys a second here. I'm going to take a short little camera break so I can adjust a couple things on my end. All right. Okay, so Kartik, I love your speed. You're always fast with the answers. Love it. Supervised learning is when you have a label, and unsupervised learning when you don't have a label in your data. Okay. Any other answers? And Kartik, if you want to go for the interview question, let me know. Give me a real world example of each one of those. Melly Durr says supervised is having the answer and the questions, and we want to teach the robot how to find the answers. Yeah. I like it, Melly. Anybody else? Supervised learning. Isa says supervised learning, the model knows where the output will be, while unsupervised has none. Okay, I'm on board with that. Supervised learning requires labeled data, while unsupervised doesn't. An example of supervised learning will be having data on which every sample has an etiquette attached. Unsupervised will miss the etiquette. Okay, Seednut, I'm on board with that answer. She says we have the input as well as the true output while training the data for supervised learning. I like it. Supervised learning is training model based on labeled data, which is telling the machine to learn the problem with answers. Yeah, I'm on board with that, Llama. Supervised learning is when we wish to predict y from x and you know what y is. Unsupervised learning is when we wish to model underlying structure of x. Patrick, I'm on board with that. Thank you. Unsupervised, I think Sravan is providing an example here. Find patterns segmenting customers on purchasing behavior. Yeah, perfect example. I would definitely accept that example in an interview. So good example there, Sravan. Dragomir says supervised means that we already give the answers to the model and it learns based on those. Yep. Supervised is we have just the questions and the robot has to find the results by itself. Yep. I like that, Melly. She says supervised learning example, predict height for a given age. Yep. Yep. In fact, I think that's in their book or in somebody else's book. Explore the Beauty says supervised learning is concerned with training a model with label data and using it to make predictions based on unseen data. Yeah. Okay, good. Lots of really good answer here. Yeah, Muhammad, I'm on board with that answer. Joseph, also on board. Okay, so you guys seem to have a pretty good view on supervised versus unsupervised. Siddiqui Diaby, welcome to the chat. I don't think I've seen you before, but welcome. Supervised learning is when there is pattern in the data and the machine learns from that. Okay. Joseph says unsupervised learning is like exploring a new city without a map. The model looks for patterns or groups in data on its own without knowing the right answer before. Yeah, that's a good answer. All right, so you guys are coming up with some great answers for unsupervised and supervised, so thank you so much for that. So let me ask you this as a follow-up. Can unsupervised learning become supervised learning? Can do these kind of cross over? Can you have unsupervised learning that becomes supervised learning? Because you guys have a pretty good idea of what each one is. I think everybody basically gave a good answer. But what about crossing over? What do you guys think about that? Let me know. Give you a couple seconds to think about that. Can unsupervised learning become supervised learning? And if so, how? Or if not, why? Okay, Seed Nun says yes. Okay. How? Okay, yeah, perfect. So Servan hit it exactly on the head. Yes, because we can label data. And that's exactly right. That's exactly the answer. You can turn an unsupervised problem into a supervised problem. You could take the time to label your unsupervised data. And I bring that up because that is dealing more with your stakeholders, right? How you manage your stakeholders. Stakeholders are going to be critical for you to be working with because ultimately they're the ones that you're serving with your algorithms. Like you're trying to solve their problems, right? So sometimes you won't be able to find a valid unsupervised approach to a problem, and you're going to need supervised data. You're going to need labeled data. So these are the interactions and quite frankly, the negotiations that you're going to have with your stakeholders in the future to say, hey, we're a data science team, but we don't know your data. You guys know your data. So can you label 5,000 records for us to help us in this effort? And that's like a whole other process, right? Stakeholder management is like a whole other thing you have to master as a data scientist. And I have some resources that I'm going to be releasing to help you guys with that. But that's why I asked that question, because you should know that you can get to labeled data, but it's not always easy. It's not always a straightforward path, okay? So that's why I wanted to bring that up so you guys can kind of, keep that in the back of your mind. But you can turn unsupervised data to an unsupervised problem into a supervised problem, but it's usually going to require the help from the business. All right? Okay, guys. So I love the feedback. You guys are giving me some really good stuff. So let's keep going. Love the progress we're making, guys. Okay. Scalar outputs and categorical outputs. What are these? Hint, hint. We talked about these earlier. What do you guys think? Scalar outputs and categorical outputs. What are they? And on the previous question, Kartik says, not perfectly because there will be wrong label and data during unsupervised. Absolutely, you're correct. But again, that comes back to the whole, the item that I said earlier. It's going to require a negotiation on your stakeholders. Because labeling data is not fun. It's not fun for you, it's not fun for them, right? So you're going to have this back and forth with the stakeholder manager. And you're right, Kartik, there could be errors, right? The labeling has to be quality labeling still, right? And there's ways to do that, right? I recommend you have to have a minimum of 3 people. The 3 people work independent from each other, and on the back end, you're doing like a polling on the answers, so on and so forth. But talking a stakeholder into doing that is like a whole other discussion, right? But Kartik, I just wanted to highlight your message because you're on the right track. Just because it's labeled doesn't mean it's right. So I love that thought there. So thank you so much for that. Okay. Yeah. So I'm seeing Patrick and Joseph. They're hitting it right on the head. And this is exactly why I picked this particular portion out of the book, guys, because I think that the authors here could have done just a little bit of a better job tying those back. But I'm presenting it here just to show you guys to not be intimidated, because you're learning all these terms, but the terms they're correlated, right? They're correlated in a funny way. So yeah, both Patrick and Joseph have great answers up on the screen in the chat. Scalar is your qualitative outputs, right? Categorical is your quantitative. Wait, Nice. I'm sorry, I got that backwards. Sorry, I got that backward. Scalar is qualitative. Categorical is quantitative, right? That's it. So yeah, actually no, I think I had it right the first time. Yeah, quantitative is scalar, category is qualitative. Sorry, folks. I have a lot happening on my screens. I need to do like a behind the scenes so you guys can see what my screens are like. So I'm sorry that I'm a little loopy. But yes, you guys are coming up with the right answer. But again, the whole purpose here is just to show you guys that, don't get intimidated. There's a lot of new stuff coming at you, a lot of new terms, but a lot of the stuff is correlated. So when you hear about scalar and categorical, just think the qualitative and quantitative. In essence, we've already covered this, right? So that's why I pulled this out, because just kind of, take it easy, right? Don't be hard on yourself. Don't beat yourself up. It's a new topic, but they're all correlated, all right? So I hope that makes sense on why I wanted to bring that out. Okay, so now, I think this is the end of chapter 2, yeah. So to close out chapter 2, the authors get a little bit closer to inching forward to modeling, right? Because this is really, because remember, everything we've talked about before is just setting the stage, right? And in chapter 2, they close it out by talking about like your model accuracy. And again, I'm copying directly from the book because I think this is an important quote. No one method dominates all others over all possible data sets. So this is where I want you to start thinking about the experimentation mindset that you need to have as a data scientist. Because you should be trying different models on any problem that you come across. You might look at a problem and say, okay, that's supervised, or that's a supervised problem, that's an unsupervised problem. But that's really as far as you want to go in terms of your assessment. After that, you should be saying, well, I'm open to whatever model can solve this, so I'm going to try 5 models, 7 models, 10 models, whatever the case may be. But keep in mind, again, this is from the authors, no one method dominates all others over all possible data sets. Very important. You should be carrying that forward through everything you do in your entire career. All right. And by the way, guys, if you see me looking up here, it's because I have my classroom monitor up above. I bought this whole monitor stand and everything, so I've got multiple monitors here. But that's where I'm looking if you see me looking up over here. And then they also include their first measurement for model accuracy, and that's the mean square error, or the MSE. It's commonly used for regression problems, and it's measuring the difference between predicted and actual responses. What does your training data say that the responses should be versus what does your model say the answer should be? What is the mean difference between those, or between the errors that those two models make, right? So this is kind of how, again, they close the chapter 2 with these, because they're inching closer and closer to saying, hey, let's get into our first modeling. So I kind of want to, just kind of set the stage there, because I think it's a really nice segue, because now we're going to be talking about linear regression, okay? All right, so you guys with me? Anything on this last screen? Because our next screen, we're going to be talking about modeling. So everybody good here? I think we should be good. But give me some feedback. Are you guys doing well? We've been going for over an hour, guys, so thank you so much for sticking in there with me. I see a couple names that have been with me since the very start of this stream, so thanks so much, guys. All right, any other questions before we leave chapters 1 and 2? This is a great time for it, guys. All right, Patrick says going strong. Good, glad to hear it, Patrick. Melly says yes, loving it. Okay, so Isa, you're asking a good question. I'm going to come back to this, okay? If I forget it, let me know, but I'm going to come back to this. You're asking an important question. All right, good. So I'm getting good feedback from you guys. All right, guys. So let's keep going. Give me just a second here to switch out one of my screens. All right, so chapter 3. So chapter 3 is our first modeling effort, and they start off with linear regression. And I think that's great. I think linear regression is a very good model to learn the basics of data science. So we're going to go through the chapter notes. I'm going to give you a framework that you would use going forward. We're going to do some labs, and then I'm going to recommend some self-study that you guys can pick up, okay? So, all right, guys, this is our first bit of math. Nobody panic. It's just some math. All right, so in the chat, what formula am I showing here? Now, you can think about it in a math perspective or just like a general perspective. It's not necessarily a data science question, but what is the formula that I'm showing here? Give you guys a minute here to think about it. What's the formula? What's the name for this? All right, cool. Patrick, Muhammad, I'm already seeing great answers. Joseph, yep. You guys got it. It's a line, right? It's a formula for a line. That's all it is. That's all regression is, right? And Muhammad, yeah, it's rise versus run, as Muhammad talks about the slope, right? It's rise times run. That's all we're doing. And really, that's kind of like what I want you guys to just take away, that you shouldn't be thinking about this as complex approaches. It's just lines, right? Angel Torero, welcome to the chat. I don't think I've seen you before, so welcome. But yeah, it's just a slope. It's a slope, as Ashish points out, with no intercept. So I just want you guys, everybody, just to calm down. All we're doing is just filling out this formula as our first data science effort, right? Y equals m times x. That's it. I think it was Patrick that mentioned mentioned the origin, right? Which this does go through the origin. Not everyone will, so we'll introduce that in the next slide. But yeah, but all we're doing is doing a line, right? So I want to make sure everybody kind of just relaxes. It's not complex math here, guys. Fernanda Vallejos. Fernanda, welcome. I don't think I've seen you in the chat. Thank you for joining us. Equation of a line, I think, is a translation. I think that's Portuguese. But yeah, that's exactly right. Okay. Amit talks about a Python, I guess a repository. Amit, I'm not a big fan of GitHub. If I release this stuff, I might release it on Discord. And I'll just put the files up there. But as far as GitHub goes, remember, we're not writing code, right? We're writing prompts. So I'd much rather just post the prompt file than anything else, right? So maybe you missed that part, but yeah, maybe some people join late, and that's okay. We're not going to be doing blank code screens here, guys. Okay? We're going to be utilizing Gen AI in a very heavy way to help us write our code, because that's really my own twist of what I'm adding to this process. This isn't ISLR, ISLP. This is ISL AI, because we're going to be using AI to help us with that, okay? But really glad to see all the people that are joining us. You know, I'm seeing a lot of new names, so thank you so much for joining us. Thank you. You know, even if you're joining late, thank you so much for that. I mean, we're almost going for an hour and a half here, so you know, like I said earlier, maybe you need to step away. That's okay. Come on back. We might still be going. We might still be going 2 hours from now. Who knows, right? But thank you so much for joining us, guys. All right, next slide. This is an illustration of what we're doing, right? This is all we're doing, guys. And again, I'm putting these out there so that you guys can understand that it's not really intimidating. You know, data science really can be this simple. So what do we have here? We have our two axes. This is straight from the book, guys, right? Section 3. They usually label the charts. They don't have it, but this is like, I pull this on page 62. So we have our line, right? Y equals mx. As Patrick pointed out, in the previous example, that was going through the origin. This one is not going through the origin. So this point here is known as the intercept, right? Where is it intercepting the y-axis? When we're looking at a chart like this, we have our independent and dependent variables. Our independent variable is going to always be the x-axis. Our dependent variable is always going to be the y-axis. In this scenario, it's TV. The TV spend on advertising happens to be the independent variable, and the dependent variable is the sales, right? So in other words, if I have this level of TV spending, what are the sales that I can expect based on that use of the independent variable? So this is known as a scatter plot. So this scatter plot with all the little red dots tells us what they've done in the past. The line is the proposed model to say this model captures these lines or these data points the best. And the lines in between the 2 points, these black lines, that's essentially the error that has happened, right? Or some people would refer to it as the variance between what you would expect versus what actually happened. So coming back to the earlier question about RSC, RSC tells you what happened in terms of errors of your actual model or your training data. Whereas MSC, the mean square error, is more about what happened between your predicted values and your actual values. So that's why MSC and RSC are very closely related. But it's where you're pulling those errors from, those variances from, that differs in the two models. So I'm getting a little bit ahead of myself, but I just want you to kind of think about this chart where this is all we're doing. We have our independent variable, what we can modify. We can modify our TV spend, right? And then we know that it's going to have an effect on sales. And then this blue line tells us what we can expect. At a spend of 250, we can expect this level of sales, because that's what the model tells us, right? And when I say model, that's what the line formula tells us. That's what I'm really saying, right? So keep this all in mind as we move forward. But it's not really complex, guys. It's just little components that we're putting together, okay? So Mosin, thanks for joining us. I don't think I saw you in the chat earlier, so thank you for joining us. So M is scalar. Sure, it can be. Yeah. And we're going to get into that right on the next screen. But yeah, M is usually scalar, and I'm going to show you why. Okay. So the authors put together these questions for linear regression, right? And in these 6 bullet points, I'm like paraphrasing what they wrote. It's pretty close to what they wrote. You're going to find a pretty good relationship. But it's kind of like my interpretation of their questions. And I think it's a good set of questions to ask, definitely for linear regression, but really for a lot of models that you're going to have out there, right? So is there a relationship at all between X and Y should be your first question. The next question is, how strong is that relationship? After that is, how much is the effect of X? How do you find what X is to begin with? Right? How do you know that TV spend has that effect on sales? Are there other factors besides X, like a Z factor, right? Because there could be more than one factor, right? And then is there an interaction effect between X and Z that impact Y, right? Because when you start talking about additional factors that you're taking into your model, well, now those factors have an interaction factor with each other that you have to take into account, right? But these are 6 really good questions that I think the authors are proposing. And I take that one step further, and I basically kind of give you some notes here, because this is why I think it kind of relates to each other, or how it relates to data science, or why I say that you should be taking these 6 items and carrying them forward. Is there a relationship between X and Y? Well, that relates to model selection, right? Because if there is a relationship X and Y, you're probably talking that it could be like a supervised problem. So now you can really only look at supervised models, right? How strong is that relationship? Well, you're really talking about errors there, right? The stronger the relationship, the lower the errors. So that's really what you're talking about there. How much is the effect of X? Is the weighting, right? Because how much do you want to weigh that value of X? How much of a weight do you want to attribute to that TV spend? Maybe it's high, maybe it's low, who knows? When you're talking about how do you find what X is to begin with, or how do you find if there's other factors like Z, well, that's your feature search, right? When you're talking about, feature searches or feature engineering or data transforms, all that stuff, that's what you're talking about, right? What other things could be affecting my model? And then lastly, is there an interaction between X and Z? Well, that's model experimentation, right? Now you're going to say, okay, well, let me try these multiple models. Let me try different hyperparameters. I'm going to do some tuning on those hyperparameters. I'm going to do a grid search. I'm going to do some transforms. I'm going to, bring in other data, right? Like data, some data wrangling. Like this is all how it ties together, right? So that's why I'm providing, the bold is obviously my notes on it, right? But again, I just want you guys to kind of take a step back and realize that everything in data science is correlated, right? Because I'm assuming you've seen some of these other items, right? Where you have articles or other tutorials or whatever that have come across about model selection or your errors or this or feature engineering or whatever, right? This is all the same thing. There are other terms, other ways for you to think about it, okay? Shravan says, when discussing model selection, are we referring to supervised or unsupervised learning? Shravan, that's a great question. I would say this is the second question. The first question is being able to recognize whether you're looking at a supervised problem or an unsupervised problem. And that's it. Just make a distinction between the two, nothing else. And like I said earlier, that's where your decision should stop. Because you might be able to say, oh, yeah, that looks like a linear regression problem. But that can turn into a form of bias because guess what? Now you're only trying linear regression models. There could be other models that work better, right? So so model selection, to address your question exactly, model selection would be step 2. And model selection is a process of experimentation, not of your own bias of, oh, well, yeah, this looks like it's regression, so let me only try regression, right? That's super dangerous, right? That's like a researcher bias. So love the question, Sravan, but it's step 2. Step 1 is recognizing what kind of problem you have. And step 2 is, okay, now I'm going to experiment and try to find that model. Okay? Great question. Love the question. All right, guys, so let me go on to the next slide here because I think the next slide is a good one here. So we're going to refine our previous formula. And this is the reason, and by the way, you'll note that I'm doing this slightly different than the authors, because the authors use like a beta value and things like that, which obviously is not incorrect. But y equals mx plus b is how they will teach it to you if you take a dedicated regression methods course. And if you're in a study program, you're probably going to have a dedicated regression methods course. But y equals mx plus b is a very common way to express a linear regression formula. So, as I said earlier, y is your dependent variable. What's going to change, right? Or what is dependent on that model. X is your independent variable, the thing that you can modify, that you have control over to change. M is what's referred to as your coefficient. And B is what your intercept is, right? Because not all lines pass through the origin, so you are likely to have an intercept value when x is 0. So that's what B represents. Okay? So y equals mx plus b should be something that you burn into your brain, because a lot of what you do, especially early on in your data science studies and in your career, all can be traced back to y equals mx plus b. Another reason why I bring this up is because every once in a while you kind of catch this in a chat or some sort of discussion online where somebody like me, like one of the older guys, will come back to you and say, well, everything in data science comes back to linear regression. Everything can be explained with linear regression. That's what they'll say in the chat, and then everybody else jumps on, you don't know what you're talking about, old man, or okay, boomer, and all that other stuff, right? But they are correct. Everything does come back to linear regression. And the reason I say that is because it all essentially comes back to this formula. What are you trying to guess? Or what are you trying to predict? What are you using to predict? And what is the value, what is the weight that you want to assign to that variable? I guarantee you that everything you do in the future is going to be related to what I just said. What are you predicting? What is the factor that you're considering? And how much weight do you want to add to that factor? That is data science in its most simple terms. I mean, think about, we're getting way ahead of ourselves, right? But just to kind of prove this point, think about a neural network, right? What is a neural network? A neural network is a collection of nodes that sit there and do a formula, and they either activate or they don't, right? They sit there they take in some inputs with an activation function, and they fire or they don't, right? They activate or they don't. Same thing, right? They're taking in the items. The activation function says, okay, these are the factors, these are the weights. I'm going to decide yes, no to activate or not. But again, it all comes back to what are the factors you're giving me? How much weight am I assigning to those factors? And I'm either doing something or I'm not. So again, I want you to kind of burn this into your brain. Y equals mx plus b, super important for you to learn. Okay? Next slide. I also just kind of make sure I emphasize this to you that I use y equals mx plus b, but I want you to recognize that you could have multiple factors. It's not always a one-to-one relationship with the factors. You can have multiple factors that influence the value of y, that influence your dependent variable. You can have multiple independent variables. Sometimes it's one, sometimes it's more than one. It just depends. Okay? To highlight again what we looked at, kind of just bring it all together, right? Sales is what we're trying to predict. We know that our TV spend is a big part of that. We know that M is some sort of weight, some sort of value we want to associate with that. But just to keep ourselves honest, it's called the coefficient. And then B is the intercept that you want to assign to that value. Okay? And then here, I'm just explaining it in a different ways, right? Sales is dependent, TB is independent, M is the coefficient or the weight, and then B is the intercept. But it's the same graph that we started off this whole discussion with. So not a lot of complex math, it's just a good model. And again, what are you trying to predict? What is the feature you're going to use to predict it? And how much weight do you want to add to that feature? Every data science problem you'll do in the future is exactly like that. All right, any questions before I go on to the next one? We're getting close to doing coding, so let me know if there's any questions. I'll give you guys a little minute here. You guys with me? Thanks for the assist in the chat there, Patrick. All right, give you guys another minute here if you have any questions. But we're getting close to using our coding here, guys. All right, good. Everybody's doing well. All right, so let's keep moving forward. This is from section, you can see here, 3.12 in the book. And I wanted to make sure I include this so that when you go and study later, you can tie this back to what you're seeing in the book. Because in the book, they talk about this in terms of the hypothesis, well, the null hypothesis and the alternative hypothesis. So here, look at this line here. There is no relation between X and Y. That sounds suspiciously like one of the 6 questions we asked, right? Because it's possible there's no relationship. There's no model to be had. Right? So that's the first, that makes up your null hypothesis. And then your alternative hypothesis is that there is a relationship between X and Y. And now you're trying to find essentially the strength of that relationship, the weighting of that relationship, right? So I just wanted to kind of bring this to your attention, 3.12, 3.13, because everything we've talked about, this is how it ties back to the book. All right? All right. So for the other question of how strong is that relationship, we're looking at your errors. And here we're looking at your residual standard error, which is again, pulling straight from the book here, average amount that the response will deviate from the true regression line. And the unit of measurement is the dependent variable. So in this case, the unit of measurement, staying with our example, is the amount of sales, right? That your model could be off by a certain dollar value of sales. And remember that here with RSE, we're talking about what it deviates from the true regression line. So in other words, you can almost think about like what is the deviation within your training data. Another item to look at is the R-squared value. And this, again, pulling straight from the book, measures a proportion of variability in Y that can be explained using X. Or you can also say it's the proportionate representation to show the fit between training data and prediction data. I believe this second bullet point is my own explanation. I don't think that's from the authors. But that's how I explain it. That it tells you how many of your, what is the proportion of your predicted values that can be explained by your training values. Right? That's a really important proportion to understand. So let's do some more participation here, guys. Okay? Residual standard error, and also the other one we talked about, the mean squared error, shows the differences essentially between your predicted values and your actual values, your model values. Right? So what makes up a quote-unquote good RSE value? Do you want that value to be high or do you want that value to be low? Same question for the R squared. It measures a proportionate amount of explanation between your training and your prediction data, right? So what is a quote unquote good R squared value? Is it high or is it low? And is there anything special about the R squared value? So I'll give you guys a second to think about that. What do you guys think? All right, so Patrick has already volunteered an answer. RSE should be low, R squared should be high. Okay, chat, what do you think? Do you agree with Patrick? Okay, Joseph basically gives the same answer. Low for RSE, R squared should be high, okay. Okay, so Patrick says R squared should be close to 1. So Patrick, you're hitting on that second part that I asked about, right? So guys, anytime you hear proportionate, you should always be thinking about values between 0 and 1. Right? So that's the first thing that should jump out at you when you see this R squared definition. Proportionate is a value of 0 to 1. So Patrick has obviously already hit on that. And he's talking about how R squared should be close to 1. And that's exactly right. R squared should be high, and it should be as close to 1 as possible. So you got it right. You got it right there, Patrick. Yeah, so basically everybody is getting the right answer. Rahul, thank you. Welcome to the chat. I don't think I saw you earlier, so thank you. So yeah, I mean, all of you are hitting on the right answer. You want RSC to be low, and you want your R squared to be high. Because in those scenarios, RSC means you're making fewer errors, right? And R squared means that your training model is very close, your predicted value is very close to your training values. Which means that the coefficients in the model that you chose to create your predicted values are very close to what's reflected in your training data. Right? So that's exactly why you'd want those. So everybody basically hit on the right answer. So Patrick says, can R squared be greater than 1? No, it's proportionate. Right? So it can't be greater than 1. Okay? Yeah. So I think in the next section we're going to be going to code. Yeah. All right, guys. So there's plenty more ways to measure the effectiveness of your model. I'm just proposing these to get us started off the ground, because again, this class is not going to get you ready for a job, but it is going to give you the foundation to go and research more and find out other measures that you could be using for your model. Okay? But R squared and RSE and MSE are going to give us a really good start to be able to say, okay, yeah, let's go ahead and research more, do a little bit more study. Okay? Okay. So here's the framework that I want to do, or that I want you guys to follow, right? What is the dependent variable we are trying to solve for? That's the first question you should be asking in any model. What is it that you're trying to predict? Second, do you have a linear regression problem on your hands? Because not everything is correlated in a linear way, right? Not everything is a linear regression problem, so you have to figure that out. And then the third thing, which is kind of like the modeling effort, is what are the factors that you should consider, and what is the weight you assign to that factor? Remember what I told you earlier about how you should, this part in bold is what you should be, burning into your brain. Because everything you do in data science is essentially that. So that's the framework that you want to kind of maintain, okay? All right. I'm seeing some questions in the chat here. Isa says, was wondering if we will get access to the slides. Yeah, maybe. I might do that on Discord. I haven't really decided that. Yeah, we'll see. But it'll always be on YouTube, Isa. So you can always refer back to it on YouTube also. Joseph says, I don't think R2 can be greater than 1 as it represents a fraction. Not sure. Yeah, that's right, Joseph. It can't be higher than 1. You want it as close to 1 as possible, but it can't be higher than 1. It's a proportionate value. It's values between 0 and 1, and that's it. The authors present the formulas for R squared and RSS if you're curious, but if you look at the formulas, it'll show you why it's not possible to be greater than 1. Okay? All right, so we look at the framework. So looking here, this is how we're going to work. What is the result that we're optimizing for? In other words, what is the value that we want to optimize for? What does the code look like? And like I said, we're going to be at least level 2 data scientists using an LLM, right? Ideally, we're going to be acting more like architects. And then 3 is that we're going to be code editors, not code writers. So we're going to do virtually 0 code on our own, okay? And this is what we're going to do for the lab. We're going to do a professional level development environment. We're going to create our own data sets. We're going to use some synthetic data for this. And I'm using that more as kind of like a warm-up for using ChatGPT, right? You can certainly have your own data. But, just as a warm-up, we're going to create our own synthetic data sets. We're going to have code to solve for 1 independent variable, code for 2 independent variables, and then we're going to provide metrics for all the models. Okay? All right, so now we're getting ready to leave the slides. Do you guys have a preference on which version of Jupyter Notebooks to use? Drop it in the chat. That way we can set it up. But we're about to start doing some code, so drop the version of Jupyter Notebooks that you're recommending that we use for the problems, okay? I'll give you guys a minute to think about that. But let me know your preferred version of notebooks that we're going to use in the next section, because we're going to jump into code now, so let me know. Woo, we've been going for 2 hours, guys. Good job. I know a couple of you have been with me since the beginning, so thanks so much. Good job, guys. Okay, so Patrick is recommending Jupyter Notebooks within VS Code. What else, guys? Who else wants to give their preferred version of Jupyter Notebooks? Okay, so Isa says Jupyter Notebook comes with Anaconda. Okay, so whatever is the latest stable in Anaconda. Okay, anybody else? We're going to code next, guys. So we need a notebook. Let me know what you guys want to use. Anybody else want to give their favorite Jupyter Notebook? Okay, Melly also votes for the one that comes with Anaconda. Anybody else? Last call? Last call before we go into code. Patrick says Google Colab. Amit says, sorry, I have been in and out watching while traveling. Hey, no problem, Amit. Really appreciate you staying with us. And you can always view the replay later, or you can join us on the following Sunday. We're going to be doing this for the next 8 Sundays. Or 7 Sundays. Today's the first one of 8. All right, no more Jupyter Notebooks. She says anything is fine. Amrapali. So Amrapali, are you voting for VS Code and notebooks? Well, first of all, welcome, Amrapali. I don't think I saw you before, but let me know which notebook you're voting for. Another vote for Conda, another vote for Google Colab. All right. All right, it looks like those are going to be all the answers I get. All right, guys. If you gave me an answer for your favorite notebook to use, wrong. You don't use notebooks. It's a trick question. My first bullet point is we're going to establish a professional development environment. Professional development in the real world is not done in notebooks. I know. That's a controversial hot take. I get it. Professional development is not done in notebooks. I will die on this hill. When you get out into the real world, you want to use some sort of IDE using some sort of terminal or some sort of other executing function. But the real world does not rely on notebooks. There's the old saying, and the old saying is still true, you can't deploy a notebook. Okay? So we are not going to use Google Colab or Anaconda or anything else. We are going to be using VS Code and then executing that code via a terminal. That is how you do professional development in Python in the real world. When you get out there, you're going to be working, you're going to be working with a lot more complex code. You're going to be working in distributed environments, a lot of different things, right? Where notebooks just don't cut it anymore. You might still use them to kind of like, as a scratch pad and, just test some ideas on your own. But professional data science is being done in an IDE that's then executed within your own terminal, within some sort of other, Python environment. Okay? Isa says, as a uni student, learning how it works in the real world is definitely insightful. Well, that's exactly what I'm trying to provide here to you, Isa. Because again, I see so much stuff out there, so many approaches to data science that, that are being, taught on other influencer stuff or tutorials. And again, when I see that, they tell me that they've never been in the real world, because this is how we do it in the real world. Okay. All right. So let's get going. So first thing I want to bring up, we're going to leave our deck here for a little bit. So first thing is I have Visual Studio Code set up with a blank environment, and I have my files ready to go here. I don't have any files, right? I'm just starting from a blank directory, and then we are going to execute our code here in this terminal window, right? And I'm using Mac, so this is using OS 10. But OS 10 mimics a lot of the Linux flavors that you're going to come across in the real world. So you want to learn something like Mac OS or Linux or whatever, because this is what you're going to be up against when people don't work. We had a discussion earlier about cloud certifications, right? When you don't have a cloud environment, or you're working in a server environment, this is what you're given, right? They tell you, okay, here's a command line prompt, go work with it, right? So really important for you guys to kind of get used to working like this. Visual Studio Code for your code, and then executing some sort of terminal. In this scenario, I'm executing locally within my own Python environments, but you would find this exact same interface if I was using one of my servers. So I keep a couple servers on DigitalOcean to help me kind of like do my own projects and my own ideas and stuff like that. But the interface is the same, right? I'm pointing out that I'm running locally, but you would see the same thing if we were to run this on my DigitalOcean servers or something else, right? The point is, you got to feel comfortable in Linux. You got to feel comfortable not working in GUIs, right? We're not going to see very many GUIs right now. This is just the way it is. This is professional development environment, okay? All right. So again, we're thinking in terms of architects, right? We are not just data scientists level 1. We're thinking of architects. So the first thing we're doing is we're going to need a file. We're going to need a file to create our synthetic data sets, right? Because we said we're going to need data. So let's create a new file, and we're going to call this datagen.py. And again, we're not trying to start with a blank screen, right? This is a blank screen. I don't want to work from a blank screen. I want ChatGPT to work from a blank screen, right? So now we bring up our friend ChatGPT, right? And so this is a limitation you guys might run up against. OpenAI has recently limited the amount of queries you can make of their ChatGPT 4.0 model. So I do have a paid subscription to OpenAI. I think it's $20 a month. So I understand not everybody here might have that, but I'm doing this because presuming that you're working for a company in a professional environment, you'll probably also have some sort of subscription to a tool. So I understand that as we go through this, maybe you're going to run up against the limit. That's okay. What they do is they let you go down to, I think it's either 4.0 mini or they bring you down to 3.5. So you can still continue, and maybe the answers aren't going to be as great as they would be in the 4.0 model, but it's still good enough, right? Or you can use something else. I've also done similar exercises with Claude from Anthropic. Claude is also very good at generating code. In fact, I think sometimes it produces cleaner code than ChatGPT does. But they also have restrictions on how many you can make per every 4 hours or something like that. So I don't want you guys to get caught up in the tools, but I do admit that I'm going to be showing you some stuff that maybe you're going to run up. You're going to run up against the usage limit. So keep that in mind. Okay, so first I want to establish some context. So we're going to ask for a synthetic data set. And we're going to say, does this last part look familiar to anybody? This portion here? Isn't that y equals mx plus b, right? That's all we're doing, right? We're asking it for y equals mx plus b. And let's see what they come up with. Okay. Oh, let me get this out of the way. So now we're using our editing skills, and we're looking at what they provided here, right? So now we can modify this, and we want to make sure that it has a low RSC, right? So we need to refine our prompt here. Let's see if it creates that. Okay. What do you guys think? This code looks fairly reasonable to me. Oh, look, it even created it for us and has a download. It looks like they're using this noise variable to help minimize the low RSC, which is good because that means that we can play with that when we want a high RSC value, right? Because remember, we're going to want something that's a good fit model and also a bad fit model, right? So this would produce data that fits our model pretty well. What do you guys think? I think this code is reasonable to use. So I'm going to copy that code, and I'm going to bring it over to our data gen. Yeah, So I'm going to modify a couple things, right? Because for some reason it added a path, which I don't want. And just to make things easy, we'll call it low RSC and high RSC. And it also put in a range of X values, which I guess is okay, but I think 10 is too low. Let's go to like to 200. And the noise level is for a low RSC. So just to get an idea of what scale it's using, I want to see what high noise level should be. Okay, so they're using a noise level of 5.0. So now we know that if we use a 0.1, that should give us a low noise level, and a 5.0 should give us a high noise level. Everybody with me so far? What do you guys think? Does this code look reasonable to everybody? I think it looks fairly reasonable. So we can actually start to put this together in a way that fits our needs, right? And here we can say that we're going to modify this for a high RSC. Oh. So here we can go ahead and change this to 5.0. And this is high RSC. What do you guys think? Feel free to stop me or give me any feedback. But again, we know we're trying to do as little coding as possible. We're just doing editing right now. Let me know what you think in the chat. All right, this looks okay to me. We have a low RSC, we have a high RSC, we change the noise level. Melly is asking for a zoom in. Is that something that could help everybody? Is the code too small? Okay, it's tough to see the code. How about that? Is that better, guys? Let me know. I'm going to go one more zoom level in. Give me some feedback in the chat. Let me know if that's better. All right, Patrick says one more level. Okay. All right, is that good, guys? All right, so it looks like we're back to good here. Okay, so we're playing with the noise level. A low noise level gives us a good RSC. High noise level gives us a bad RSC. And then we're saving it to two local files, right? All right, so I think I'm good with this code. So we're gonna go here. Let me know if you need the terminal bigger too. Okay. So it looks like our code ran just fine. So if we go back to Visual Studio Code, we now see our two files. We have our low RSC and high RSC, right? So that's what our high looks like. And then that's what our low looks like. All right, good. So now we have data to work with, right? So now we're going to start with our modeling. So now we're going to do linear regression, one variable, or one factor, we should call it. Okay. Again, blank screen, but that's ChatGPT's problem, not our problem. Okay. So we're going to go back to our ChatGPT. And we're going to ask ChatGPT basically what code it knows, right? So it's telling you that it knows scikit-learn. And it's producing some relatively reasonable code. And it's plotting the results, which is okay if you're using a notebook, but not great for our code. And really, you know, again, guys, we're professional data scientists, right? We don't need plots, at least not all the time, right? So let's ask ChatGPT to modify the code. Let's use scikit-learn. MSC, RSC, coefficient, intercept, and R squared values. Let's pick up the R squared. Okay. What do you guys think? It even gave us a way to read the data set, which is wonderful, right? What do you guys think? This code look reasonable? Give me some feedback in the chat. What do you guys think? Actually, you know what? Let me bring it over to VS Code. That way it'll be a little bit bigger on everybody's screen. I just realized that. The part you can't see at the bottom is where it's just printing out the model items. What do you guys think? So Melly says, yes, it does for me. Okay, thank you, Melly. Appreciate that feedback. Anybody else? Patrick says it looks good to me. All right, you know, it looks good to me too. Let's try it. So again, we're just doing code editing, right? So now we are going to use our low RSC CSV file. All right, so let's think about this, right? We are data scientists, which means we're also critical thinkers, right? We're going to use our file low RSC as our input. What are we expecting down here, guys? right? I mean, this is us forming a hypothesis, a theory, right, to help us understand whether our code is running right. So let's take some guesses or some educated guesses on what these results should be. What do you guys think? What are we expecting? Let me know in the chat. Give you guys a little minute here. But what are you guys expecting to see from these print statements once we run this code? Okay, so Patrick says RSE should be 0.1 as we set the scale to. Well, we set the noise to that, not necessarily the scale though, Patrick. So I think you're on the right track, but not quite there, right? It's not gonna be exactly 0.1, right? But you're on the right track. She says we should expect 10 and 7. Yeah, that's definitely the right track, because if we go back to our initial code, or initial prompts, excuse me, that's what we requested, right? We did y equals mx m7, I think. Yeah, right. We said y equals 10x plus 7. So that's exactly right. If we're on the right track, and that's to say if ChatGPT wrote the right code, right? Then yes, we should expect that our coefficient is going to be 10, because that's the weight we're adding to x. And 7 is our intercept, right? That's our b, and b is the intercept. So you know what? To remind ourselves of that, let's go ahead and copy that and put that as part of our our comments, right? Because we said y equals 10x plus 7. That's the formula we used, right? That's the model we used. So yeah, Ashish, you're definitely on the right track. And yes, Ashish also says that those should be approximate values. Absolutely, right? They're not going to be exact, because remember, we're still modeling. There's still going to be a random element to it, right? But we know we're on the right track if we're hitting these numbers. What about R squared? Did anybody provide R squared? What should we expect for R squared? Anybody want to take a guess at that one? Melly Durr says, I don't know. Hey, that's okay, Melly. We're all here to learn, right? So it's totally okay if you don't know. You know, maybe after these classes, you'll pick up some of these things, and maybe you'll take some of this code, do some experimentation on your own, right? And that'll help you learn. So it's okay if you don't know all the answers. We're going to get you there. But yeah, so what do you guys think for R squared? Anybody have a guess on what R squared should be? Give you guys a couple more seconds in the chat. Yeah, that's right, Patrick. So R squared, it's not going to be exactly 1, but it's going to be closer to 1. Yep. Yeah, Patrick corrected himself. Yeah, near 1. Yeah, it's going to be very close to 1, right? We should expect a very high R squared value. Isa says R squared close to 1. That's exactly right. We should be expecting a very close value to 1. Because remember, we asked for a low RSE, which means that the errors between the predicted and the actual are very small, right? In other words, that line and the dots are very close together, which means that your model, the model that should come of that should be very close to the training data. So that means on a proportionate basis, a lot of your predictions are going to be explained by your training data, which means that you should be high, you should be close to 1. So yeah, Amram Pali, that's exactly right. Amram Pali says R squared should be good towards 1 as it is low RSE. That's exactly right. Okay, so again, we're using this almost as like a check, because what if ChatGPT's code is wrong, right? We should be, kind of checking ourselves along the way, because ChatGPT does make mistakes, guys, right? So that's why I'm going through this exercise so that we can kind of, run ahead and say, okay, yeah, that looks like a good result, or whoa, that's a terrible result. Where did ChatGPT go wrong? Because we didn't write this code. ChatGPT wrote this code, right? All right, so let's do it. Let's run this code. I think we're ready for it. Ooh, I didn't save it. So let me save this code. And then we're going to go to our terminal. Because we are professional developers, we do not use notebooks. Linear regression 1 factor dot pi. All right, let's see what happens. All right, coefficient of 9.999, intercept of 7.0, mean squared error of 0.009, residual standard error of 0.09, r squared 0.999. Let me know if you need that terminal bigger. But what do you guys think? Are we on the right track? Yes or no? Give me a yes or no in the chat, guys. I want to see as much participation as possible. Don't be shy. No wrong answers. But are we on the right track? Do these results look like we have viable code here? Joseph, you're asking a great question. Where can we learn how to work with an IDE and the command line prompt? Joseph, it's practice, my friend. It's just practice. That's really the only way I can tell you. Maybe, you know what, guys? Maybe I should write that resource, but I don't know any good resources that can teach you like from a level of 0 to do this. This is one of those things, like I said, I've just been doing it for so long, but I've been a professional software engineer from the beginning, basically. And I've been a data scientist for like the last 15 years. So this is just the way I've always done it. Like, this is the way professional code is done. So I wish I could tell you, oh, I learned from this book or from this tutorial. It's just the way I've always done it. I've worked in a lot of environments. I've had clients all over the world. I've been fortunate to work on a million different projects. And this is how it's done in the real world. So really, that's just like the only way I can tell you that you have to just kind of get out there and do it. Being on Mac helps because Mac has great terminals, and the Mac operating system, very closely mimics Linux. I think it started as one of the Linux variants, and then Apple has built upon it, obviously. But that's really kind of like the best way I can tell you. You just kind of have to do it. Okay, so Explore the Beauty says r squared should be close to 1, and we are, right? We're at 0.999. That's pretty close. Melly Durr says, I think so, as far as it looks good. Joseph Hernandez says it looks good. Isa says looks good and satisfactory. Amrapali says looks reasonable. Okay. Ashish, I answered this question on an earlier slide. Maybe you were just away from the screen, but go ahead and refer back to the replay on that, or maybe somebody in the chat will help you. Okay, so Amrapali says it looks reasonable. Okay, all right, guys. So yeah, and I agree. It looks reasonable to me. We got very close to our coefficient. We know that our formula was y equals 10x plus 7. We got very close. Basically, we got to the intercept, right? We know the intercept was 7. Mean square error is as low to 0 as possible. Residual standard error is 0.97, which is good. R squared is 0.999. So yeah, these all look like very reasonable results. So this tells us that our code that ChatGPT produced for us is reasonable, right? Like we have functional code. So we can have faith in this code to go on and do more modeling with it, right? All right, so next thing we want to do is let's try our high RSE. So guys, what are we expecting here? Same question as before. What are you expecting here? What coefficients, intercepts, mean squared? What do you guys think? Remember, this time we're using our synthetic data set that has a high RSE. What do you guys think? What are we expecting? You don't have to do all of them. Just tell me what the R squared value we're expecting is. What do you guys think? Is it going to be 0.999 again? Yeah, Issa says, not comfortable working with terminals. We don't do it on Uni, mostly GUIs. Yeah, Issa, I get it. I hear you. It's a pain point. And maybe I'll do that. Maybe I'll come up with a resource to help you guys with it. Because, yeah, it's just the way it's done in the real world, And it comes back to that same discussion that we had earlier, right? Where people are talking about, oh, well, should I go for Amazon, Azure, Google certifications? Well, be careful, right? Because if you're saying, hey, I'm Azure certified, that might be telling a hiring manager, oh, this is somebody who always needs an interface to work with servers. They need an interface to work with databases, right? I mean, it's been a while since I looked at Azure, but Azure is very GUI based for their management, right? You want to be able to walk into an interview that says, yeah, I can work with Azure, I can work with Terminal, these are the different flavors of Linux that I know. You kind of want to have that flexibility in your resume, guys, okay? Okay, so Issa says R squared is close to 0. Amrampali says definitely low R squared. Joseph says low, maybe less than 0.7. Joseph says just low. Okay, guys, so I don't want to sound like I'm splitting hairs here, but there is a difference between saying it's going to be close to 0 versus definitely low R squared. And I think I tend to agree a little bit more with Amrampali, where Issa, we don't know it's going to be 0. The only thing we really know is that it's definitely not going to be close to 1, and it's going to be low. So I'm leaning more towards Amrampali's answer and Joseph's answer about low, maybe less than 0.7. Joseph, I would say it's even lower than that. I mean, I would say like 0.2. So again, that's kind of more Amrampali's answer, where, it's definitely going to be low. I mean, I would, if we were betting and we had an over-under, I would put the under at 0.2. 0.7, it's definitely going to be less than that, right? But you guys are on the right track, though. We know this is going to be a bad fit model, right? We know that we introduced a lot of noise into the data. So this is not going to be a great model, right? So yeah, let's go ahead and run it. So same code, we just use a different file. So I can execute the same line. Yeah. All right, so let's see what this gives us. All right. Oh, that doesn't look right. Did I not save it? Wait, what just happened here? Yeah. I did that. We're pulling from the high RSC. Okay, let's run it again just to make sure. All right, so this time we got coefficients that are still reasonable, right? So we know that the modeling went okay. But this time we got a really high MSE and also a very high RSC. But the R squared is also high. Why is that? Anybody want to take guesses on why that is? Actually, I think I know why. I can see why we have that. Anybody else want to take a guess? Give you guys another second here in the chat. All right, what do you guys think? Patrick says, is it because we are using a linear model to model linear data? Yeah, in a way, yes. I think you're providing a good explanation. Amrampali says, is it pointing to the correct file? It is, Amrampali. So there's two possibilities here. Is that one, the file itself could be created incorrectly, right? Maybe we could look at our creation code again. But here's what's getting to me, guys. Look at the intercepts and look at the coefficient. The model still did a fairly okay job at figuring out what the coefficients and the intercepts were. So in other words, when ChatGPT created the synthetic data, it still created pretty good X values, but the Y values were still off. And that's why we're still getting very high mean squared errors and residual standard errors, right? Because, I mean, we got excellent values in the previous one when we knew we were using the low RSC file. But here, it still did a pretty good job of finding the model, but the mean squared error and the RSC are still low. Ashish, it has changed. It has changed from the previous file. Ignore this run here because this run is a repeat, right? But this is the previous run. This here is the run with the low RSC file. So it has changed significantly, right? That's a significant change in the MSCs and RSCs. So I think this is an interesting case here because ChatGPT did a good job of changing the Y values, but not the X values. Yeah, but I think that's why, Ashish, because the X values are still valid. It's the Y values that I think ChatGPT changed, or the code that it gave us for the synthetic generation that changed it. So here's what we can do, guys. We can go back to ChatGPT. And let's get a new generation for data. IRC and low R squared. Okay, that's interesting. It's using a really high noise level at this point. If you guys look at that, it went from using a noise level of 0.1 to using a noise level of 10, and we didn't do that in our previous code. We went from 0.1 to 5. So maybe that's part of the challenge. So maybe we should be doing it. Maybe we should be putting it much higher here. So that's one option for our change. What do you guys think? Patrick says maybe we can shift the location of our noise to add a systematic shift. Yeah, maybe. Let me show you something else, because here's what's also getting to me. I did a test to get ready for this course. And this is the code that ChatGPT had given me previously, where it's using the random normal distribution from NumPy and the standard deviations in order to modify the value of the code, or the value the value of the RSE and the R squared. So I have a feeling that it's also related to that. So here's what we're going to do. I have it for another, I have it for 2 variable linear regression, because I want to make sure that I show you a model that has multiple values for for factors, right? So it's not just y equals mx plus b, it's y equals mx plus mz plus b, right? So let's go ahead and use this one here, because this is going to give us for 2 variables. So let me bring this up to my root directory. Yep. So now it's going to be dataset gen for 2 variables. And let's relook at this code. And I like that. We're going to have different coefficients now. But you can see here how we have an x and we have a z value, and then we're still going to a y. All right, you guys with me so far? But let's go ahead and execute this code and use the files that it gives us. And I'm going to go ahead and move these CSVs to the archive, just so that we don't get confused. All right, dataset gen2 var. Dataset gen 2 var. Oh. Oh. I forgot a T. All right. All right, guys. So now we have this new data set with an X, Z, and a Y. And that's should give us a good RSE, and it should give us a bad RSE. So now we're going to ask ChatGPT for how to do this with how to do linear regression with multiple values, right? So it's going to be this here. Oh, it thinks that we're still working with synthetic data set, so that's not good. Oh, okay, it's going to give us that too. Okay, great. All right, so let me copy this over. And I think I need to create the file on VS Code. I don't think we did that yet. Linear regression 1 factor, yep. So now we need to create a second one. Linear regression 2 factor dot py. All right, let's drop this in. And we are going to be using the good RSE data set. All right, guys, start putting in your predictions. What are we expecting? What are we expecting for these down here? Oh, did I not copy that correctly? That is a weird result. It forgot to do the include for NumPy. Oh, wait a minute, did I use the wrong code? What happened there? Wait, hold on a second, guys. I'm tripping over my own shoelaces, as we say. Linear regression two-factor. Linear regression two-factor dot pi. And it's showing a problem in line 23. Yeah, that's weird. So it looks like ChatGPT made a mistake. It didn't give us the NumPy import. Everybody see that? Let me pause here and make sure everybody sees what we're doing there. Anybody else see the problem that we ran into there? You guys still with me? Hey, Issa, good seeing you. Safe travels. All right, guys, so that's a serious problem, huh? And this is exactly why we still need to have a pretty good level of understanding of code, right? Because ChatGPT will make mistakes, and this is a clear mistake on ChatGPT's part. It gave us code that didn't have the right includes at the top, or excuse me, the right imports at the top, right? So this is the stuff that we still need to be aware of, even though we're relying on ChatGPT to write code for us. So now let's go back. Our code is saved. We're not getting any more warnings, right? VS Code is not yellow. Let's see what this gives us. Okay, this looks reasonable. Coefficients of 3.8, 6.3. Is that reasonable for what we gave it? 3.8 and 6.3? Yeah. So 3.8, 6.3. You know, not the greatest fit, but a reasonable enough fit for 4x and 6z. And intercept of 15, intercept of 14.955. Okay, so pretty reasonable. What do you guys think? Yeah, you're right, Joseph. That's exactly right. It missed an import. So guys, really gives I'm glad this error came up, because it does set the tone for the importance of still, having coding skills and being able to edit when ChatGPT makes mistakes, because the mistakes will happen. And keep in mind also, this is the 4.0 model. This is their latest model. So I'm really surprised that it's making such basic mistakes like that. All right, but good. I'm glad that we were able to tackle both a one-factor and a two-factor problem, because you can see here that in this case, this line is the key one, right? This line is telling you that there's two coefficients that need to be worked through for this model. And then, of course, there's an intercept, right? There's not always an intercept, but in this case, it's telling us. So we got to the expected values. We got really good values for the MSE, RSE, and a good value for the R squared, right? So this is good. All right, so let's go back to our deck. We have hit all of the items that we wanted to hit during our lab walkthrough, right? Let's go to the next slide, because here is where I want to leave you guys with some self-study. First thing I want you to consider is, what does the code look like for additional factors? Maybe your model has 3 factors, 5 factors, 10 factors. What does that code look like? What about categorical results? We've only talked about scalar results, but we also mentioned categorical results. What does that code look like? We use synthetic data. Can you do this with real world data? That would be an interesting challenge too, right? And then, if you really want to take it another step further, if you're really feeling ambitious, what does it look like with another framework like Keras? Because right now we're using scikit-learn and we're using a lot of, NumPy code and kind of piecing things together. But there's other ways to do this, right? Like Keras can do linear regression. So what does it look like when you're using Keras? Because generally speaking, you wouldn't do it in the same way that I'm showing it to you here. You probably would use a framework. I'm more of a Keras guy than I am a PyTorch guy, but I'm pretty sure PyTorch can also do linear regression. So how would you do it in PyTorch, right? So these are the things that I want you to think about as far as next steps. So if you wanted to do some programming on your own, this is where I would extend it to. And keep in mind that when I say programming, I'm talking about ChatGPT. So yes, we kind of got snake bit a little bit right now by ChatGPT, but that's okay. That's going to happen. That's going to happen in the real world. It's going to happen to you whether you use ChatGPT or not. Or maybe you inherited somebody else's code and they made a mistake, right? So, you're still going to have to, have an editing mindset to be able to catch things like this, right? So that's where I want to leave you with the self-study. And, that's where we're going to pick up next week. We're going to move on to chapter 4 next week. So if you want to get ready for that. But I want to thank you guys for sticking with me. I know a couple of you guys were there from beginning to end. So thank you so much for that. I want to, give you another couple minutes here if you have any questions, because we've covered a lot of ground. But again, I think we've done a lot of really good work here. I think I've shown you how I want to manage these sessions going forward, because we're going to write very little code. We're going to write very little native code, right? And that's going to have its upsides, and it's also going to have its downsides. We saw one of the downsides today. But we got to roll with the punches, and we got to, fix the code, right? That's our job as data scientists, right? So I think you guys did really good. Got a lot of really great answers. I really want to thank you for all the participation on all the questions. Really impressed by that. But this is where I want to leave you guys for self-study, and hopefully see you again here next week. Ashish says, thanks Dennis for the patience. Love the content. Oh, thank you so much, Ashish. Again, I'm just sharing what I love, what my experience has been. So if it helps somebody, then that makes me happy. So thank you so much for that feedback. All right, last call for any questions or any closing notes, guys. But thank you so much. This has been really fun, really interesting. So I hope you keep on coming back future Sundays. Again, this is how this is the framework that I want us to establish to work together. And Patrick says thank you. Thank you, Patrick. Appreciate that. Everybody give a shout out to Patrick for helping me mod. Thank you so much for this, guys. Angel, thank you. Sravan, thank you. All right, everybody. So stay cool out there. It's probably hot in your part of the world. That's a pretty safe bet to say that. But yeah, take care of yourselves. Take care of your families. And I'll see you next time. Hey guys, how are you? Good morning. Happy Sunday. Hope you're doing well. I can't believe that the countdown timer ran out on me before I joined in. Sorry about that. I didn't turn on my camera quickly enough. But I hope you're doing well. Thank you so much for joining me in this continuing series on the Introduction to Statistical Learning book. This book here, again, this is the book where professional data science begins. So what I'm doing is I have an 8-week series where we're going to cover each one of the chapters every Sunday. This happens to be week number 2, which means that we did chapters 1 through 3 last week, and we're going to do chapter 4 today. And I think the book really lays out data science in a very good way, so that you're going to establish a really good foundation for moving on in your data science studies. So thank you so much for joining me. I'm seeing different people on Instagram. I'm seeing different people on YouTube. Really going to get a great turnout today. So let me start by looking into some of the chats. I already see chats already going on all platforms, which is fantastic. And by the way, today I'm also experimenting by pushing out on Kik. I just opened a Kik account yesterday, so I thought maybe I'd push out there. So if you also have a Kik account, feel free to follow me there. But I think that most of you will be following along on YouTube because YouTube provides you with a wider format, which is a little bit more convenient for some of the stuff we do, especially when we get into the classroom view. But yeah, just want to go ahead and get started and, make sure I greet everyone because everyone here is already ready to go. But let me hop into my chat here. Patrick, good morning. Hey, all happy, hoping you're having a great Sunday. Thank you so much, Patrick. Patrick, by the way, is going to be our moderator in YouTube, and he's also one of my moderators in Discord. Really helps me out. So, give a shout out to Patrick when you get a chance. But thank you for being here, Patrick. Rohan, good to see you again. I know you've been attending a lot this week, so thank you so much for being here. Hope you're well. Sayed Salmanziz says, good morning, Mr. Dennis. Good morning to you too. Hope you're well. Rohan says, can you increase the font size during the coding part? Yeah, sure. I think I got to a pretty good font size last time. If not, let me know. But yeah, we can definitely do that. I'll do that for both the code and the terminal. Hamad Javed, welcome Hamad. Hello everyone, I hope you're doing well. Well, thank you Hamad, hope you're well too. Himsteak says, good morning all, good to see you. Rex Riker, our man in New York City, says, hi everyone. Well, hello, Rex. Good to see you, my friend. Rex is also an active participant on our Discord. If you haven't joined our Discord, we have over 50 people now, which is incredible, on the Discord. So if you'd like to join the Discord, you're welcome to do that. The link is in my Instagram highlights. Explore the beauty of nature. Well, good to see you, my friend. I think you attended all of last week's class. I think you were one of the people that stayed for the whole thing. So glad to see you. Hope you're well. Okay. So I think we are ready to get started. What I want to do is, and by the way, if you haven't introduced yourself, please go ahead and let me know where you're checking in from. And then also, I do like to run my classes with a lot of feedback. So I will be asking questions, throwing questions out to the chat, and please participate as you feel comfortable. It kind of helps everyone learn from each other. There's no bad answers, and I'm not going to call on you for an answer. Just participate as you feel comfortable, but it really helps the overall learning if people, kind of help and jump in and help each other. Rahul Jain, hello all, lovely to meet you all again. Nice to see you, my friend. Atharva, I don't know what you're referring to. If you want to provide some clarification there, I don't usually help people with homework questions. That sounds like a homework question. Siva Namaste from India. Nice to see you again, Siva. I know you've been on plenty of streams before, so nice to see you, my friend. Hey, you may call me Tim is back. Hello, Tim. I think you took a little break there, but you're back. Good to see you again, my friend. Hi, Dennis from India, Dehradun. I hope I'm pronouncing right. Okay, Palki, good to see you again, Palki. Patrick, I love your reply. That's funny. Yes, I guess people in the chat think that they should be writing prompts so that Dennis AI can write it for them. That's hilarious. I love that reply, Patrick. And Andy Edife? Andy Edife says, good morning, my name is Anderson. I am a master's student in economics from Nigeria. Welcome. Welcome. I appreciate you joining. We get a lot of viewers from the African continent, so good to see you. Yeah, Rex, indeed. That was funny. I love that reply by Patrick. Ashish, hello, Dennis. Hello, Dennis. Good to see you. Good to see you too, Ashish. Welcome back. Rahul, smart reply, Patrick. Yeah. Patrick gets his name on the board today. He made a good one today. Sai Divya, hello, Dennis from Dallas. Oh, very cool. What part of Dallas? I was based in Dallas for 2 years, like right before the pandemic. I was based in Dallas. Still have many friends there actually. Love the community there. Lots of tech companies in Dallas, at least in the areas where I was. Lots of really good Indian restaurants in Dallas too. So yeah, hope you're well there, Sai. Sanai Muthu says, hey Dennis, I'm also in India. Happy to see you again. Oh, happy to see you too, Sanai. Welcome back. Essay Work says, dear sir, I'm new here, just curious to know about statistical strategies in machine learning. Well, you're in the right place. You're in the right place. The book that we're going to is called An Introduction to Statistical Learning. So you're in the right place for it. And, we're going to go ahead and, just keep on going with the book. And, you're welcome to join us for as long as you can. again, I told people, if you need to go, you can always come back. We know these sessions tend to go at least 2 hours. We haven't gone anything short than 2 hours, really anything short than 2.5 hours. So yeah, come and learn as much as you like, and if you need to step away, that's totally okay. My hair is not cooperating this morning. Ugh, I didn't put enough product in it, eh? I always, shower fresh and everything right before these streams, but I didn't put enough product in my hair. So you're going to have to forgive my hair. It looks terrible this morning. Sincerely, Sadiq says, hello, Dennis. I'm Sadiq from Raleigh, North Carolina. Oh, very cool. I have family in Raleigh. Let me know what part of Raleigh you're from. Lots of tech companies there in the Triangle in Raleigh. Hello, Dennis. How are you doing? Happy Sunday from Nigeria, from Michael. I'm doing well, Michael. Thank you so much for asking. I got up early. I've been up since 4:30 in the morning. I take my dog to the dog park. He runs around and has his fun. And then I go to Starbucks, come home, do some work, get ready for the day. Just so I've had a good morning. So we're gonna continue that with having a good class today. Nazish says, hi Dennis, really excited to be part of this session. I'm excited too. These sessions are fun. I hope they're informative for everyone. Honestly, it helps me too to kind of go back and look at some of these concepts in the book. I've had this book for a very long time. I'm embarrassed to show you the back because it's so dirty, and it's a book that I refer to quite a bit. But it's been helpful for me too to also go back and remember just little different things like, oh yeah. And actually, and now since I have a lot more experience in the industry, it's also helpful for me to go in there and say, yeah, I want to teach this because I know I've used this. I know this is important. And then I can look at other things and say, yeah, that's a good chapter, but maybe not as important because, it's been like multiple years and I haven't used it, So it's been good for me too to kind of go back and help these things, okay? Yes, somebody help Atharva. I think Atharva might be AI. Maybe we have it backwards. Maybe he's AI. So, because it sounds like he's just repeating the scripts from some of the previous sessions and some of my reels because these are some of the interview questions that I asked. So yeah, somebody help Atharva. Somebody guide Atharva in the right direction. All right, guys. So now that I'm seeing some of the hellos slow down a little bit, let's go ahead and get started, huh? So I'm going to switch over to my classroom view. And what I think I'm going to do, Hamad, that's a good point. Yes, something is not being understood here by Atharva. Let's all try to help him out. So I'm going to switch over to my classroom view. And I'm going to bring up my slides. And it looks like I might have to redo my classroom view. Give me just a second here, guys. For some reason, I have to refresh this every once in a while. Okay. All right, so this is my classroom view. Again, if you're on Instagram, maybe not the ideal platform, feel free to go to YouTube so you can get a widescreen view. But what I'm going to do is, today our focus is on chapter 4 of the ISL book. If you don't have the physical book, you can always go to the author's website, statlearning.com, and download the PDF. I am working from the ISL book that's for the R version, and this is their first edition. They've updated it since then, but it's the edition that I have, so it's the one I feel most comfortable teaching. Don't worry about the language, because if you haven't heard, the twist that I'm doing here, to honor the author's work, is that we are doing it with AI. We are not going to be doing any native code. We are going to be using AI to write all of our code. So it's going to be, a little bit of a twist, a little bit more fun that way, okay? So here's what I want to do. I'm seeing a lot of new people in the chat. Maybe you didn't come to the last session. So what I want to do is I want to go ahead and I want to start by doing a review of the previous slides. Or at least the introduction slides, because I want to make sure that we're all on the same page. I know a lot of you also attended last week, so I'm going to keep it a little, I'm going to keep it quick for the introduction, but I do think it's good for us to see that, just to kind of get all of us on the same page, okay? So in my introduction, I want to cover the philosophy that I'm going to use for the class, a kickoff as far as how I see the class going, and then the agenda for everything that we're going to do for the remaining weeks, okay? So, data science is a very serious study. It's a profession that you have to dedicate your life to. There is nothing that disappoints me more than when I see these, hack the interview or these shortcut sheets on LinkedIn making somebody think that they can become a data scientist in a month after reading a couple of sheets. It's a very serious profession. I equate it to being like a doctor or a lawyer, where you have to study a lot, and then after you finish your study, you're still going to learn a lot on the job. So for me, if I don't like that people are cheapening the profession by doing these hacks, then it's up to me to contribute and kind of help the data science ecosystem by teaching what I think is relevant. And that's really the point here of this course, that I want you to understand that I'm not offering any shortcuts. I'm not offering any hacks. It's going to take work to become a data scientist. But having said that, I assume that you want to approach this in a professional way. We're not just looking for a job. We're looking for a career. We're looking for a profession. So that's really kind of where I'm approaching this. In addition to that, it's also important for a data scientist to maintain flexibility in their thinking and carry that for the length of your career. You should always be open to more learning, different approaches, different thoughts than your own, so on and so forth. So that's part of also the philosophy that I want to encourage in you for attending a course like this. Okay? I teach with the Socratic method. That means that I ask a lot of questions. If you post a question in the chat, I might reply to you with a question, because that keeps the conversation going, and it kind of helps you kind of think on your own 2 feet, not to always just have the answer, kind of spoon-fed towards you, right? So I want to make sure that, you also understand that, I'm asking you to listen and participate as much as you can, I know that most people might be watching on their phones or things like that, but try to make this a dedicated time so that you can participate back, because I think it really helps you. And it also helps you to read the comments from everybody else, right? To read the answers from everybody else, to read the questions they have, right? I think all of that really helps. I am not promising that you will be ready for a job after this, but you're going to have a pretty good foundation. You're going to have a really good foundation to continue your study and keep going forward with more of the things that you're going to learn and some of the things that aren't taught in this book. There's plenty of things that aren't taught in this book, and the authors fully acknowledge that, right? So I want to make sure that you have that understanding that this isn't for a job, but it is for a pretty good foundation. And again, it's for professional data science. This isn't just somebody who, I really need a remote job, or you just want to rush into it, right? It's intended, to help cultivate the professionalism that it takes to become a data scientist. So we are doing the Introduction to Statistical Learning book, and my intent is to honor the authors, because I want to be intellectually honest throughout this process. I'm not here to copy anybody's work. That's not my style. That's not intellectually honest. So we know that the authors have developed the ISL book for R, and we know that they've also developed the ISL book for Python. That's ISLP. So how can I build upon that work? Because that's the way I want to honor the authors. And what we're doing, I'm introducing ISLA, which is the ISL book with generative AI tools. This is rooted in what I call the blank screen effect. If you're a data scientist, a software developer, and other professions too, like lawyers, real estate agents, advertising executives, you should never start from a blank screen anymore. Gen AI has changed that. If you are starting from a blank screen, then you are a dinosaur. Your job will be eliminated. This is what I truly believe will be the future of data science development. You will not write algorithms. You will supervise ChatGPT writing algorithms for you. I'm 100% convinced of this. So we might as well get a head start now and start working with some of those tools and start working in that mode where we think of ourselves, this is fine, where we think of ourselves as developing the skills to do the managing of AI tools, not necessarily of writing our own code. So we are going to learn the concepts from each chapter, and then we're going to use AI to help our understanding of that, and to handle the prompts that we create. And then our job will be to edit and refine the code to a deliverable state. We will be editors of code, not writers of code. And by the way, we already saw that. We saw that in last week's session. For those of you that attended, you saw that ChatGPT made a very fundamental, very simple mistake in one of the code scripts that it generated for us. So the AI tools are not perfect, but they're close enough. So we still have to be smart enough to be an architect and understand what we need, understand how we're going to prompt the AI, but then also be able to understand when it makes mistakes. So that's what we're going to be doing, okay? So I'm going to provide the general concepts that I pick up from the chapters. More specifically, the stuff that I know we use in the real world of data science. And in some cases, I'll point out stuff that maybe you don't use. That's going to be the case today. I'll point out some stuff that maybe you don't use, right? So that's kind of my intent. I'm not going to sit here page by page and copying the author's work. That's not honest. I'm going to give you the highlights as I see them as a chief data scientist. Maybe things I ask questions on, maybe things I know we've used, maybe like theoretical things I ask in interviews. I'm going to just kind of like be curating those out of the chapters and presenting them to you in these slides. And then we're also going to do 1 to 2 lab exercises. And then I also leave you with some like additional thoughts of where you can take this further. So if you want to do some of your own study, I'm gonna leave you with a couple nuggets to say, well, what about this? What if you extended it this way? What if the problem was X instead of Y? And how would you modify what we did today to do that? I'm gonna try to leave you with some of those things. But again, the work will be on you. The work will be on you to take that and run with it, okay? And then finally, as I said earlier, I'm working from ISLR version 1 that's available as a PDF. Let me go down here. Patrick has been kind enough to already post it in the chat. That is where you can download it from. And also, again, to honor the authors, that's also the author's website. That's the official website for this book. So please go there, support them. They've created a wonderful book. I'm not trying to steal any of their book or any of the idea. So please go to them, and that way we can all honor their work, okay? Yes, so if you want to know which one to download, there's multiple PDFs. Go ahead and download ISLR version 1. Again, it's just the one I like. It's the one I feel most comfortable with. If you want to download the other ones, it's up to you. But I will be teaching, and what I show on the screen when I do show the PDF, it will be the version 1 of the R code version. Okay. Okay, so let's go. Let's go to the next slide. Yeah, so you're encouraged to read the PDF prior to each session. So today we're on chapter 4, and we're going to do one chapter all the way to the end. I believe there's 10 chapters in that version. So we're going to go through today and then in the coming another 6 Sundays after today. Everything is as a live stream. I completely hate the thought of sitting here and recording something for you guys and then you having to see it. That's not my style. I'm never going to record content like that. I think that's boring. So it'll always be a live stream. I love seeing you guys in the live stream. I like highlighting your chats and things like that. So this is the format we're always going to do. I refuse to teach in any other way. I make the announcements on Instagram. I also post the thumbnails and the session ahead of time on YouTube. So make sure you subscribe to my YouTube, and when you see the new thumbnail come up, click on notify, and YouTube sends you an alert, I think like 5 minutes or 10 minutes before my stream starts. So YouTube will take care of notifying you and saying, hey, the next class is starting or whatnot. So feel free to click on that, and that way you'll never miss a class. Or I keep them up on YouTube. I host, it's in my, I think it just converts to a video, so you can sit there and watch it. Maybe you missed a particular portion and you want to review, whatever the case may be. Okay. Okay, so this is the chapters that we're going to cover, and give me just a little break here, guys. Hold on. Sorry about that. I had to sneeze a little bit. So these are the chapters that we're going to be covering. And then also, I do want to emphasize this again, because some of you, weren't here last week. And I think of this as like, if you were to go to an Olympic athlete, like a javelin thrower, right? And you were to take lessons from them, they're probably going to focus on a lot of the general stuff, right? They're going to show you, how to hold it, how many steps to run, at what time to throw the javelin, right? And they're going to do that. But you, as a beginner, you might have questions beyond that and say, well, like, why do I put my wrist in this way? Or like, why does my arm have to be like at this angle and not this angle, right? And that javelin thrower, that expert athlete is going to tell you, I don't know, I've just always done it that way. It's just kind of habit, right? There's things that they literally can't explain because that's just the way they've always done them, right? So I feel the same way because I've been a developer and in the field and a data scientist for a long time, that sometimes I may be glossing over things that to me are just like natural things that I haven't thought about in years, but to you, they might still be new. So feel free to, kind of call me out on that. If there's something that's not clear, I encourage you to come back with questions and just, let me know what, something needs more explanation or whatnot. But, that's just the way my mind thinks because I've been at it for so long, right? I don't think about like the small little individual things. I just do them. I've just done them for years. So I hope that's clear. And, again, just encourage you, feel free to stop me and keep going. Okay? All right, let me check the chat here. Patrick's doing a great job of answering it. Okay, yeah. It looks like Patrick's handling all the questions. If there's anything else that's needed, let me know. I'll stop the session. But Patrick, thanks so much for answering all those. All right, let me see if there's anything else in the setup that we should go over. Otherwise, we're going to jump to chapter 4. Okay, so this is the general concepts. Yeah. So I'm going to come back to this slide because there's one more thing I want to cover with you guys. This is it right here. Okay, so real quick, again, I realize that this is a repeat for those of you who attended last week. I apologize, but I'm seeing some new names, so I want to make sure we go through these. In chapter 1, this is important, you're going to find these 4 tenets or these 4 premises that the authors put forward. And I really like those premises, and I want to make sure that you also understand them because I think they're important. So the first thing is they talk about how they fully acknowledge that there's more models out there. There's more to learn. There's plenty of things out there for you to tackle. But they have narrowed it down to what they think are the most flexible and most widely applicable models across industries, right? See, that's what makes this book so good, that they recognize that their work is not just academic. They realize that it will be used out there in business applications. So the authors clearly acknowledge that you're going to be working for somebody, you're going to be in some sort of business environment. So these are the most widely applicable in industrial approaches to data science. So I think that's really important to understand because one, it helps you understand how these chapters came to be, how they chose these chapters. And two, as I said earlier, finishing this book, finishing my course, finishing any class is not a straight jump to getting a job. It's a good foundation. You're still going to have to build upon it. You're still going to have to, learn more about different things, right? For example, I don't want to speak for them, but I think the authors would agree that this is not necessarily a good book to learn neural networks, right? They cover neural networks very little in this book, right? So you're still going to have to go out and do your work, but the authors do try to provide the most applicable models in here. Second, no single approach is going to work well for any given problem that you have. They're going to have trade-offs, but most importantly, this is where the experimentation in data science begins. Some of you were in the chats earlier this week where we talked about what's your favorite machine learning model, right? And that's a trick question. You shouldn't have a favorite machine learning model because there is no favorite. Every piece of data, every project, every endeavor you're going to take in data science is unique. So you can't say, oh, that data looks like some data I worked on last year, so let me use the same model. No, right? No approach will work well in all situations. You always have to run a proper experimentation process. That's the science part of it, right? So keep that in mind. Super important premise. This one is also very key. I'm copying directly from the book. We assume that the reader is comfortable with basic mathematical concepts, but we do not assume a graduate degree in mathematical sciences. This is so key. And we've seen some back and forth. One, I get a lot of private messages from a lot of you who are intimidated by the math. Some of you put that in your comments. And sometimes we have to go back and forth in the comments with some people who just refuse to believe this. I guess there's a lot of linear algebra supporters out there that can't handle their world being rattled by by hearing this. But the reality is that the math that you need in data science is way overstated. It's much better to understand the models, what they do, how to use them, and how they can apply to different problems, and how you can use a series of those models to find the most applicable for your individual problem. And again, this is not me saying this. I said it before the office because I truly believe in this. I've seen it. I've seen it in the people that I hire, in the projects I've run, the way we execute those projects. You don't need this amazing graduate level, PhD level worth of mathematics, right? The time when companies only hired PhDs in mathematics has come and gone. It hasn't been that way for at least 6 to 8 years, right? And then finally, the authors, again, coming back to their acknowledgement that we're all going to be working in the real world, the book focuses on solving real world problems. And I love that because that's what I focus on too. That's what I try to center my content on. I've already been in the industry. Now I'm reaching my hand back to help all of you, but I'm going to do it with that twist of this isn't a school exercise. This is the real world. All right. We are out there, earning a paycheck from our skills, right? And this is what's required of that. That's different from academia. Okay? So, closing with that, I encourage you to read the ISL book. If you also want to know more about data science in the real world, I also will point you to my book, Your First Year in Data Science. I just published it last week. I'm #1 in the new releases in the data mining space on Amazon, so I'm really proud of that. So if you guys are interested in learning more about the real world of data science, there's a whole book on it. Really proud of it. I went through a lot of work to make sure I produced a quality product for you guys. It's all in color. All the charts are in color. So if you're interested in that, I'd appreciate your support. It's available on Amazon globally. I've made the ebook version affordable. So please consider the book, and I appreciate your support. All right. So these 4 tenets are what I like from the author, and I think that's the last part of the first chapter. That's the last part I want to talk about because I think it's super important, so feel free to revisit that. Okay, so now let's get started. I'm going to reuse one of my slides from chapter 1. And this is our first opportunity for participation here, guys. So listen up. I'm seeing a lot of YouTube folks, which is great. If you're on Instagram, feel free to join us. You're welcome. You're welcome to also participate and give answers as you see fit. What are quantitative outputs and what are qualitative outputs? Give me an example, give me your definition, give me your elevator pitch, whatever you'd like. And then if you want extra credit, tell me what's clustering. All right? So I'm going to give the chat here a minute. Let me know. You don't have to answer all 3, by the way. You can answer just one if you're comfortable with. But what is quantitative, what is qualitative, and what is clustering? Answer however many you feel comfortable with. I'll give you guys a minute while I take a water break here. What do you guys think? Qualitative, quantitative, and clustering. Give me some definitions or examples. All right, Rahul, thank you so much. Rahul is giving us our first answer. Quantitative means which can be measured using numbers like count, average, sum. Okay. Explore the beauty. Wonderful. He's going to give us, he's volunteering for qualitative. Qualitative outputs can involve a set of land cover classes, water, built up forest. Okay. There's a name for that. Explore the beauty. Give me you understand what it is, but there's a name for some like water, built up forest. I love the example. So to be fair, you filled that because I did ask for examples, but give me the name for that. There's a name for that, okay? Mamiya says when response variable is expected to be numerical, it's quantitative. Great answer. I'm on board with that. Quantitative output is numerical output, more so predicted number or figure. Okay, being, I'm on board with that. Clustering means grouping items in different classes. Nice, Rohan. I'm on board with that too. So Rohan volunteered for clustering. I like it. Nazish says qualitative. Do these individuals have a lung disease or not? And is in the form of yes, no. Ooh. Chat. What do you guys think? That's an interesting answer. Nasish, I love the way you're thinking about this. You had, Nazish, you had me at lung disease. You lost me at yes or no. Is it always yes or no? What do you think? What do you think, Chad? Is it always yes or no? You know what, Nasish? Ultimately, don't misunderstand me. I love your answer because it fits perfectly with what we're going to talk about today. But is it always yes or no? Tell me, guys. Quantitative like age, qualitative like gender. Yeah, okay. I'm on board with that. Ah, Patrick. Patrick is presenting us with a key word here. Qualitative is categorical. Is that right, chat? One, is that right? And two, are categories always yes, no? Because we've been told that it's also just yes, no, right? Is that the case? But Patrick, I'm on board with your use of categorical. That's a key word, right? We should be thinking about that. After all, today's chapter is categorization, right? So I like it, Patrick. SID official, deal with numerical quantitative, and deal with numerical is quantitative, and with variable qualitative. Clustering means grouping items into different subset from a set. Yeah, okay. I'm on board with that. I think that clustering can have more uses than that, but yeah, I'm on board with that. Qualitative is why, and quantitative is how much. And quantitative is how much. I'm on board with your quantitative. Qualitative is why. Is it always a why? I don't know about that. Is it always a why? I think it can be more flexible than that. What do you guys think? Mamiya says when a categorical output is expected from response variable is qualitative. Love it. Love it. That's a great brief answer. Love it, Mamiya. I think you're on the right track with that, my friend. Rahul says clustering is when you group data with some similar features. Yeah. I like it, Rahul. I'm on board with that. Clustering is grouping different classes together. Yep. Yep, that's a good one, being. Clustering is grouping two or more classes based on their characteristics. Yeah. Yeah, Rahul adds for qualitative. Qualitative means which cannot be measured with numerical accuracy. Text or image of categorical groups would have to be interpreted. Yeah, that's one use. But I just don't want you guys to think that that's the only use. There's a lot of uses for categorical, right? Or for qualitative outputs, I should say. So yeah, I'm on board with it, Rahul. Just make sure you understand that there's more uses than just categorical groups, okay? Or you can think of it more than just groups. Being says categories can be more than yes or no. I agree. So that's coming back to the earlier response about it being in the form of yes, no. Categories can indeed be a lot more then yes or no. And we're going to talk a little bit about that today. So I love the fact that we're hitting on that. I love the fact that Nazish brought up that yes, no, because that's really key. So yeah. Ashish says quantitative outputs, numerical outputs, qualitative outputs is categorical. Categorical output clustering is grouping without any explicit labels. Ooh. Hey, and by the way, guys, please try to not spam the chat. If you give an answer and it appears on your screen, I guarantee you that I see it. It just takes me a while to scroll down, okay? But please don't spam the chat. Okay, so is clustering... So you're saying clustering is always grouping without any explicit labels. Is that true, chat? Is that true? I don't know. I don't know if I'm on board with that last part. But you guys let me know what you think. And we're going to cover some of that a little bit today. Okay. So yes, no indicates binary classification, but we could also have different categories: lung disease, common cold, placebo, etc. Yeah. Yeah, that's good. That's exactly right. So you know what? I love Patrick's last comment there. It's a great segue for us to go into the slides for today. So let's consider this the end of our initial review and kickoff. And now we are into categorization, chapter 4. So everything else, most of the things from here on in, you'll be able to find in chapter 4. I'll tell you when you can't. So I'm going to give you my chapter notes. I'm going to give you a framework example. We're going to walk through a lab, through a coding example, and then I'm going to leave you guys with some self-study. Okay? So, what is categorization? Basically, it's what we just went through in the chat right now. It's talking about how not all measures are quantitative, right? There's a plenty of use cases where you're going to need a number value back, a quantitative value back. But there's also a lot where you don't need a quantitative value. You kind of need a category, right? You need that qualitative output. So last week in chapter 3, we looked at linear regression, which is excellent for qualitative outputs, or at least we saw it being used for quantitative outputs. We saw it being used for quantitative outputs quite a bit last week. But it can also be used for these qualitative outputs, right? So this chapter focuses on logistic regression, linear discriminant analysis, or LDA, and K nearest neighbors, or KNN. Because all of these are valid models for those times when you need qualitative outputs. Okay? So, next question for the chat. What is logistic regression? Think about the conversations we just had in the chat, right? We had some great answers, and we're thinking about qualitative outputs. What is logistic regression? What do you guys think? Why would I be bringing up logistic regression right now after the conversation that we just had? Give you guys a minute to think about that. If you don't know, it's perfectly okay to say I don't know. That helps me too, because it helps me gauge the level. But I want you to kind of just, do this mental exercise to kind of tie these things together. Why am I bringing up logistic regression right now, given the conversation we just had, and given that we're talking about these qualitative outputs, right? What is logistic regression? Okay, so Shantanu says logistic regression is about classification of categorical data. Okay. Give me a little more. You're super close. Give me a little bit more. Take me just one extra step further. Because you're so close, Shantanu. You're so close, but give me just one more extra step. Or anybody else who wants to build on his answer, give me one extra step. Give you guys another few seconds here to think about it. Being says logistic regression is one of the classification algorithms used for categorical distinction outputs. Oh, you're just as close as Shantanu. You're just as close as him. So go one step further. Go one step further. Oh, Mamiya, I love the way you put this. Classification of categorical data based on probabilistic approach. Yeah, I love your mention of the probabilities because that's going to be key for what we're talking about today. But still, give me one step further. One step further. You guys are so close. And there's a lot less participation on this one, so I'm going to assume people, don't quite know what logistic regression, or at least aren't comfortable expressing it, and that's okay. That's okay. We're going to try to change that here in this lesson. But I'll give you guys another 10 seconds here. Oh. Explore the beauty. You're so close. Go one step further. You're so close. All right. Shantanu, yeah, you got the answer in the long run. So good job, Shantanu. Yeah, so I skipped over Rahul's answer because he's giving probably the best answer that I'm seeing here, right? Actually, Rahul and Patrick essentially have the same answer. But yes, the key here is that Rahul mentions the yes or no questions. Or Patrick, calls it the binary questions, binary classification. And that's exactly right. When you hear logistic regression, you should be thinking about binary classifications. 2 classifications, yes or no. Yes or no, true, false, is a member of the class, is not a member of the class, right? So I think it was Mamiya that talked about the probabilities, right? So that's exactly what logistic regression is. And by the way, guys, I started off like this, one, because I think it's a nice tie to, the conversation we had, and kind of understanding the qualitative nature and stuff like that. And somebody had mentioned the previous question about, it can be a yes/no thing, one or the other, right? So that's all on the right track. But another reason I asked this is because, believe it or not, this is a popular interview question. People will ask you, what is the difference between regression and logistic regression? I've had that question in interviews before. I've never asked that question. Perhaps I should work it into my interviews. But I have had that as an interview question before, where they will ask you, what is regression and what is logistic regression and what's the difference? So you should be prepared to know those types of things, and hopefully you will be after this and after so much more study, okay? But that's what you should be thinking about. You should be thinking about, as soon as you hear logistic regression, you should be hearing, okay, I have 2 categories, so this is a binary classification, and I'm going to be receiving a probabilistic answer. Okay, those are the 3 things that should come to you when you think about logistic regression, and that's essentially what I have shown here, right? Sorry, guys, I have to take these camera breaks because I'm sneezing. I apologize for that. But when you're thinking about logistic regression, you should be thinking about binary yes/no decisions. And again, whenever you see quotes, that means I'm pulling direct from the authors. The authors say it models the probability that Y belongs to a particular category, right? A particular binary category, a particular yes/no category. Another way to put it is that you know what class you're looking for. So the answer is, what is the probability that Y belongs in that class? So does this person have cancer? Yes, no. right? Is this person a potential client for our sales? Yes, no. And then the answer might be zero 0.7. And then that gives you a probability that that person does have cancer, or is a potential client, or things like that. Okay? So y equals mx plus b is something that we learned last week, right? And you should always be thinking about y equals mx plus b for the rest of your data science career, because it really explains a lot in data science. How it relates to logistic regression is that over on this side, on the left-hand side of this graph, this is pretty much a standard regression method approach, right? A linear regression approach. The challenge is that linear regression can give you negative values, and it can also give you an unlimited number of values, right? But since we know that we're logistic regression, we're talking about probabilities. I didn't mention this earlier, I'm sorry, but the fourth thing you should think about when somebody tells you it's a logistic problem is that your values are between 0 and 1, because it's a probability, right? It's you'll see how it's a proportion, right? So you should always be thinking of values of 0 and 1. So therefore, a linear approach is not going to work. That's what this, the right side graph shows. That we're going to use an approach that's going to always give us values between 0 and 1, no matter what data we put in. So that's another really key difference between the regression we learned last week and most regression approaches versus logistic regression. We're going to modify our math a little bit so that we're always getting a proportion, a probability of class membership. So in this case, the authors were using a loan company, and the probability of default, which is the y-axis, and then the balance, which is the x-axis. So these numbers is the value of the person's balance, the client's balance, and then this shows their probability of default, right? So this is also a good opportunity for review here. There is a name for what the balance variable is, and there is a name for what the probability of default is, right? Or if you think about this formula, tell me which one is the x and which one is the y. And again, there are proper, data science names for these. They're on the next slide, so before we move to the next slide, let's just take this as a little bit of a touch point, right? What is the name for these variables? So if you're new to data science, this is a good opportunity for you to learn too, right? So what do you guys think? Yeah, Patrick, thanks for handling that. Guys, I push out on as many platforms as I can to let you know that the streams are going, but the best format is on YouTube, because YouTube does give the wide version. Unfortunately, Instagram only gives the vertical. So I understand that on Instagram it may not be convenient. That's why I push out on multiple platforms. So please, switch over to YouTube, as Patrick and other people are suggesting. There's only so much we can do here, guys. It's a limitation of Instagram. So give you guys another minute there. There is a name for the balance variables and the probability of default. How do they fit into this formula? But there's a name for these. I understand this is a little bit of a beginner question, but it's good. We have different levels in the chat, so let me know. Lakshmi, is it Lakshmi Matella or Lakshmi Matella? Lakshmi Matella, I don't think I've seen you in the chat before, but you're coming in strong. You're coming in strong with a perfect answer, right? X is the independent variable and Y is dependent. Perfect answer. That's exactly the answer we were looking for. So good job on that. I've never seen you in the chat before, but coming in hot. Explore the beauty of nature says Y is the response variable, X is the predictor variable. Perfect. That's another way of saying it. Response and predictors, certainly valid. Shantanu, yep, you got it. Patrick, X is the independent variable, balance. Yep, and Y is a dependent, probably the default. That's exactly right. Yeah, perfect. You guys got it spot on. So let's move forward on that. Another thing I want to mention to you guys, super important principle here, guys. Write this one down, okay? You'll note that, as I said earlier, the binary is for the yes, no. You're always going to get a value of 0 and 1, right? You're always going to get a probability that it belongs to a class or not. So in this case, staying with the author's example, it's going to give you a probability of default. Here's the client's account balance, and then we run it through the model, and then this is the probability of default. Like I said earlier, it might give you an answer like 0.7. Now, the challenge with that is that you have to translate that into some business impact. All right, I'm giving you the real world stuff here, guys. This is why this is important. Just because it's 0.7 doesn't mean it's an answer. And you can't just say, well, we'll only take the people that rate as a 1.0, right? Because then you're still missing a lot of people who have pretty high probabilities of default, right? So what ends up happening is you're going to have to set a threshold and say, okay, we think at 0.75, that's way too much higher a probability. That's when we're going to say deny the person, right? Or whatever measures your loan company would take for that. But who says it should be 7.75? Maybe it should be lower. Maybe it should be higher. You don't know that, right? So I'm using this to illustrate that these are the times where your model answer is not the answer that you give to your clients, to your stakeholders, to your colleagues on the business side. This is where the work of interpreting your results takes over. Super important, guys. This right here is what separates the okay data scientist from the great data scientist. Because an okay data scientist, or even a below average data scientist, takes this graph and puts it in a chart and emails it to the stakeholder. Bad, right? A good data scientist goes out and says, okay, I'm going to pick values at 0.6, 0.7, 0.8, 0.9, 1.0. I'm going to look at those balances. I'm going to look at the number of accounts, and then I can come up with projected losses at each one of those levels depending on what the business chooses, right? And then keep in mind that each one of those also has a potential loss in revenue because at those levels you have a different level of clients that are paying, that you are accepting, right? Not just the rejection side, but the ones you are accepting, that's your revenue, right? So I'm kind of taking this little pause to highlight that with you guys, because again, this is where kind of like the real data science separation begins, right? Like the statistics and math nerds just stop at this chart, but the good data scientists take it a step further and say, I'm going to translate this into business results. This is like this is where, like, in my book, I call this the result interpretation or the model interpretation. And this is where that work begins, where you're going to say, hey, I'm just giving you the probabilities, but this is what it means. If you go ahead and install this threshold for when you're going to reject clients, or deny a loan or whatever the case may be, this is what it means for the losses. This is what it means for our revenue, right? So I kind of want to stress that with you because, this is where like that real work of data science begins. You never send these results to the business. You send them your interpretation of those results. All right, so everybody with me? I really hope that sticks with you guys, because that's what separates the below average data scientist to the better data scientist. All right? And then the great data scientist can stand up in front of them and run a whole presentation in front of them, right? That's a whole other skill. But that's really kind of what separates the below average to a really good data scientist, to be able to take these probabilities and make them mean something for the business. All right, you guys with me on this? Give me some feedback in the chat. I love the way you guys answered. I'm loving the participation. You guys are doing fantastic, so let's keep going. But give me some feedback in the chat if that resonates with you. All right, let me go up here. All right. All right, so tell me about this formula. What do you guys see? I see a couple things that are jumping out at me. What do you guys see in this formula? What do you guys see? All right, good. I'm seeing some good feedback in the chat. Okay, it looks like that is resonating with you guys. Well, good. You know, because that, again, that's me giving you that real world insight, right? The books aren't going to tell you to do that, but that's what you learn when you're out in the field. Okay. Okay, so explore the beauty says logistic regression formula. Yeah, but tell me more about it, right? Aren't there a couple things in here that kind of jump out at you? Okay. Patrick and Rahul, you guys, are you guys like copying off each other's work? You guys hit it exactly right. The equation of the line and the exponent, right? Both Patrick and Rahul came up with that answer really at the same time, right? That's exactly right. Look at that exponent. What is it? It's y equals mx plus b, right? As I mentioned to you guys last week, you know, the authors use, you know, the Greek alphabet for this. You know, I learned it in a different way, and I've seen it expressed in the way that I do it. That's why I always stick with y equals mx plus b. But yeah, that's exactly right. They're using the exponent as the formula that we've already seen. So at first look, this can seem a little bit intimidating, but it's just y equals mx plus b used in a different way. Okay? Ashish says it squishes the output between 0 and 1. That's exactly right. That's the second thing you see, right? It creates a proportion, right? This over this means it's a proportion. And you're always going to get a value between 0 and 1. That's exactly right, Ashish. That's the other answer I was looking for. Because then this over here, the output, right, makes sense. Because this represents the probability of x belonging to the binary category, the yes, no, the true, false, the cancer, not cancer, right? So that's what should be jumping out at you, right? Where it's an exponent and it's a proportion. It's a 0 to 1 value. So, yeah, Rahul. Not only was the timing amazing, is that you guys also gave nearly the exact same answer. Right? Like your answer is just like your two answers are variations of each other. That's crazy. Excuse me, guys. I guess I have my allergies acting up or something. Sorry about that. But yeah, you guys are giving fantastic answers. But that's exactly what you want to be thinking about, right? The math can seem a little bit intimidating, you know, when you hear about these, like this different function you have to use for the output and all that. But it's just y equals mx plus b. That's all it is, right? All right, let me go to the next slide. So here we're just reinforcing what we just went over, right? Px is the probability of y belonging to the class. X is the independent variable, as you guys previously correctly identified. We also did the independent variable is x. B is the coefficient, or the first beta 1 is the coefficient, and beta 0 is the intercept. Right? And then down here, I think it was explore the beauty of nature. Yeah, so explore the beauty of nature. I think your answer is more like this, right? Because just like we saw last week, you can also have multiple independent variables, right? You can have multiple independent variables to determine one dependent variable. So yeah, so explore the beauty of nature. You're on the right track, my friend. But yeah, you can have as many x's, as many independent variables as you need. And most of the time you will, right? It's rarely just one, right? But yeah, so I like the way our conversation has tied into this slide, because this really should be kind of connecting some of those thoughts in your mind. All right, let's go on to the next slide. So far, we've talked about qualitative outputs. But what about the inputs? There's going to be times when you're going to have a situation where you need to use a binary value as an input to a model. Not an output, but an input. And is that possible? You guys let me know. I mean, you're kind of seeing it on the screen, right? So let me know what you think of this, and let me know if you can think of a scenario where you would need that. Satya, you can mostly find me on YouTube. That's probably the best platform, but I'm also on LinkedIn and on Twitch. And really all three of those will give you a wider screen format. So Twitch, YouTube, LinkedIn, you can find me on those, Data Science with Dennis, and that'll give you a wider view. So what do you guys think? Are qualitative inputs useful? You want to give me an example of one? Give you guys another minute here. Yeah. Yeah, Rahul's giving a great answer. Yeah, Rahul's giving a great answer. Where you want to predict if a particular demographic feature is responsible for a customer being poor, rich, or whatever outcome. Yep. Yeah, demographic features is one of the ways that this is commonly used for any number of demographics, or maybe regional if you live in certain regions or states or whatever the case may be. So yeah. Yeah, so the answer really is that qualitative inputs are very useful. They're very useful and they're very common. You know, and really, I don't want to single out any industries or any particular business cases because there's so many. You're going to use this virtually in any industry or company that you end up at. Qualitative inputs are very useful, and that's where dummy variables come in. So dummy variables are basically binary values. Are they part of the demographic or of whatever category you want to come with, or are they not? So that's where you see, if you look at the two formulas, the difference between the two formulas is the very end, right? The 1 or the 0. In this case, they're looking at students and their probability of default. So here, the person is a student, or here, the person is not a student. Member of the category, not a member of the category. So a member gets a 1, a non-member gets a 0. Right? So dummy variables and binary values like this are extremely useful. You're gonna use them quite a bit. Qualitative input are useful. For example, which city is someone from? Does logistic regression still work? Yes, it absolutely still works. You're seeing it on the screen. It's the same formula, right? You're still using the y equals mx plus b as an exponential. It just so happens that one of your x's, one of your independent variables, is either a 1 or a 0, no other value. That's the dummy variable part of it, right? That you're saying it's either 1 or 0. It can't be anything else. It's either a member of the class or it's not a member of the class. So yeah, you're seeing it right up on the screen. Same formula. It's an x, right? The x is a 1 or a 0. The independent variable is a 1 or a 0, right? Satya, okay, Satya, nice to see that you made the switch to YouTube. Yeah, guys, I apologize for that. I push out on Instagram because that's where my biggest audience is, but definitely join my YouTube, subscribe, click on the notification. It'll tell you when the class starts, and it'll give you a nice wide format. So glad you made the switch, Satya. Hamad says we have to convert qualitative inputs into binary. Yes. For the regressions that we're doing, yes, you do. That's not always the case, and we're going to talk about times when that's not always the case as far as binary, right? Because there are going to be times when you need more than the binary class, right? But there are times, but yes, but for regression and in the examples that we're talking about, the person, the attribute, whatever, you're either part of the class or you're not. Again, that's the dummy variable part of it, right? But that's what you want to do. Just 1 or 0. That's all I need to know, right? Yep. So Ashish, you're definitely looking ahead there, where you're changing qualitative inputs to quantitative, like one-hot encoding or some other techniques. Yep. And we're going to talk about that a little bit. But yes, you're right. It's not always binary. There are times when you do need more than that. And yeah, I'll hit upon that a little bit, but really that's more of an advanced discussion for another day. But yeah, I'm on board with your statement there, Ashish. Okay, so let's go to the next slide. And this is kind of headed in that direction. Now, Hamad and Ashish, I love your comments because it's a good segue for this next slide here. Okay. What about classification with more than 2 outcomes, right? Because we've already agreed that logistic regression is for that binary output, right? It's the probability of belonging to a class, right? That's what we're going to get from those formulas we saw, right? We agreed that it's a proportionate formula. It's always going to be 0 to 1, but it's really just for 2 classes, right? Here's the probability of these independent variables resulting in being a member of the yes/no class, the true/false, the default, not default, cancer, no cancer, right? But there's plenty of times where you're going to need more than 2 outputs, right? So this is where the authors are putting forth LDA, linear discriminant analysis, right? That's their approach to it. So I want to switch over to the PDF. Give me a second to bring that up. So this is in chapter 4. And this is their linear regression side, or their logistic regression. But I want to skip ahead to their LDA portion, because we've essentially already covered all of this, right? I've taken all of this text, and I've shown you what I think is the most important, right? So that's multiple linear. It should be coming up here. There we go. So now this is where they talk about LDA 4.4 in version 1 of the R book of ISL, right? This is where they talk about having to use multiple classes and the theorems that they use for it. And I like this section of the chapter because they talk about a couple of really relevant things. One, this is one of their really first explanations of confusion matrices, right? This is where they start to introduce confusion matrices. They also start to introduce some of the charting that you're going to use. Not that you're going to show your stakeholders, but the charting that you use internally. So I think this is all really valuable stuff. And I'm kind of scrolling because there's another thing I want to show you here. Bear with me a second. Here. They also have a great explanation of the ROC curve. So I encourage you to read all of this. I encourage you to understand what an ROC curve is. It's one of the questions that I ask in my interviews. I want you to know, I want you in my interviews to give me a really solid theoretical explanation of the ROC curve, What does it show you? What are we talking about when we talk about an ROC curve? That's a question that I ask. If you want to work for me, you got to know the answer to that question. And again, here, really good explanation or a really good start to understand a confusion matrix. Super important. That's another question I ask. What is a confusion matrix? What does it tell you? Right? So I'm pointing this out. Yeah, and by the way, yeah, this is also good here. The errors and the type 1s, type 2 errors, and that's another question I ask. What is a type 1? What is a type 2? What is the difference? Right? Give me a real world example of those. So there's a lot of really good text in this LDA section, and I'm going to encourage you to look at it and look and study it on your own. But I'm not going to have a section on LDA because in practice, in the real world, you are most likely going to use other models for multi-class classification. This is kind of where deep learning starts to come into the equation. So Ashish, we know with your comment and Hamed's comment, right? This is where you start to talk about different encoding methods for those times when you're going to have qualitative inputs with more than binary classes, right? When you have to go beyond those dummy variables we talked about, right? When you start to talk about that, yes, LDA can be used for multiple categories, but in reality, you're probably going to use a neural network, right? For most of these classification problems like this, for multi-class, you're going to need a neural network or some form of deep learning, right? So that's why I didn't really invest the time in an LDA explanation, because from a practical perspective, there's probably other models that you're going to explore that are going to be superior to LDA in a lot of situations, right? So Rahul, the answer is you're most likely going to start with a neural network exploration. Because, and another reason I say that is because when you're talking about these multi-class problems, it's usually not just 3 or 4, right? You're usually talking about something where you have 10 classes or something like that, right? It's going to be something where you have a lot of classes to look at, and when you have that many classes, you're usually going to have a lot of data behind it. So you start using some deep learning approach. Or even, in some cases, you'd be using like an XGBoost approach, right? So, or something else like that, right? Jeremiah says, is it because it's easier to use deep learning than LDA? No, it just tends to be more effective because you're going to have more classes. When you're looking at multi-class categorization, it's rarely just going to be 3 classes, right? 4 classes. It's going to be like 10 classes, 15 classes. I've done models with up to I think 35 classes or 40 classes in one case that I can think of, right? So 40 classes means you're going to have a ton of data. And so it becomes a deep learning problem at that point. So just from like I say, but in practice, right here in my notes, like as a practical perspective, right, you're gonna be saying, okay, let me start looking at some deep learning. Let me start bringing in some bigger models. Let me start going to a GPU instead of a CPU, right? I mean, it's kind of a step up, right, in all respects. So that's why I'm telling you guys, read the LDA section. There's great discussion in ROC curves on the confusion matrices, great explanations. But from a practical perspective, I don't want to invest more time in this because I just don't think it'll be worth the time here, given that you're mostly be going into deep learning techniques when you're really talking about multi-class approaches. So again, this is me curating the chapters, right? This is me saying, yeah, you're going to need that. Maybe you don't need this so much. So I'm thinking that LDA, you're going to be using other approaches instead. Okay. Rahul says, what kind of deep learning are we talking about? It depends, Rahul. It depends on the problem. It depends on how much data you have, how many independent variables you're going to have, right? I'm just saying that you most likely would not be using LDA, right? And again, we don't want to get caught up in saying, well, I'm always going to use a neural network. I'm always going to use a CNN or whatever the case may be, right? I'm not saying you should always be like that narrow. I'm just saying that this is where LDA is kind of put to the side and other approaches are explored because it most likely becomes a deep learning problem at that point. That's all I'm saying, okay? So I want to leave you guys with that because, LDA, is good, and it's good for study, academic stuff. But there's deep learning is usually where comes into the picture when you're talking about these big multi-class problems. All right. Yeah, Jeremiah. So neural network can be one of the ways, but it can be in any number of things, right? The point is that it probably won't be LDA. All right. So let's move on here, because now we can talk about the second model that's introduced, and it's K nearest neighbors, KNNs. And I'm also going to kick off by telling you to not confuse it with K-means. So I know a lot of you read the chapter ahead of time, and if you didn't, that's okay. But does anybody want to volunteer their understanding, their elevator pitch for what KNN is? And if you're feeling brave, tell me about K-means also, or pick one of those. Pick one, pick both, whatever you're comfortable with. Or maybe you're not comfortable at all. You can just sit back. That's okay. But does anybody want to volunteer to tell me about nearest neighbors or K-means? I'll give you guys a minute here on that. What do you guys think? Maybe we've taken a step up in the level of complexity here. That's why I'm getting less answers. Okay, Lakshmi volunteers. It is used for both classification and regression. Okay. Okay, Lakshmi. Patrick says KNN is using nearby points to test our points to assign a class. Yep, I'm on board with that. Anybody else, or anybody want to try K-means? Explore the Beauty of Nature says KNN is classification, means, and observation is likely to have similar values as values of its immediate neighbors. Okay, I like that explanation. Jeremiah says for KNN, if I am not wrong, we would have a test point which we try to observe which are the points that are nearest to the test points. I'm not sure if I get what you're trying to say there. Rahul says these are clustering approaches. KNN uses the distance between all nearest points, where K-means uses the mean distance, I guess. Ooh, Rahul, I love that you took a stab at K-means. I'm not sure if I'm on board with your K-means explanation. There's a key difference for K-means, though, right? So help me find that key difference. Oh, okay. Patrick already found it. And actually, it ties to Hamed's answer, too. K-means is an unsupervised algorithm for clustering data in a natural way. That's exactly right. When you hear K-means, you should mostly be hearing unsupervised approaches. And Hamad says KNN is supervised machine learning model used to overcome the problems of classification and regression. Yeah, Hamad, that's a great answer. But yeah, both of you hit it right on the head. KNN, generally speaking, is a supervised approach. K-means is an unsupervised approach, right? So what Satya says K-means is based on the calculation of square mean of individual points, and a linear line is drawn with the lowest squared error. I don't know. I don't know, chat. Is Satya right on that? I hope I'm understanding your explanation correctly. I'm not sure if I'm 100% with it, though. Tungamac, welcome to the chat. I don't think I've seen you before. Prediction based on nearest attributes from a set of data. Yeah. Yeah, nice answer. I like that answer a lot. That answer will work. Lakshmi says it uses Euclidean distance to measure the proximity between data points. Yeah. Yeah, in a way. Underneath the hood, it is doing that. Yeah. But yeah, you know, I want to come back and highlight Patrick's answer and Hamed's answer because both of them are sharing some key points, right? KNN is supervised. It helps you overcome the problems of classification and regression because it is a way you can use for multiple classes, right? And then Patrick also talks about how k-means is unsupervised, and he also mentions the key of clustering, right? It's a clustering approach. Well, excuse me, both of these KNN are clustering approaches, and that's kind of what you should be hearing in your mind, that it's a clustering approach, right? Clustering is very key in a lot of problems, right? Because again, not everything has a quantitative output. You're going to have qualitative outputs also, right? So that's what KNN helps you with, right? She says K equals 3 as an example. We find the 3 nearest neighbor points to our test point, and then we categorize our test point. Yeah. So, by the way, I make a mention here too that unfortunately I'm not on board with the way the authors wrote this because KNN is actually mentioned in chapter 2. It's only briefly referenced in chapter 3, even though they give you lab exercises in chapter 3, not chapter 2. So it's kind of out of sequence. It's a little messy, you know? So I will ask you to refer to chapter 2 for KNN. And this is one of the charts from chapter 2, and it's a good segue from all of the answers that we've had so far, right? Because this is showing KNN. This is showing clustering methods. So what you should be seeing is that both of these charts have the same dots, right? The dots are in the same locations, right? The difference is how many clusters you're using for your dots. So here we can see that the algorithm has determined 2 clusters, or excuse me, 2 categories, and then it has the different clusters of where it's putting each one of those members. On top of that, you can also see the correlation of members of each cluster to each other. So for example, let's hone in on this one here, this one here in the lower quadrant, lower left-hand side of this chart. You can see that it actually belongs to the blue class. But how close is it to the other ones? It's not, right? And that's why, even though it's part of the blue class, it actually sits in the orange class. And it sits just outside of the blue class. But it's also very far away from the other class members. Over here, you have 2 class members that are very close to one another. But then you also have this orange member that's still within the orange, but still kind of close to the blue, right? So it's like orange but leaning blue. Or there's this one here that's literally on the border between the 2. But it's still labeled as being part of the orange cluster. I'm highlighting this because, again, this is important for that business translation of how you will actually talk about these things to your business stakeholders, right? You're going to be talking about these things in terms of why these clusters share, these items, these members share the same attributes. Why are they orange? And why are they so close to each other? Very, very important skill as far as being able to translate your results. So, I couldn't find a chart that's a good example of this, right? But let's pretend that right here in this corner, I have a member, and we'll say for the moment, it's neither orange nor blue. We'll just say that it's a purple color, and it sits right here in this corner. It sits really far from the blue clusters, and even though it's in the orange cluster, it sits really far from any of the orange members. What's the name for that? What would you call that? Or why is it important to think about those types of members that sit? Why is it important to think about a member that sits in a corner like that? I'll give you guys a minute to think about that. Ooh, if you guys are fast on this one. Fast, fast, fast. Explore the beauty of nature, you got it. It's an outlier. Right? That's why you want to take the time sometimes to plot this out. Or to think about those values, right? Because you're going to assign values too. To think about those values. But yeah, that's an outlier, right? That's super key to be able to acknowledge in your items, right? To be able to say, yeah, I was able to plot this, but it sits way off in the corner. It's not near any other members. It's an outlier. Or in some cases, and I want to come back to, Lakshmi, it can also be an anomaly. Sure, it can be anomalous data. But keep in mind, though, in a lot of these cases, we're talking about qualitative data, right? Qualitative data is often not always an anomaly, right? So, coming back to Servan's question, another way to also look at this for your outliers, for these items that sit in the corner, nowhere near any of the other members, you know what else it means? It might indicate a need for a new class. Maybe you need more than the classes that you have. So yeah, it's an outlier, but what are you going to do about it? Well, maybe you need to introduce a new class. So Servan, I like your question. Hey Dennis, any real-time example from your experience? Yeah. I'll give you a really interesting example that I actually created this project and we actually ran with it. I love this project. So I want to keep things generic because I want to protect my clients. But a lot of clients that you're going to run into, a lot of projects, are going to be concerned with how you are addressing policies and laws that are out there, right? So you want to make sure that you're always addressing policies and laws, because the policies and laws that you don't cover are what are known as an emerging risk, right? That's the business term for it. Because if you can say these are the 10 laws and this is how I'm covering those 10 laws, anything that falls outside of those laws is a risk to you, right? Because that's something where you could be potentially breaking the law. So I was approached by a client that wanted to identify emerging risks. And a clustering approach, very similar to what you're seeing on your screen, it is what we created for them, right? Because if you want to think about this as another way, guys, another way I think about this and the way I explain it to my clients is that this is a big filter, right? A clustering approach is a big filter. I'm going to create a really solid model that can take your data and filter it into these categories really quickly. It's almost like one of those in the US we call it like a colander or a sieve, something where like you would drain your spaghetti, right? You put your spaghetti in the top and all the water comes out, right? So it's a big filter, a big sieve in that way, right?